So, hello, good morning.
And good afternoon or good night, depending where
Good
you are.
night almost. So, we've been running now for about, I don't know, is it 9 hours? More than 9 hours.
At least, yeah. We started at 12. New Zealand is 9:20.
Yeah, look at that. Yeah. And I joined late last night. For me, it was 12. And I went to bed probably at 1ish. So, had an early morning this morning. And we're continuing with the next sessions. Welcome to the Global Integration Bootcamp. This time it's virtual.
2021.
It's the 5th year already. We've been doing this since 2016 or 17. I don't recall it actually. What's
Yeah,
5
it was
years?
like 2016. We have the idea because of there was like a really cool beach talk bootcamp in Redmond, and then we get everything organized. All of a sudden, 2017, we have 15 locations throughout the world. So it's really good.
And yeah, it was always a hands-on event basically. But since COVID hit the entire world, almost the entire world, some countries are denying it, but we have to do it online. And during the night, Bill and Wagner, I don't know if Martin dropped in, they have been running during the night together with Tom in the Americas. Doing all the sessions during the night, presenting and basically just talking all the sessions in between. And for EMEA, Stevion already did an Apex session, the last Apex session this morning. Yep. I just got a glimpse of it when I woke up. Aldert is with 1T, by the way. He is running the Scottish event today, so he will probably not be joining, maybe on Discord. Sven also has something else to do, but it's mainly me and Stevion running the things during the EMEA time zone.
Yeah, I'm here as a special guest, and then I'm going to disappear to have some shut eye soon.
Exactly. Yeah, it's time. Now it's your time. Your turn. We have a small code of conduct, so we're running on Slack, YouTube, and Twitch. So please join in the discussions, but always be considerate and respectful, of course. If you're considerate and respectful, I can go through the next two ones, but that shouldn't be possible if you're considerate and respectful. So please refrain from demeaning, discriminatory, racial, harassing, etc. But I don't think any of our community will have problems with that. At the end of each session, you can ask your questions. You can drop them in our Discord. That's maybe the easiest. And YouTube and Twitch are also coming in our stream, so it's also possible to ask some questions there. If you're on Discord, people will always be able to just jump in and answer your question over there with some extra links, etc.
Mm-hmm. And if you're interested, or for some reason we wanted to put the comments on YouTube or Twitch, just like I ping it here, we'll be able to push it into the stream and ask the presenter to present. In the meantime, just a reminder, join us on Discord.
And that's the slide deck. We'll have a short introduction by John Fancy. Probably runs for 10 minutes. And after that, Ambash will be joining the stream for the first session about logic apps. Top 10 tips about logic apps.
Okay, so I'll push the John's introduction now.
Sure. If you have it ready.
Hi, I'm John Fancy. Welcome to Global Integration Bootcamp 2021. This is the 5th year, I think, that the Integration Bootcamp's been running, starting back in 2017. Things are a little different this year for all of us. I think this week marks the week when I stopped traveling, so haven't seen an aeroplane for a year, but hopeful that things will improve this year and maybe we'll get back together again before too long. it's great to talk at this event. We've been strong supporters of it from the beginning, and honestly, strong supporters of you in enabling you to use Microsoft as your integration platform of choice. A great 24 hours of sessions running continuously across multiple time zones. So, I encourage you to kind of dig in and discover and learn in terms of what we can do. Azure Integration Services is really our integrated cloud platform. This is built on top of Azure, bringing the best of Azure together into an integrated suite of capabilities. Things like Logic Apps for orchestration, for workflow, automation, pretty much anything where you want to be able to connect to all the different data sources and applications that you have, and being able to put it all together into a holistic platform. And it doesn't do that alone. It does that through over 400 connectors that we provide, everything from B2B to EDI, business-to-business protocols, to on-premises application integration, to web services, and a whole bunch of other things as well. And it does that with the other things that you see on this slide as part of Azure Integration Services. Event Grid for being able to do event-driven invocation, as well as functions for being able to augment those integration solutions with code, maybe taking existing libraries that you have and being able to connect it all together, being able to leverage the assets that you have already. Things like Service Bus for doing pub/sub at scale, being able to send and receive data over messaging is a very powerful paradigm for doing cross-platform integration. And then we have API management for being able to not just consume existing APIs that you can publish in your organization, but being able to actually publish out from functions, from Logic Apps, and from other assets that we have in Azure as APIs into API management to make it super easy to build an API-driven approach to integration, to make those APIs kind of platform agnostic, standards-based, and easy to integrate across not just Azure, but also the Power Platform and beyond as well. And then finally, we have Data Factory as a way of being able to do massive data ingestion and processing through a pipeline-based approach to getting data into things like Azure Data Lake and other offerings that we have for analytics, giving you the ability to do ETL and ELT patterns in the cloud with Azure Integration Services as well. And, I'll just finish here by just talking about the team ethos is that integration really is everything to us. Everything comes back in terms of the way you build modern applications today, in terms of how they're going to connect, not just to each other, but also to people to build experiences around the data, around the usage of those applications and the functionality that they consist of, in easy, as friction-free way as possible. So traditionally, this has covered application-to-application integration and business-to-business, those EDI protocols I mentioned. But increasingly, this is about SaaS-based integration and API-based integration, led by the SaaS movement, where everything is an API. And then you have IoT being able to connect devices, sensors, and other machinery in the field into your integration platform, and being able to run components of that integration platform where they make most sense. Logic Apps Anywhere, the new runtime that runs on top of Azure Functions, is a great example of this, where you can actually push those workflows to the edge now and actually run them against data as it's being emitted, being produced, and then pushed up to the cloud through the connectors that we have in Logic Apps. And then data analytics, you can't do anything without data. Between every good application is a great data store, and applications become richer through easier integration with the data that is powering them, and being able to share that data across application experiences where you really see it as a borderless viewpoint when you look at applications in this way that don't kind of start and end. They just cross-cut different personas and different experiences across your organizations and across your customers as well. And that brings into focus people and processes. That really integration isn't just about those traditional system-to-system based integration, but about how you integrate with people as well, human workflow processing, how you do automation, how you can actually empower users and other folks inside your organizations who may be outside of IT to be able to build their own integration solutions, automate their own tasks to improve their productivity, improve the visibility over the business that they're running. And that includes things like RPA, robotic process automation, as well as things like automation tasks in the Azure portal, a new Logic Apps feature that we launched a few months ago, allowing you to take any Azure resource that you have and actually automate actions against it. For example, starting and stopping VMs on a particular schedule. So arguably the most visual component of Azure Integration Services is Logic Apps. Hopefully some of you have already seen the investments we've been making over the last 12 months or so since Ignite, when we released this in public preview. So I just wanted to touch on this a bit now in terms of what we've been doing, because I know some of the sessions today will cover this in detail and why it's so important and significant for us. Logic Apps is really the centerpiece of Azure Integration Services, our integration platform as a service, our iPaaS. It provides the visual componentry, the no-code metaphor for being able to build integration solutions with the full power of Azure behind it. All the other components of Azure Integration Services, particularly things like functions, being able to be integrated right there with Logic Apps running on top and hosted by the function runtime, gives enormous power to developers and integration specialists to be able to seamlessly transition between code and no-code workflows. Being able to have the gestures of being able to write code in Visual Studio Code and then being able to integrate that quickly and easily into your Logic Apps, being able to debug those Logic Apps and setting breakpoints, we think is very powerful and a real accelerant and productivity boost for developers to be able to build more complex and more sophisticated integration solutions. We've done a whole bunch of work around the runtime to produce additional flexibility, the containerization elements of the runtime, being able to run on Docker, being able to run in Kubernetes, and even, we see some customers today running on top of AKS as well, with the functions runtime right there as well, being able to have a full feature-rich set of capabilities in Azure Integration Services. The new designer is another big investment that we've made that we continue to push on the boundaries of what's possible, particularly in a web browser, to give a much more sophisticated layout engine, to give better rendering of more complex Logic Apps, and much more to come on that in terms of editing experiences. As well as that, we've really focused on that sort of local dev inner loop. Dev, test, and DevOps have been critical for a lot of our customers so far in their journey with Logic Apps and Azure Integration Services. But of course, we're conscious as a EU that as solutions become more complex and as organizations use more of it, create more resources so they can introduce complexities around management and the challenges there. So DevOps and testability are key themes that we're working on right now. As we march towards general availability for the new Logic Apps runtime, you'll see some improvements coming in the DevOps space and being able to fully automate from GitHub all the way through to your production environments, parameterization of the individual settings that may differ between the different environments as you go from dev through staging to production. A whole bunch of good stuff coming down the line. So again, I encourage you, if you haven't already tried the new runtime, to try it out. It is pretty interesting in terms of not just the technical aspects of it, but also how we're changing the business model away from having a action-based model for built-in actions to a compute-based model, which can be very attractive at high scale and high usage as well as the performance improvements we have with stateless workflows with no storage dependency anymore, allowing you to achieve lower latency, particularly for request and response scenarios. So the full breadth of Azure Integration Services is really pretty big. It spans, as I mentioned, not just kind of Azure itself and bringing all of the Azure together into a set of connectors that's easy to consume and easy to build integration solutions against, but also across to the Power Platform with things like Power Automate, using the same set of connectors, but driving different experiences that are optimized for the different users that we see across the entirety of Microsoft. Power Automate is integrated with Dynamics, integrated with Office 365 and Teams, giving you full capabilities within these individual products and applications to be able to build personal automation. But then branching out into Azure and using and leveraging the full power that Azure provides you. And the Data Factory, or optimized for data integrators and data scientists, give you this suite of capabilities that's quick to learn, easy to use, and fast to scale up to meet the growing demands of your business. So I encourage you today to jump in, enjoy the sessions like I will be, as well as some great speakers and some great content today. And as always, we're here to answer your questions and help out at every step of your journey as you look to move and run on top of Azure. Thank you. Bye-bye.
So that was John with some good words about the whole Microsoft integration story, which is developing more and more into a whole complete system. So that's good to hear. They are also moving to the CI/CD stuff in a better way. Next up is Ambash. He's from Germany. I'm not too far from Germany, about 300 meters. So always good to have a neighbor here. Where are you from, Ambash?
Thank you, Rob. So basically, I'm from Berlin right now.
That's
So
the other
yeah,
side.
yeah, it's totally other side. Probably, yeah, exactly not 300 meters or something, but
No.
definitely too far from there.
Yeah, cool. And you're going to talk about our top 10 tips for Azure Logic apps. You worked a lot with Logic apps already?
Yes, exactly. Yeah,
Cool.
exactly. So basically, like whatever I just learned throughout the implementation journey, I would like to share. So the people who are gonna implement, who are planning to implement the integration via Logic apps, so they just consider those points. And it's also just include a brief about the fundamentals also. So the people who are not very involved into the Logic app and they need to get a fresh start with that, so they could also understand. So it's not directly with the L400, but definitely like the people who don't have much understanding about that. So there's a initial fundamental breakouts for those two.
Cool. It's a pre-recorded session, so I'm going to start it now. This is new for me. Let's hope it all works. And afterwards, you will be available for some questions until the next one drops in, right?
Yeah, sure.
Perfect. I need to the stream. And there we go.
Hello everyone. Welcome to the Global Integration Bootcamp today. A very good morning from Germany, afternoon and evening based on your location from where you are watching this session. I would like to say great thanks to the Global Integration organizers here to execute the 24-hour long lasting event in a successful way. I will try my level best to make the session interactive and alive, so please bear me for the next 40 to 45 minutes. I hope by the end of your basis 40 minutes, you will be confident enough to build, use, and implement Azure Logic apps for your customer or for your own organization in more prominent way to get the best return for your investment. I would like to briefly introduce myself here, and then I will start with the agenda for the session. My name is Ambesh Singh, currently working with KPMG Deutschland as a Dynamic 365 architect and a technical manager within Microsoft practice. Prior that, I worked with Pearson VUE and EX Sports, and mostly in my career, I worked with Microsoft in different product groups, global consulting, and deliveries. I'm also mentor and ambassador of 365 Saturdays and speaking on Azure, Dynamic 365, and Power Platform technologies on different global platforms. Let's see the high level of agenda for today. I will do my best to cover as much as from the topic mentioned here and as well as the topic outside from the list. So we will cover a brief about Azure Logic App ecosystem, how and where to build, bonus tips from my learning in Azure Logic Apps implementation journey, and so on, followed by the Q&A. Let's start it. What is Azure Logic Apps? So as per the Microsoft, Logic App is a cloud service that help you to schedule, automate, and orchestrate tasks, business process, and the workflows when you need to integrate apps, data system, and service across enterprise or organizations. The next question is why? You don't have to worry about building, hosting, scaling, managing, maintaining, and monitoring your apps. Logic App handle this all the concerns for you. Plus, you only pay for what you use based on your consumption model. How Logic App works? Every Logic App workflow starts with a trigger which fires when a specific event happens or when a new data meet to the specific criteria. We will see in more details in the coming slide. And the most important thing, where to start from. You can build your Logic App visually with the Logic App Designer, which is available in the Azure portal through your browsers and in Visual Studio. Honestly, I haven't used Visual Studio or Visual Studio Code to build the Logic App, but you can do just in case if you need. For me, build app over the Logic App Designer is much more easier, convenient, and cleaner. But let's have a quick look at how it's look like on a Visual Studio Code. So I just open a Visual Studio Code here. You could do on the Visual Studio itself. And what you need to do, the first thing you need to go to the extension, you need to install the Logic App as a Logic App. And then after that, you need to make a connection on that one. So you already made a connection. So you need to just provide your credential and it will be connected. And then you, based on your subscription, the resource model will be there. And then you can select any of your logic app, the existing one. If you want to create the new one, you just need to click it, create logic app button. And then you need to give a resource name. If you want to create the new one, you could create it from here. If you have a proper proper permissions for that one, you could definitely go and create it from here. If not, then you could use the existing one. So suppose I just use the existing one, then you need to select the location for your resources. I selected that one, and then you need to just give a logic app name by which you want to create it. If you want to update the existing one, you could go and simply update any of this existing logic app from there. So you could open in a designer, an example here. So it will open the logic app in a designer window. Just give some second to it, and then you can make the changes accordingly. Let's go back to the slide again. So basically we have two pricing models, pay as you use and the fixed cost. So the first one is the consumption pricing model that run in a public all the global Azure Logic App services. You pay only for what you use it. In your Logic App, each step is an action, and Azure Logic App meters all the action that you run in your Logic App. So basically it's a CapEx model. It probably the operation expenditure model. The CapEx model will come as a fixed pricing model. So it's an integration service environment that provide a private, isolated, and dedicated way for you to create and run logic apps that can access resources in Azure Virtual Network. That for this, the logic app that run inside an IAC, you need to pay a fixed monthly prices. So it's capital expenditure, and it's a CapEx model in that case. So you need to just consider that all the action that get skipped due to unmet conditions, you don't have to pay for that one, and all actions that don't run because of the logic app stopped before that because of some error or the exception, or maybe for some other reasons. So you also don't need to pay for that one. But please remember, if you are using any action that run inside the loop, as your logic app count each action for each cycle in a loop. So if you have a 10 actions inside the loop and you just run it for like 10 times, then it will be the 100 actions metered, and you need to pay the cost for that one. And regarding the pricing details, so every time logic app definition run the trigger action or the connector executors that are metered. For actions, you need to pay that is 0.00022 euros. For the standard connectors, you need to pay around 0.000106 euros. And then for the enterprise connectors, it is a bit costly, but again, like it's 0.000844 euros. Apart from that, you need to pay for the data retention also, which is 0.11 GB per month. So 0.11 euros per GB per month. So it's not quite expensive, but you need to plan everything in advance, that okay, what you are gonna do this, you need to calculate everything, and then you can use the Azure calculators for that one, like price calculators. You need to find out the cost in more advance in a planning stage. Now, the next thing is the trigger, like from where the logic apps start. But before that, I would like to show you to show all this stuff in the system. So let's go into the system, and I would like to show you. So the first entry point where you need to go is the portal.azure.com. So suppose you are on the portal.azure.com is the home page. You could go to your resource group. In the particular resource group, you can start by creating like if you need to create the new logic app, you can just go add, like click on the add, type the logic apps. It will be in a list, and then you can create it from here if you have a contributor permission. The second thing is that, like if it is already there, you could directly go and open it. So an example, I'm just gonna open the test logic app, which I have already created. So it's look like this. And then you can just see all of the stuff from here. Like an example, I would like to show some basic stuff. So you have a top pin here, and it has some of the buttons to execute. Like you can run the trigger and just validate if something is already in the pool. You can refresh it. You can make the edit, and then it will open the Logic App Designer. You can delete or disable it from here. You can update the schema too. You can clone it and export it. So this is more and less tool available on the top pane. Then on the left plate, like you have an overview about the logic app, that okay, in last example, what is the definition for? So it has one trigger, it has 31 action inside that one, and the status is enabled. So if it is disabled, you will see the updated stuff here. Like last 24 hours, how much it ran. So it's successful, and 2 failed runs were there. What subscription you are choosing, what resource group you are choosing, you could change it definitely. And then you have a subscription ID for that one. Then in the summary, you could see that, okay, basically, what is the trigger point? So it's a SharePoint online when the item is created, and the frequency is for like it will run on every 500 days. And then you have an evaluation that, okay, in like it's evaluated 76 times, and it fired 8 times in last 24 hours. So you can see the trigger history for that one also. Then it will show again like how many actions you have. You could check it from there, or you could check it the actions from the definition also. From the other portions or other part of the left pane blades. So you have a Logic App Designer. You could go and view the code also. You could check the different versions on which you have already worked. Workflow setting is one of the important aspect. The other things is related with your security stuff. The monitoring portions or the monitoring tab is there. So you could get a lot of monitoring stuff from there. Like you could make an alerts, you could see the metrics, you could enable and then configure the log system. There's a diagnosis settings. Something is come for the preview, like you could export template, and then automation is available there. Automation for the task is available there. So it is in the preview mode. You could utilize that one for sure. You have a support there from the Microsoft if you just need to raise a new support ticket for that. And then you have few things like which is out of, like you could tag it. You have a access control here, integrated access, like integrated access management, and then you have a diagnosis. How if it is there any problem, then you could just see it. It's mostly like kind of the part. So this is on the left pane. Apart from that, I would show quickly the logic app which I have already built for. So how it's look like inside the system. So every block you are seeing, it's an action here. The first one is a trigger. You could put the comment inside that one. So you could put the comment inside, and it will be very helpful if you have a lot of step inside that one. You don't need to go very deep into that one to check, okay, what is happening inside, especially in the loops and scope blocks. So you could get all the insight directly via the comments. And it's really important for the other developer also to analyze, okay, what is happening actually in those actions. And then you have a connector. So like an example, if I just connected with a SharePoint, if I connect, so there are, I think more than 300 connectors are already available. And apart from that, you could create the custom connectors also. And the most important aspect here that like these connectors, as I mentioned, like you have a standard connectors and then price connectors. So the pricing will be the different. We need to choose very wisely. The next, another important aspect is like the triggers, which I would like to show. So I would just quickly go there and open the blank one. And in this particular scenario, if I would like to show you, just give a second, like you have already some of the common trigger available, then you have tons of the template. Like if you need to use the existing template, which is available out of box in the logic apps, you could utilize that one. Example, I'm just gonna use a template for the blank logic app, or maybe when the HTTP request and response related stuff. But just let's start with when HTTP request is received. So I'm using a predefined trigger. The moment I will save this request, it will generate a URL for that one. So just let's do it. So the URL is already there. I would like to show how the URL look like. So the URL contain basically like all of your details inside that one. And the most important thing is these keys, which generally use for the authentication purpose, which is again, really important aspect to look into that one. And then let's go back to the slide and we will come again there in very soon. So basically like I just explained you regarding the trigger which use the HTTP endpoints. And in that case, Logic App are great, but exposing them as a publicly available HTTP service is clearly far from the perfect. So we will see that how to solve the challenges by using built-in offering or the API management service, which will be used to secure the Logic App HTTP endpoints with OCP APIM subscription keys, or the other ways like as an Open Compute project application management, application interface management, basically. So let's go and see that one. So basically like we can, there are the multiple options to do that one. Like you could pass the authentication key from the request header. And you could validate in your Logic App. The second thing, like you can store the which is really important. You have to make a practice that if you are storing any of the secrets or the password, that you have to use the Azure Key Vault for that, because for that purpose, Azure Key Vault was introduced by the Microsoft to just secure all the credentials and the secrets. You could secure the input and output in the runs also. So an example. Anybody is having access to watch the run history, so they could not see any credential what you already passed or what is going inside and outside via on the Logic App run. An example, I just opened this one and just let it load. So I go to the HTTP call, and here you see the input, like what I'm passing in the input, what I'm getting back from there. So everything I can see it. The option is like you could go to the designer and you could basically secure your input and output, go to the setting. And here you have an option like secure input and output. So the moment you will do this, you will not be able to see any inputs and output what is passing throughout that particular action. So we will go with the like SIG or the shared access signatures. We will see the IP restriction access control, which is IAM, and API management very soon. So as you see in the like over the screen, there is an SIG key available with every Logic App. You could generate it, the primary key and the secondary key too. Like if you already shared it and then you want to block or you want to change it, basically you could definitely go to the Logic App portal and you could regenerate it to just change it. This is probably not a very secure way, because if anybody have this URL, they will definitely have these keys, and then they could use the Postman and some other tools to automate it or to make a hit on your Logic App and to push the data or to fetch the data from your actions, which is already available there. So the second option is like you could definitely use the access control, your identity and access management, which is IAM for the internal users, like who should have the access or not, who should not have the access. So everything you could manage it from there. The third important thing, like you could just whitelist or the blacklist of the IPs. And apart from, you could also use the child Logic Apps into that one. So an example, you created one Logic App and you just restricted, okay, this Logic App can be used only via the other Logic App as a child Logic App. So you could make this changes and then your Logic App will be secure, because then in that case, it will be only accessed via your environment. The second option is like you could, as I mentioned, you could blacklist or the whitelist of the IP ranges for that one. So if you want to just give a specific range, it will be access only those specific IP ranges. So that is another way to somehow secure it. The API management, like for this, you need to use another service of the Azure. It is a bit costly in my view, but it's worth to have that one day, not to secure and put a lot of security stack on that one, but also to just comfortably work with different versions. So it's also worth to have a look for that one. Now I would like to talk about the limitation and the configuration limitations for the Azure Logic App, and we should be really aware about this before modeling the Logic App. So like an example, I will not go through each and every point, it's already there. We can pause and see that. But like an example, we could use maximum 500 actions per Logic App or the per workflow. We can go till 8 level of the depths. If we are going with the nestings, we could use 250 variables for that one. Apart from that, like more variables, if we will declare, we won't be able to do this, and we will get the errors. Switch case scopes we could use till 25, which including the default one also. Apart from that, if we need more, then we somehow need to plan accordingly, and we need to bifurcate into that one. Characters per expression, we could use 8,192. The name or for the action or the trigger, we could not, like we should not go beyond 80 characters. The same is length for the description is 256. Maximum we could pass the 50 parameters, and then output could be the 10 one. But definitely you could extend that limit by creating your nested workflow if your requirement is really like that you need more actions, more variables. You could definitely create a nested workflows as a parent and the child Logic App. Technically, there is no as such difference into that one regarding the functionality and the behavior. It's just way of like synchronize and just model your Logic Apps workflows. Another important aspect, like the run duration with in the multi-tenant environment, is the 90 days, which is but at the same time, like for the ISA environment, it's 365 days. And the same is for the storage retention also. The minimum recurrence is 1 second, and the maximum interval is the 500 days. Let me just quickly show this as well, like what does it mean? So an example, if I would like to just make it as a 501, it will not allow me. I could show you 501 days. The moment I will do this, I should get an error there. So this is something you need to consider. The minimum you could go for the 1 second, not before that. So it's basically like how often the Logic App will check the items from the queues. Definitely you could extend the limit. If you really need it, you need to justify via dropping an email to the Logic Apps email at @microsoft.com. You could discuss with the product team, and then they probably increase the limits for you or decrease it accordingly to your requirement. Then also for the retry attempts, like we need to consider that in the multi-talent, it's a 90 days. The default is a 4. But definitely we could change it. The maximum delay is 1 day, and the minimum delay is 5 seconds. So this is also we need to consider when we are creating or accumulating the Logic Apps. Basically, the steps where you make the HTTP calls, where you're connecting with some of the, like an example, SQL or the Oracle database. So there we could definitely use this kind of retry attempts functionality. So it will be really helpful in that case. Then the number of custom connectors in multi-tenant like environment is 1000, and it's the same for the ISE also. But the other aspect, like if you are creating the custom connectors, then please note that you could do the 500 requests per minute per connection. You can't go beyond those limits, which is like for ISE environment, it's 2000 requests per minute per custom connector. So this also you need to consider, like if you're really going with a lot of like some data upload or frequent changes which will trigger it, then it may cause some abortion for the Logic App runs. Now, I would like to talk quickly about some bonus tips and top tricks. So the first one is we need to really understand what is the impact for the disabling and deleting the Logic App. So if you disable it, yes, you could re-enable it, but we just need to make it sure the moment you disable it and you enable back, the pool is already running for that one. So if there is something happen in duration of like disabling and enabling, the moment you will enable, the pool will like pick up all the values from there and it will execute it. At the same time, if you really don't want to use the logic app, you could download the template or somewhere, store it, put it in the CI/CD pipeline, and then you just need to delete it, because even if it is in a disabled state, still you are paying the cost for that one. Definitely not for compute, but for the storage and the other things. So you need to just keep this this stuff in mind before any decision. Naming convention is really important for the logic app. So an example, if the name is for each loop 1, 2, 3, 4, it doesn't make any sense. So I could quickly show that what does it mean for. So if you are putting any name here, so initialize variable 1, variable 2, variable 3, which doesn't make any sense. Maybe even for you as well, if you're even developing the logic app, after a couple of minutes or the hours, you will be lost that, okay, what this action are doing. So you need to be very, very careful for that one while naming any of the action or putting any of the labels into that one, like either it's a variable, even the logic app name also, the loops names or anything, any naming convention need to be considered like other programming languages. Then you should, like, there is a thing like, should we use the local variable or the global variable? So there is no local variable in the logic app. You need to declare at the root level and then you will reuse it. The maximum you could reset it, but you basically you won't be able to declare any variable inside of any of the scopes or any actions, like a for each loop or something. So you need to declare at any variable at the root level only. There is no local variable for that, and you need to be really wise while using the local variable again and again in a different steps. A benefit of the clone functionality is really, really impactful. So I mean to say, like, if I just go to the source group, sorry, test group, okay, don't want to save. And here's the clone functionality. So I created one for maybe my dev environment. I just need to put for the UIT. I could give the name here, and then I would select that the status for that one. Ideally, whenever you create it, always recommended you create it as a disabled state. And then after making some connection changes for the UIT, because definitely the environment or the connector will get changed. So then you change it, and then you could just enable it from the logic app overview itself. So this is again important aspect. And after that, like timeout property is really important. I can show this quickly to you as well. So suppose I have a HTTP call here. Just go to the edit quickly, and you don't want that your logic app is stuck for and like on any action for so long. So what does it mean? If I can go, there will be a 3 dot for any action. Go to the setting then, and here you will have the timeout property for that one. I already explained regarding the limits for that one. So you could actually utilize this functionality. Like an example, you want to keep hit for maybe 7 days, or you don't want to hit it more than 70 seconds. So you need to decide it accordingly here. And it's really important when you are considering about how smooth your logic app need to be run, how fast it need to be executed without any delay. How to deal with the asynchronous versus synchronous request, which is again really important. Now, as we know that what is about the synchronous and asynchronous, by default it's async enable. But if you really want that, okay, an example, you are in a loop or some scope block, and based on your previous block, your previous action, your next action need to be decided. In that case, definitely you would like to run those things in a sync way, because if something is happening there, it will go in a async mode and you will not get the appropriate result for that one. So like other programming language, you need to really decide how you are modeling your actions inside the loops, basically, and it's more important there. This is basically the concurrency control. Let me just quickly show how it's performed there. I need to go to the loop. Let me see where it is. Example here. So I have a 2 loop. In one, the concurrency control it's not enabled, it's default. And in the second one, I made the concurrency control, like I just enabled it and specifically make it to the 1. So it's number of parallelism that, okay, there would be a parallel calls will go and execution will happen by default from like it will be taken care by the Azure environment itself. Let's see the output for that one and we'll see, okay, what and how does it impactful. So I just run the 2 loop, one with the concurrency control on and off. So the loop which like if you can see here, the increment variable. So it started with any random number like a 57. If I just go to the next one, it would be 56. So there is no specific pattern than 17. But at the same time, if I just go and check the like the second one where it is going in a parallel one. So it start with the 201, 202, 203, and it will go in a parallel fashion. So this also an important aspect which we really need to consider it. Try, fail, try again, and success. This is when you are going with a basically HTTP SQL and SharePoint. So you have a retry option, and we definitely need to go. We definitely need to consider for that one. So what you could do, like an example, you hit a HTTP request, and then you could check the response. If it is a 200, you could proceed it. If it is not a 200, like it's a 500, you want to really make another try, you could definitely capture those responses and make a retry back to the as the form of the another action. This is again a really important aspect because if you're working on a browser, especially the portal, if you're not saving anything and if the session will time out, you will lost all of the changes. So you really need to save the logic apps like as and when you are proceeding to build it. There's another like a benefit for that one. If you are frequently saving your logic app, the moment if any error will occurred, you will get in a notification pane. So then you can fix this immediately. Otherwise, if you started in the morning and at the time of afternoon before leaving for the lunch, if you're just checking it and there will be the 50 errors, it's really hard to fix all the errors, and it's really hard to identify, okay, from where the error is actually occurring it. So there is no harm to save, like multiple save, like maybe probably you could make a practice that, okay, after making any of the progress in the logic app, maybe 2 or 3 actions or the step, you save it and just validate it. So it's also useful for the validation in the other way. How I can roll back my logic app changes to the specific version. So what you can do, you could go to the logic app versions here, and maybe you could just pick any of the versions. So with the latest version, you will not get an option for the promote. But if you really see that, okay, till this point of time, my logic app was working fine. After that, I don't know what happened, but it's not working. You could go to that particular specific time and you could promote your version. Then it will override all of your changes and it will promote this version as a live version. So this is also important to know about it. Should we use the preview action features? Definitely, you could use it in your dev and the test, but it's definitely not recommended in the product, like for the production logic app workflows. The reason is very simple, because Microsoft not take any warranty, like they don't provide any warranty, any SLA for that one. And if you're using it, it's totally based on your risk. So until it's not like it is in the preview, you should avoid it. And the moment it will go live, you could just promote your dev and you at workflows as an production if you are using it after the testing. There will be no inbuilt conversion for the logic app data type. So if you really want to put the string values, use the string data type. If you really want to put the integer values, use the integer one. So you don't need to go like a JavaScript, like it's not treated like a JavaScript. You declare where ABC and you are storing anything inside that one. So it's not at the runtime. So you need to decide prior while modeling that what data type you're going to use it, and then you need to create those kind of the variable with the specific data types. The peak code, we can't make any code changes there, but what is really important for that, like an example, here. So I would like to see, okay, what is happening actually inside this block for that. Let's go for some HTTP. And I can see all of the things together here. So it will be really easy and convenient, especially if you are working as a developer. So sometimes what happen, like if there's a lot of stuff inside that one, it's really hard to identify specifically when you're using the expression. So it will be an easy way to do that without going to the logic app code view. So code view will also give you the same stuff, but in that case you will be having the complete code for your logic app, and then you need to just put a control F and you need to find the specific variable or the changes, and you could make the changes directly here too. So if you're comfortable with that, you could use definitely this feature. Then you could use the try catch finally block. There is no out of box try catch finally block. You could make a via trick. You could make it. So for that you need to use a scope, and then in a catch scope, you basically need to check that, okay, if the previous step has failed or timeout, then you need to execute that one. And the finally one, like the finally block, if you just need to check even if it is a failed or the skip, then in that case also you need to run it because it need to be executed every time. So this way you could do this, like if you're making some HTTP calls, you're trying to connect with the external system, and where you thought there could be a chances for the exception, you could put in a try block, you could catch it, you could perform like push the logs accordingly into the different system, drop the emails to the contributor groups or someone, or maybe you just push to the specific log files. And in a finally block, you could just close you could just perform the rollback or something. So this way you could definitely utilize the try catch functionality inside the logic app too. So as I mentioned earlier, like if you have a complex requirement, you could put in a smaller chunks. You could create a child logic apps. It is also useful when you are maintaining those things, and the readability prospect also, and the reusability prospect. So feel free to create the child logic apps, and because it's not a per workflow run, it's per step execution, so it's always easy, and it's advisable. Don't go with the very large logic app workflows. Create in the chunks, like distribute and divide into the different chunks and manage accordingly. So high throughput is basically it was in a preview. Just let me check very quickly. Currently it is in a preview or not. Let me just quickly go into the particular logic app and then see the workflow settings. And here basically I was talking about the IPs, which I just mentioned, like a screenshot. So you could check this one. So it is still in the preview feature. You could enable or disable. So its number of parallel instances is executing for your particular workflow runs. So this is the benefit. You could definitely use that one. There's no harm into that. But the second thing is about the retention policy. So you could use the default one, and default I think is the 90 days. You could definitely go and minimize this to the 1 week or something if you are using it for the dev instance or the testing one, because in that case you don't need the log for the 90 days. So you could definitely utilize this functionality while building it. Let's quickly go to the next one. And this is, I just explained you, like you could for especially for the dev and like lower environment, you could just decrease it, because for storage you have to pay the cost, and you definitely don't want to just pay the cost for which you are not going to use it. Then you use the advisor recommendation. It's on the resource group level, and it will give you a lot of recommendation if there is any security issue, if there is any cost related issue. So it's worth to have a look for that one for sure. I've just compiled a few links here, and it will be very useful for you on your Azure Logic Apps journey. So it's worth to have a look for that one. I'm really thankful to all of you to spend your valuable time today and looking for your positive feedback and suggestion. Please scan the QR code to use on the short URL to access the feedback form. It will not take more than 20 or 30 seconds to provide you valuable feedback. And it's really mean a lot for me to improve myself in the subsequent sessions. You can connect me on the social platform, ask your queries on my Twitter handler, which is @Ampesha19. Scan the code and connect me over the LinkedIn. You could subscribe my YouTube channel for the slides and the more demos on the Azure Dynamic 365 and Power Platform technology. I hope you find the session interesting and useful, at least to find a new dimension on your integration requirement. I would like to open the floor for the question and discuss now. Thank you.
Hey, I first have to apologize for the quality of the stream. I don't know what went wrong here. I already plugged my UTP cable in, but that also didn't really work as well as I expected. So we're gonna put a original quality up anyway, somewhere next week. So you can always watch it again, and hopefully the quality will be better then. For sure, because I know it's better. Ambish has delivered a good file, but the stream is not coping with it correctly. I saw a few questions coming in, so I'm gonna throw it up here. Maybe Ambish can answer it. This one is from Jaya Ayawad. Any way to extend the 120-second limit if you want to have a long-running logic app? So it's or the asynchronous response with the location header, the only option for such flow. Do you understand the question, Ambesh? I don't hear you. It's my problem. I cannot hear you anymore. I don't know if your microphone is somewhere. That's weird. You're in the stream.
Am I audible
Yeah, I hear something
now?
Yeah, you're audible now. Perfect.
Hello?
Yeah, you're audible.
Able. Okay, that's great. I'm sorry for that. So the first thing is that I haven't seen that there is any kind of the limit for the 120 second for the long running logic app. Like it could be executed. I think there's a maximum limit for 90 or something. It was already in the slide. So for me, there is no as such limit for the 120 second. Or the second question is, or is there any synchronous response with location header, the only option for such flow? I think the flow, what can do, logic app can do so, because logic, like the flow built on the top of the logic app, they're using the same engine. So I don't think so. Like we will not get the location header. We definitely can get it. Then yeah, I would wait for the next question.
Yeah, I could see some questions. There has been a lot of chatting going on. This one is also a good one. Can you suggest any alternatives to the APIM for integration in Azure?
I didn't get this question. Like if
let me pay.
If you just elaborate a bit more on that one.
Alexander, maybe you can follow up in the chat on YouTube, or
yeah, or maybe you could connect me over the LinkedIn also, so I
that's
could
also
understand.
yeah,
I could understand, and I could because it's not really good if I don't understand and give an appropriate
no problem.
answer for that one.
Yeah, we also have to move on because we're a few minutes behind, but that's okay. You can also go into Discord, post your question there. I'm not sure if you're on the Discord, Ambash. That's also a place where you can elaborate a little bit more. People can reply on each other's threads, and everything gets grouped together. You can also put your files there or link to your files. Yeah, thank you very much. Again, my apologies for the stream. I didn't know that it would be that bad, but we'll make sure the right quality is going up. I'm gonna add Alpa to the stream. Who's the next speaker?
Hi.
Good morning for you.
Morning.
Or good afternoon. I don't know.
It's a good morning.
Good morning. Let me remove this one as well. Where are you from?
I'm from UK.
Ah, okay. That's across the channel.
Yeah, it's 9:15.
9:15. So it's in the morning. Stefan had an earlier one. He was in at 7 this morning.
Yeah.
Very, very early. Can you share your screen? Then we can start you. stream. And you're going to talk about Azure Data Factory, which is a good one for this group probably, because there are a lot of integrators that are not really data heavy. They are mainly heavy on the real integration part. So it's always nice to have some interesting insights on Data Factory for sure. If you
I'm trying to share it, but it's not allow me to do that.
It's not allowing you to do that.
Okay. Let me try it again. I think okay. So I first need to click on share.
Yeah,
And there is a video file and share a
share
screen.
screen. Yeah, share screen.
And then there are a few options. Mic and don't show these tips again, or just a share a screen. Okay.
Yeah.
So and here, share audio.
It could be that you don't have to share the audio. It could be that your browser is blocking it.
Browser is not showing that one. Yeah, that button is disabled for me. So, okay. I need to choose a StreamYard and then share.
Yeah, exactly. Yeah.
Okay, let's try that.
All the things for a first live stream.
Yeah, actually, this is first time for me as well. So,
no problem.
Yeah, can you see my screen now?
Yeah, it's there.
Okay.
There it is. A little bit of inception going on now.
Yeah, but can you see other screen as well? Like I'm just clicking on another.
Yeah, so if you share your
this is pipeline and another browser. So like
currently we're only seeing StreamYard Inception.
Okay, so how can I share other screen as well?
You can choose the screen if you click share.
Okay.
Let me remove it shortly.
Yeah, I think I didn't get a option.
Not.
Okay. Sorry for this.
No problem.
So how can I edit the screen here?
If you
click on okay. No, no. Shall I start it again because I choose?
Yeah, start it again, please.
Okay, sorry for this. Share screen, and here is not showing anything, so I share it. Okay, it will go. Okay, application window, entire screen.
I normally choose entire screen. Yeah.
But that one is not allow me to do.
Okay, that's weird.
So shall I do application?
Yeah, try that.
That one is disabled. They only allow me to do Chrome tab. Okay. I maybe select this all. No, they're not allowing to select as well. What should I do? Is it every time I have to show different screen?
Should be. Let me. I can only edit your name. I have troubleshooting.
Okay, let me try now.
Yeah, you have StreamYard in your window now.
Yeah, and can you see other windows?
Yeah, I can see it now.
Okay, yeah, that's good. Yeah.
Okay, then I'll hand it over to you.
Yeah, okay. Thank you so much.
Good luck.
Yeah, thank you. Hi, all. Good morning, good afternoon, good evening, depending on where you all are. Thank you for joining this session and welcome to attending this Azure Data Factory for anyone with pipeline creation and DevOps deployment task. So myself is I'm Alpa and I'm Azure consultant at Cluster Reply. And if you would like to join me, then I have my LinkedIn profile as well there. This is a breakdown
I
of
don't
my.
think your deck is showing. Can you? it's
Oh,
still
no.
showing your.
Okay.
You can. Yeah, if you click that, what would happen? Nothing.
Nothing. I have it in here. Okay. Let's.
Okay, you share your deck first and then share the other stuff.
Okay.
I can help you switch.
Yeah. Okay. Actually, I will stop it and we'll start.
Yeah, exactly. Yeah, that's okay. I'll keep an eye on it.
Share screen, but I'm not able to see that one. Application entire screen. Oh, now it's unable entire screen. I think that's fine now. Yeah. So,
Yeah.
Yeah. Okay. Good.
Okay, perfect. Then.
Okay. Okay.
Okay. Good luck again.
Yeah. Thank you. Thank you all. Thank you for joining. Today I am going to explain Azure Data Factory, very introductory overview, and I'm showing pipeline as well. So let's, yeah. So here is my company. I'm working on cluster replies, and if someone would like to join us, then please follow us on LinkedIn because we are looking at the moment architecture and Azure developer. So yeah, here is today's agenda. Initially, I'm going to explain about Azure Data Factory and key component of Azure Data Factory. And later on, I will move on to CI/CD pipeline lifecycle. And then I'll show demo. And last, we share resource and materials. So yeah, what is Azure Data Factory? Azure Data Factory is a serverless cloud data tool which help us to do ETL and ELT, like extract, transform, and load, and extract, load, and transform, and data integration. It we can imagine it's just like a conductor in orchestra, and it help us to do data transformation, complex data transformation. So why we need Azure Data Factory? Because it's low code and almost a no code solution. We can do it in Azure portal, and it's play a very important role in a modern data warehouse, because in modern data warehouse data comes from various different sources, like structured data, non-structured data. It comes from like clicking any items in a browser, or maybe it comes from like social media websites, or like various different forms. So it's play a very important role. Another reason is everything you create in Azure Data Factory in a portal, behind the scene, they are a JSON file. So we can say it's like very ready for a source control. Also, it provides a Git integration in Azure Data Factory. They have inbuilt Git integration, and when we publish it, our pipeline, it will create automatically ARM templates which we can use it to deploy via manually, or we can use automatically CI/CD pipeline, which we'll see later on. So here is like what to do in Azure Data Factory. So we can do copy data and we can do transform data. We can copy from various sources. We can copy from on-premise database. We can copy from another cloud like Azure, AWS, Google Cloud, and IBM Cloud, or any other cloud. Or we can do different data source like SQL Server, Oracle, IBM, and I think it has around 100 data connectors for that to copy a data. Once we have a copy a data, we can do complex transformation. We can see later on quickly in Azure ADF tour as well. And we can store into data warehouse or data lake or any data, like for example SQL server, or like even we can move from one API, copy a data from one API to another API. So this is very powerful tool. So I would like to explain you with comparison with SSIS package, because maybe some of you are familiar with SSIS package. So here we can see in SSIS package we have a package, while here we have a pipeline in Azure Data Factory. In SSIS package we have a connection manager. Here we have a link service, and we have around 100 connectors. So we can have like link service from that connector. So source same in both side. In Azure Data Factory, we have a sink, and in SSIS package, we have a destination. We have activity in IDF, and we have a control flow in a SSIS package, control flow task, and data flow is the same in both places. So it's like kind of like SSIS. ADF is a kind of like SSIS, but in a cloud, and it's much powerful than SSIS. So now I would like to explain you about a key component of Azure Data Factory. Azure Data Factory has pipelines, it has activities, link service, dataset, data flow, and it has a trigger and templates. So what is a link service? Link service is nothing, as I explained earlier. It's just like a connection manager. It allows us to connect your data source, or we can say it's just a connection string. Then we move into datasets. Dataset is nothing, but it's just like a table, or we can say it's just like a file folders which having list of files, or file which have a list of data inside that. And dataset is authenticated by link service, because link service is pointing into data source. For example, if link service is connected with blob storage, then dataset would be like files on that containers, or folder in that in containers or storage. Activity is nothing but just like a specific task. It do some specific task. Look, for example, copy activity, do copy from source to sink. For a set variable activity, that just set a particular variables. So we have I think lot of activities I will show you later on. And data flow we use when we need to do a complex transformation, like for example, in SQL Server, we have a select, where, having, group by. Similar kind of stuff we can do in data flow using no code or less code. And we can do it very quickly as well. It will very quickly filter your data. It will aggregate your data. It do union or join. It do so many things in data flow. So that is a data flow. And now triggers. Pipeline will execute it by triggers. We can run pipeline immediately, or we can schedule pipeline, and we can schedule it based on timely manner, or we can schedule it based on something happen like event based. For example, when file comes into that blob storage, it will automatically execute this pipeline. So that kind of stuff we can do using setting a triggers. And templates are used. For example, we can create our own templates, or we can use inbuilt templates. They have already available inbuilt templates to save our time if we use already existed template. I'll show later on in a while we view the IDF in a portal. So here is like relationship between the elements. So like pipeline is logical group of activity, and activity is authenticated on predefined link service which you have chosen earlier. Like for example, we first choose link service. So, and based on that, it will do consumer data or produce the data, and for that it use dataset. Dataset is like represented data on a particular link service. For example, we use a link service for Azure SQL Server, then dataset would be a table. So, and if we use Azure Blob Storage as a link service, then our dataset is just like a blob file or blob folder. And as I said earlier, that LinkedIn is not linked service is nothing. It's just like a connection string for a source or destination. So here are generally available activities. Typically, it's like you can do metadata activity, lookup activity. You can use a store procedure using procedure activity. You can use a wait activities. You can use web activity to connect Azure functions or any logic apps or other kind of other APIs, third APIs. You can use Azure function to as a customized activity, or you can use like you can trigger another pipeline by using execute pipeline activities. We can execute SSIS package in Azure Data Factory by using the execute SSIS package activity. We can set variables, we can append variables by using those activities. So here is typically, like for example of RDF pipeline, how it looks. So like for example, we have a lookup activity. We'll do lookup for example, table lookup, or it can be like folder lookup for file and size kind of stuff. And then once we have a lookup activity there, then we can copy a data from source to sink. Once we have a copy activity finished, we can do the transformation for a complex logic using data flow, and we can run machine learning applications like Python code or Java code using the notebook activity. And if there is any error, we can execute store procedure activity to do separate error logics. So this is the pipeline and typical pipeline example. And now I'm showing you the example of data flow. So data flow is like as it's we can compare it in any SQL language. For example, SQL Server, SQL query. So here we can say like my source is MovieDB, which is a CSV file. So it's, for example, it has a millions of records. So that's why I have to filter it. So I have used filter activities in a data flow, which do filter based on year. Then I add a aggregate activity that do aggregation based on a type of a movie or a rating, and then I store into sync that source. So this can be done is very quickly by just clicking few steps in Azure Data Factory. So I would like to show now ADF tool in a portal. So let's see browser. So if you go to portal.azure.com, can you see my screen? Hello? So yeah, here I can like we can say, for example, let's add new Azure Data Factory here. So we go to this resource, and I'm just clicking on adding the new integration. It's in integration tab, and here I can add Azure Data Factory. Sorry. Yep. So this is Azure Data Factory. I'm just creating Azure Data Factory for a like for example, I'm just giving one name, and I can say it's production, and I'm just creating it. And here I just want to change it because I don't want to use Git integration at the moment. So I'm just clicking this one and I'm creating it. So this is I'm creating Azure Data Factory for a production environment. This is just example. Yeah, so my factory is going to complete soon, and it's still deploying. Okay, it's done. So now see. So this is my Azure Data Factory. I have just created it, and now I can go to author and monitor. So yeah, so here you can see it. It has like pipe. We can create pipeline. We can create data flow. We can create pipeline from templates. We can copy data tool, which is a separate tool, and we can do exercise integration and set up repository. But and we can use even a predefined template as well, like this way. So let's go to here, and we can see it like this is typically how the look Azure Data Factory. Here we can have a pipelines. We can add pipelines here. If you like to add, we can add it. At the moment, I don't have it. Yeah, we can add a data set if we would like to edit here, and we can add data flow. But at the moment, we don't want to go that way. Then we can manage it. So like here, we can add a link service for a particular source. Here we can see we have so many connectors available. We can connect that, and we are not adding that at the moment. Then here we can do git configuration. At the moment we don't have it, but we do later on. We can import and export a pipe templates. Once we have a created pipeline and we publish the pipeline, we can import it. Template will generate automatically, and we can use that one for import or export. So yeah, this is just a tour of ADF. So now let's move to PowerTech. Yeah. Yeah, so that is a tour, and next is now we move into IDF continuous integration and continuous delivery. What is the continuous integration and continuous delivery? And we will also visit the life cycle of it in IDF. So what is a continuous integration? Continuous integration is nothing but it's a practice of testing your change in automatically manner, and we do it as soon as possible, as early as possible. And continuous delivery is just it used what we have done in continuous integration, and it's push your code from one environment to another environment. For example, staging to production, or staging, testing, or UAT, like that way. So now we are going to see what ADF in CI/CD in ADF. So in Azure Data Factory, CI/CD means we are moving the data from Azure Data Pipelines from one environment to another environment. Why we need this? Because it saves our time. We don't need to do it again and again in all different environments, as well as we can find if there is any fault easily in a dev environments. So we don't need to do again and again it. This can be done in two ways. One is manually by using the portal which I have showed earlier. We just need to import that ARM template, export that ARM template, then we can import that ARM template in another Azure Data Factory. Also, we can do this is automatically by using the CI/CD pipeline, which we were showing in this session. We only need to note here that only one ADF, dev ADF, is connected to a particular repository. For testing and production, we are not using any repository, but we are using the pipelines. Once we have deployed in ADF, dev ADF, we can directly use that one into test ADF or like test stage or stage, another stage, or UAT stage or production stage. And we use a release mechanism for copying data or moving the pipeline from uh, testing to production or lab production or UAT. So here is a typical life cycle of Azure Data Factory, continuous integration and continuous delivery. So here we have a dedicated a dev Azure Data Factory. So here we will create a future branch first. Then once we added a pipeline or we modified pipeline or we modified data set or link service, then we, if we happy, we run it and it's work fine, then we do pull request using the Azure portal. Once we do pull request, then our code will move from feature branch to collaboration branch. And here collaboration branch can be like your main branch or your master branch. So once we have a code in our main branch or master branch, then we need to publish it from that branch. So once we do publish, it will create ARM template automatically under the ADF underscore published. And this is the ARM template we will use for build pipeline and we will use for later on different staging. So once we have ARM template is ready in ADF underscore publish folder repository, we can create a build pipeline. So once we have a build pipeline and inside build pipeline, we will do build artifacts. So once that is ready, then after we can create a release pipeline. Release pipeline is there. Once we have a release pipeline, we using that ARM templates from ADF underscore publish repository and we will deploy them into different environments. It can be like test environment, QA environment, and production environments. So let's look inside the Azure Data Factory pipeline demo. Okay, so here, as we have a time limit, I think almost 45 minutes or like that. So I have added here all steps. So like first we need to create a resource groups, then we need to create Azure Data Factory, which we have earlier created. Then we need to create a project in using the dev.azure.com. Once we have a project there, we can initialize repo there, and then we can set a Git repository or Azure Git repository. So I can show you that one with here. So for example, let's go to, yeah, it's here, dev.azure.com. For example, I have already added a project, but for yourself, I just adding project here. So we can say GIB 2021 3, and we keep it as a private repository at the moment, private, but we can do public as well later on. So let's create that. So this is the project I have created using dev.azure.com. And here you can see we have like a repository, we have a pipeline, and at the moment we're looking for two. So there is a no pipeline and there is a no repository. So let's quickly initialize this to see this one. So now, okay, so this is our project name is this. So now we need to go to Azure Data Factory. Let's go to, I'll already show what I have because of a time limit. So like, for example, this way we need to create a project and then we need to go to portal.azure.com and then, yeah, then we can create a factory here, which I showed you earlier. Like that, I created that one. And so I can show you here how it will do. So this one is my dev at Azure Factory. I created earlier yesterday night. So here I have connected it with Git repository, but I can show you what you need to do. So like you can see here. So I have here a configuration. So I have connected it with my DevOps account, my project name. Here we need to create new project we created, which is 3, GIB 2021_3. Repository name, and collaboration branch is main branch, and publish branch is ADF publish. And then so once we do like that way, it will connect it to our repository in DevOps. So that one is ready, and then we can start creating pipeline. So I have already created pipeline here. It's just like we can do copy, and then we can move that copy into here, and then here you can see it that I have a source and sink. So for source and sink, we first need, okay, let me show you data set. So I have created first of all one link service, which is, this is the link service which pointing to blob storage, because our scenario is to moving the data from one blob storage container to another. So I have created link service for that. So I just give name of link service. I'm connecting with that storage account, and yeah, that's it. We can use keyword as well, but at the moment I just showing concept. That's why I just use a connection string instead of storage account key instead of keyword, and we can test it. So it's there, it's already there. So this is our connection link service, and here we have a two data set. One is a sync data set, and one is a source data set. So let me show you here. Yeah. See, I have here one storage account. I created earlier storage account for Dev. So this is my storage account, and it has a container. I created two containers. One is sync container and one is source container. And I have here one file as well. If you like to upload, then you just click in upload and you can upload it here. So that is my sync and source account. So let me add here one for storage account for product, so we can use it later on. Yeah, I'm creating storage account, and we can say same group. We can say here GIB. It has to be lowercase. GIB 2021 storage. The full name of that storage and PR for production. So this is creating our storage accounts. We can create it, and then we will create two containers, one for source and one for destination. It's still doing that. So meanwhile, I can show you here. Yeah, so I already have it, but I have created for a production round. So yeah, so here is a data source which is pointing to, I can edit as well, so you get idea. So this data source name is that. It's using default Azure integration runtime because it's in a cloud. And I have used connection string instead of using Azure keyboard because of we have very short time to do that. And here is my storage account name, and I need to paste here connection string of the storage account key. And when I test it, it's run successfully. So, and similarly, it's a source also. It's pointing into same account. So, yeah. So let's run this pipeline to see it's moving the data from source to destination. Let's first make a empty storage. So here, so if we go here and we can see that this is my storage account. So let's as I ran pipe. Oh, it's empty. That's fine. Okay, no worries. So this one and in sync we have one file. So this file will move into source. Okay, it's already moved. So we deleting from sync because with that we demoing. So now sync is empty and source is also empty. So I just would like to upload here a file from my desktop. Yeah, use a little bit different file at the moment because I'm not able to find that file. Yeah, I got it. That this is the file. Anyway, it's a hang. Anyway, that's a hang. So okay, then let's we try it again. We're moving that file into that folder. Okay, it's already there, so I can upload that file. So now that file in this sync folder. So when I run that Azure Data Factory, it will just move file from sync. Oh no, I don't want to update here. Let me delete this. I need to do it in a source. So click here, upload file. Upload. So now this file is uploading into my source folder, and when I run Azure Data Factory, it's move file from source folder to sync folder. So let's go to our dev Azure Data Factory. So when I run this, it will move file from source to sync database. It's queuing that. So while it's running, okay. Okay, I think I got idea because that file is not there. Let's run test one because I have deployed it via pipeline. So yeah. So if I run this one, so while it's running, I just would like to show you the properties. So source one. So here source data set, it's connected, and we can preview as well. So it's look like that. And we can set here a lot of other properties as well. And sync one, which is our sync data set, which is pointing to sync folder. And while it's completed, let's see what it has done. Yeah, so it's executed completely, and here we can see it what it has done. So here you can see it's more read data, how like read data is like size of which size of data it has read, and write in same size. You can see like how many files it has read and what is the peak connections, and you can see like individual performance related issue you can find out here, like which task is executing more, taking time. So that it. So let me show you now. Actually, we go to here because we have very less time. So this is the one. We did that, and then we set up the repository. We show the how you will set up that. So then you need to create a future branch in here. So like I can show you very quickly. Let's go to dev ADF. Okay, we can we can go into dev ADF because because it only pointing to one repository, which is dev ADF. And so here we need to create a future branch if you want to do any changes. So like for example, you can create new branch like that. So once you do changes in that new branch, then you need to create a pull request from here, like this way. So once you do create a pull request and it upload and it completes, then your code moves into main branch, and then you need to from main branch you need to publish from here. So it will generate ARM templates in a pipeline. You can see it sorry, in a repo. So you can see here that it this is adf underscore publish, which I have published yesterday, and you can see that it has generated ARM templates for our Azure Data Factory, and it has like link service, it has a parameters, and you can see it has a like everything, copy activity, sync source, and you can see it has like all elements like source also there. It has a link service as well, and here we have a parameter. So this parameter is like for a dev, we have a dev data factory. If we have a testing, then we need to have a testing factory name, and we have a connection string because link service dev link service pointing into dev storage. If it's a UAT, then UAT data source blob storage will point it by this link service. So we have to pass that in here. So this is a repo. So once this is ready, you can create a pipeline, which is a build pipeline, which I already have created, but I can show you how to do that. So if you are new, then you just create new build pipeline, and then you use the classic editor like this way, and then you can choose your like this way. You have to choose your repo and like that. So once you do continue, and here we need to add empty jobs initially. So this is the one. So this setting is okay. We can change here name if you want to change like this way, and then we will create here I'm not going to continue it, but then you need to add your new task, and here we are adding publish build artifact. We will add this one, and then we will set here like we can name also here like any ARM template or which way you want to do. Like, okay, I'm keeping it for a moment. Then here you need to choose your folder name, which is folder which having ARM template. So like this folder, so you have to point out this folder here, this one, and then you need to click OK, and then you can give like your name, templates, and like that's it. Then you need to save and queue, so it will execute your build pipeline and generate build artifacts. So that one I already have here, which is this one. And then once you have a build artifact is ready, you can create a release. And I already have created for a dev and UAT. But if you want to create it, you can just create it by create yeah, you can add here. I already created, but I'm just showing you that one here. Like for example, you can give a stage name. So like at the moment I'm selecting it. So you can say testing, test the stage. And then you can add your artifacts. So your artifacts is nothing but when you uh, uh, in last step you have built your pipeline. So now you just need to use your artifacts here with that one, and then you need to add in here, so it will comes here. I'm not doing that at the moment because I have already done. And then here you need to test your task, which is ARM template task, because we are deploying ARM template, Azure Data Factory ARM templates. So here you need to choose a service principal. I already have it. If you don't have it, then you choose your subscription. It will automatically create a service principal for you. By here there is one button will comes authorize, so you click that. Then you choose your subscription, you choose your resource group, and then here resource group you have to choose for testing resource group, another resource group. And then you need to choose location, which is same as Azure Data Factory location. And here you need to choose your ARM templates, which you have at the moment. I haven't set a build, so I won't have it, but you will get your ARM template, which I show you earlier. And here you will choose ARM template parameters, which I showed earlier. And here you need to set two parameters, one for storage account key and one for Azure Data Factory name. So that's it. Once you have this one, you can save it. And then once you run it, you will deploy your code from dev to build pipeline to testing environment or UAT environment or live environment. So I think I have here that one as well. So I did test it for test and UAT, two environments, two stage I have done. I can add here more stage for UAT live as well, or something else QA or like that. So you can see that one here. If I create new release, then it will run. But at the moment I already have it, and we didn't get time to deploy into production. So otherwise I have created but I think we have out of time now. So done this all. This is the step I have already created here. So if you want to build, you can do by yourself. And for here I have used resource group, blob storage, and data factory, and I created two data set, one for sync and one for source. I created one link service because we are pointing to same blob storage account, and for source and destination. So this is the, if you want to do it by yourself, then you create resource group, and then you create three data factory. I show you how to do it by creating product data factory. Then you create a storage account, three storage account for three data factory. You can use one as well, that's fine. Then you can have in data storage, you have a containers. I have a name sync and source, and in the source I have a data. I have a file, CSV delimited file, which is a movie DB file. So once I run pipeline for testing, it will move from it will generate this pipeline in this testing Azure Data Factory, and then when I run that one, it will move file from source to destination. So you can do like another way, like you create 3 different resources, like say resource group for different environments. Then you create 3 different data factory for different environments, and then you can have keywords or SQL server per environment. So you can create and give a name, and then if you storage, then you can create storage accounts name, and that way. So once you have deployed release pipeline, then in your product environment or dev environment, you can see that factory will be deployed, pipeline will be deployed, and then you just need to execute your pipelines in that environment and see it's working or not. So here I have already explained these all steps. If you want to go by yourself, and you can execute like this way. This is material, if you like to use. This is a very good material by Catherine. And here you have like data flow, compare, like how you will compare with SQL Server and data flow is there. And there are few YouTube channels which I really like there. Thank you so much. If any questions, then please let me know. And thank you for attending this session. Thank you for Global Integrator Bootcamp for allowing me to attend this session, to deliver this session. Thank you so much. Any question? And thank you for listening me.
Yeah, thank you too. Are we going to? We don't hear you, Rob. I think you're on mute.
I was muted. Thank you, Stevian, my savior. I suggest we jump into Matthias's session right now immediately, because we have a small break after that, about 5 minutes, and otherwise we will be running too late. If you could go into Discord, if people have questions, you can always go into there and answer them there. So
also feel free to ask me in LinkedIn if you have any question regarding Azure Data Factory, or you would like to do first time your pipeline and you have any problem or something like that. Yeah.
Yes. Thank you very much, Olpa, for your session. And talk to you soon.
Yeah. Yep. Thank you for listening. Thank you. Bye.
Bye.
Thank you.
Yeah.
So Matthias, you're up next. We cannot do a long introduction, otherwise I don't have any time to go to the toilet.
I got 3 minutes.
So you're going to talk about Key Vault and MSI, I think.
Yes.
They're very, very good friends. So
indeed. Mm-hmm. If you guys haven't tried them, well, I will make them your best friends at least.
No, Key Vault is my best friend. Let's see for MSI.
Key Vault is definitely my best friend, and Managed Service Identity is the other friend to become a big friend.
Yeah, they are. They're really nice. You'll see it in my next session as well. I will use them there also. So
yeah, so you're doing this session, then 45 minutes. It's
release with love.
Yeah, and then you're up with a longer session.
Yes. Okay.
Yeah, so let's jump
in. My Swedish friend.
Cool. So today we're going to talk about MSI and Key Vault, and I'm going to try to make them your best friends because they are my best friend. And hopefully you'll see this in this session and later on this next as well. So that's what we're going to do. A short introduction about me. My name is Matthias Lugberg. I'm a solution architect and an MVP. And I'm doing some new stuff, so hopefully you'll hear about that soon. Otherwise, if you want to reach out, you can find me on Twitter or on LinkedIn, and let's go. So, Rob, I want your help. Give me camera, please. Thank you. So today we're going to talk about Key Vault. So Key Vault is where you store secrets. It's a really nice service that we can use, and you can store your keys for cryptographic stuff, and you can store secrets like key passwords and stuff like that. And you can also store certificates. And as you all know, in integration space, we use them a lot. We use them all over the place. Because regardless of what we are integrating with, regardless of internal, external, we use some sort of password. And we use certificates for security. So we need them. And what better to keep them centralized and at one place and make them secure and manageable? Nothing. Awesome. So now you're hooked on Key Vault. That's good. And Key Vault is a simple service. So yeah, let's jump in and see how it looks like, because, well, I'm gonna try to save some time on this. So thank you. And there we go. And let's jump out to PowerPoint. I don't really like PowerPoint, as you all know. And there we go. Let's see. There we go. And so this is a Key Vault. As I mentioned, a Key Vault is a small service. It's cost nearly nothing. And there's a way to centralize our secrets in it. It mainly has 3 different areas. So it has keys. So this is, as I mentioned, cryptographic keys that we can use. We can generate one, and we can get a new key to use when we encrypt our data, sending it to, I don't know, if you want to use it for storage, or if you want to use it transmission to another source. And we also have secrets. So this is the place where you store like a username or a password or anything that is a plain secret in text. So you can have API keys, you can have anything that you would like to share between services and centralized management. And we also have certificates. So this is also a good place when you want to store certificates and work with them in a centralized way. I've been using this a lot. Just having my Let's Encrypt secret certificate in the store and manage it like that is a very simple way, because then other services can pick that new certificate automatically, which is really, really good and much simpler than needing to go onto that service. It makes it more manageable for someone else to manage your certificates. And all of this is, of course, protected. By default, your Key Vault is secured by role-based access. So you have access control to it, which means that only people with, I think it's contributor right, has the ability to go in and actually grant access. Might even be owner these days. But then you can go in and read things, but if you don't have enough, you cannot get anything out of it. And then as a second layer of protection, I would say, we got this called access policies. So not only is this service needed to be accessible by the service itself, it also has to have a access policy, which means that we need to create a access policy to get the part we want. And in this area, we can actually go in and say, let's just go ahead and add an access policy. We can actually go in and say what policies they're going to be able to choose. So if I want to give someone the possibility to actually get secrets, then I can go into secret permission and I can select get and list, for instance. Or if I work with certificates, maybe I want to give them the get and list certificates. And if they are actually, like I mentioned before, someone who's updating certificates, then I might want to give them more, maybe everything. And there's a template for that, so I can give them the secret or certificate management, and then they will have all the permissions they need to do that. And that we can select on a principal, which means that I can go in and type my own name, and I can find myself and grant myself those permissions. So that's where we are. So let's just add a secret into this to show off this a little bit. So I'm going to go ahead and add a secret. I'm just going to go ahead and add my secret. And I'm going to go ahead and say Gib 2021. Awesome. So first step, we got a secret. In our Key Vault, we actually have a secret. And now if we want to go ahead and access this one, we, as mentioned before, need to have an access policy and access to this. And there's actually why we come into MSI. So MSI is Microsoft Service Identity. And Microsoft Service Identity is where you... Hey, Rob, can I get the camera again? Sorry for not poking it. Thank you. So Microsoft Service Identity is a way of giving your services an identity, which means just like me, like you saw me there, you can find myself that in that list. You can actually find the service itself, which means that I can provide this service. Oh, take this round thing over here, and we can give that an identity. So we can grant access for that service into our Key Vault. And this is particularly nice when it comes to moving parts, like when you go into releases and stuff like that, because then I, as a person, don't have to have access into that Key Vault. I just need to make sure that my service has, and I know what name that secret has. So let's just bring in an identity. Let's jump in again, and let's go into a logic app. Let's just go in. I have a get secret over here. So, and we're gonna skip starting this part. We're gonna go down here because MSI is found on most services, and you can find it as this identity tab, as you do on logic apps, for instance. And when I go in here, I will just go ahead and press on, and I press save. When I do this, a lot is happening actually. So this is going back to AD, creating, and I wouldn't say a service principal, but you know the deal, service app registration, you know that part. But it's called a managed identity, which means that this is this service identity. And it's create an identity for this one and links them together, which means that this service knows what it is and have all the secrets and stuff like that to be able to identify themselves as them. I'm not able to identify myself as this service, which is really good. So now I have that, and yeah, if you're interested in that, in how it works, this article describes the whole process. And as you can see, the resource manager is doing stuff, and then it goes to the AD, and then you come back, and that's how we get. And when I have my identity, let's jump into Key Vault again, and I want to be able to pull this secret out. So let's do the access policy area. So let's add an access policy, and let's go ahead and I just want to have them to list and get secrets because I don't want it to be able to do anything, and always keep these permissions as minimal because it's good practice to do that. So let's select principal, and then I'm going to head in 001 get secret. There we go. So now I can find it just as I found myself earlier. I can find this resource. So this is the identity and the person. So there we go. Select and add. And one thing that you need to remember, press save on this one because that's easy to forget. So press save. So now in my logic app, I can actually go in, and let's go ahead and add this one. And I can go in and do, let's just do request response, use the template, and let's bring this minimized. I zoomed in because I heard it was hard to read and looks good. And let's just find Key Vault. Key Vault. Oh, sorry. There we go. So in my Key Vault, I want to get a secret. There we go. And this is actually in preview now, so this is quite fun. So connect with service managed identity. I want to use that one, and I have a system assigned identity. That was exactly what I did. There's one thing called user assigned identity as well, I think it's called, and then you can assign your own. You can create it in pre-hand and then redirect the identity to a resource that way. But we are going to use this. So Key Vault name, mlugberg -dev -key vault, and let's just add test. Let's create that one. Awesome. Now I can list my secrets because I gave the permission to list. So I have my secret, and I can then just return that into the body. Oh, into the body. This is not the way you should do, but let's just do the whole thing. Let's just do the secret. There we go. And we save it. And we copy this trigger URL, as you are familiar with, and go to Postman. And just add post and enter URL. And let's just press send. We don't need a body. We just need to prove it. So, as you can see, really, really small. Sorry, I'm not. Yeah. Zoom in. Zoom. Look. Zoom. as you can see, I get my secret and I get give to 2021. And this is how I can get it. And I didn't, as you saw, I didn't manage anything. I didn't need to pull out any service principal. I didn't do anything. It just worked. And the cool part about this is exactly that. It's just working. So all we need to do is be able to get our small service and they can connect like this. I, over here, doesn't even need to know. Doesn't even have to be me who's adding the secret. This can be this other person over here to actually add the secret, and my resource can get it. So I'm just in the blue over here and don't know. All I know is that the secret is called my secret. That's all I know. And this is why you should use Key Vault, and this is why you should use MSI. And thank you for me. And I'm gonna try find stop share.
So should I be in love now? That's it?
Yeah, I think you should. I was a bit stressed, sorry.
No problem, no problem. It's for a lot of us. It's live stream is always we call it spannend in Dutch. Exciting. That's it. There is Steve Jan. He's back. A little bit fuzzy. Very short and very clear. Also very clear to read, by the way, Matthias. I don't know. It's probably bandwidth. I don't know what it is. Nice. Very short and clear session. If you have any questions, please go into Discord. There you can answer them there, because we have a 5-minute break now, and then Lieselot Johnson. And after that, you're up again with, you know the session name yourself better than me.
Releasing with Love. So we're going back to that theme again.
Yeah, we're going back to some love again. Okay.
Releasing with Love. Is that a James Bond movie or?
I don't know. I just wanted a nice catchphrase. So
it is.
Yeah. And I really like doing that, because when you do releases, it's actually really beautiful. And it's nice. I love doing that part when it's working fine and everything is smooth.
Yeah. Totally true. Totally agree. Even for best talk, who knows?
Releasing with Love from Matthias Bond.
Okay. See you back in a good 50 minutes probably now.
Yep.
Cool.
Thank you
very much.
Thank you.
Bye.
Bye.
voor bedoeld. Hè? Het is in de regel, of het is voornamelijk een woordleesboek. Maar het gebeurt dan.
And Stevie on as well. Perfect. I saw you were eating, so I didn't want to
No worries,
too
no
early.
worries.
Okay.
Coffee.
Coffee, yeah, that's important. It's a good one. I was just enough time for me to jump to the smallest room in the house. So,
Okay.
Yeah. Next up is Lieselot.
Lieselot Åslund, also from Sweden.
Yeah.
And you have been working with BizTalk. We have to find a new name for BizTalk Bill. That's basically what I saw in Discord. So maybe you can think as well. Like maybe there's a good name for Bill in the future. But you've been busy with integration quite a long time, I see.
Mm-hmm. Started out in 2009, and that's the road I've been walking since then. So the last couple of years I've been introducing myself to Azure.
And
yeah, that's nice, Lieselot, because when I became MVP back in 2010, I also went to Sweden, and that's the first time I met you. So ever since I came to Sweden to doing sessions, I always saw you in the room, and we had some discussions. So yeah, it's you go back way long as me with this stuff. So.
Yeah.
Cool. You have a pre-recorded session. I'll be throwing that up in a minute. You will be available for questions afterwards. Just asking. Okay, perfect. So if you have any questions, please put them in the comments by the end of the stream, because otherwise I will not keep track of everything. In the beginning of the day, we had like 100 things on YouTube and I couldn't find questions anymore. So throw it up, and afterwards you can always go into Discord, of course, and go in.
Hi and welcome. In this session, I will take you on a hands-on walkthrough on integration towards Microsoft Dynamics 365 Finance and Operations using Dynamics out-of-the-box data management framework and data management package API. The agenda, I'll talk about how to choose integration patterns, batch data API, data management framework, data management package, REST API, how to connect Dynamics 365 and Azure, and there will be a demo. My focus will be on the data management package REST API. I'm an integration rockstar, and I play in an awesome band called IBIS. The experiences and findings that I will share in my session come from joint work with my awesome colleagues. I've been working with system integrations for over 10 years, and I've been a developer consultant for about 20 years. My area of competence is system integrations, not Dynamics 365. However, I've picked up some useful knowledge along the way. And that's what I will share today. Questions to consider when choosing an integration pattern, not only for Dynamics 365, but in general, I believe. We need to consider requirements regarding if the integration should be real-time, if there will be peaks in data volume, and the frequency. The most common integration patterns integrating Dynamics 365, finance and operations, and other external systems are OData, custom services, and batch data API. There are a number of ways to integrate Dynamics 365 finance and operations with other Dynamics 365 applications. For example, Power Platform, Dual Write, Custom Data Service, I believe that's called Microsoft Dataverse today. OData is a standard protocol for creating and consuming data. OData uses web technologies such as HTTP and JSON to provide access to information from various mobile or third-party programs. A data entity is automatically exposed as OData service. Custom services, I believe, is the old flavor of AX 2012. Custom services are used to integrate with third-party applications and add-ons. Both OData and custom services are considered synchronous integration patterns because when the APIs are called, business logic is immediately run. The batch data APIs are designed to handle large volume of data import and export. The OData is considered synchronous, as I said. It's suitable for handling thousands of records per hour in an ad hoc frequency. Custom services are also considered synchronous and is also suitable for handling thousands of records per hour in an ad hoc frequency. The batch data API is considered asynchronous and it's suitable for handling hundreds of thousands of records per hour. And the frequency is predictable. By that I mean it should be scheduled. When it comes to the definition of large volume, Microsoft has not given a definite answer. The answer depends on the entity and on the amount of business logic that is run during import or export. The rule of thumb is that if the volume is more than a few 100,000 records, you should use the batch data API for integrations. The batch data API has two flavors: data management package REST API and recurring integrations. Data management REST API is scheduled outside Dynamics 365 Finance and Operations. It handles data packages and it's based on REST and is built on OData actions or services. For recurring integrations, scheduling is handled in Dynamics. Recurring integration handles both files and data packages, and it has both SOAP and REST endpoints, and it's built on custom services. Batch data APIs are considered asynchronous integration patterns because when these APIs are called, data is imported and exported in batch mode. For example, calls to the import from package API can be synchronous. However, the API schedules a batch job to import only a specific data package. The scheduling job is quickly returned and the work is done later in the batch job. Therefore, the batch data APIs are categorized as asynchronous. Recurring integrations actually have an internal queue in Dynamics 365. Before we continue to the data management package REST API, let's have a look at the Dynamics 365 point of view. The data management framework is an all-in-one concept introduced by Microsoft. Dynamics 365 for finance and operations. It supports and manages all core data management tasks, such as configuration, data migration, and integration. The main purpose of the data entities is to provide a single platform for data management. Additionally, they also provide foundation for the services framework. It also enables file integration and recurring integrations. Data entities provide conceptual abstraction and encapsulation of underlying table schemas and presents data concepts and functionalities. Data entities are updatable views. They can also be exposed as OData services. If we return to my focus area, we have some considerations. Composite entities is only supported in data management framework. Composite entity is a concept that allows you to build a single entity by leveraging multiple entities that are related to each other. The concept is heavily used in scenarios where an entity can be represented as a single document. For example, sales with header and lines, invoice with header and lines. This concept is applicable in asynchronous integration scenarios rather than synchronous. Recurring integration is built on top of data management framework. The data management package import from package API have some limitations. It can only handle one composite entity per package, and it cannot be called in parallel threads. In an earlier slide, I had a note saying schedule outside Dynamics 365. This is why. Some entities take longer time to post in Dynamics. For example, the ledger entity that we will look at later may have finance dimensions that does not have unique IDs on insert, and then the sequence number are created in Dynamics 365. So that will take a little longer time to process. The error handling differ between data management package and recurring integration. I think we will talk about that a little later. The data package is actually a zip file. That zip file consists of 3 XML files in our example. The data file matching the entity in Dynamics, a manifest holding metadata regarding the entity, and the package header describing the data package. If we drill into the import process, the scenario describes the data management package import flow. We start by retrieving a URL for uploading the data package to blob storage. This call return URL, and it has a file name as input, and that file name need to be unique. Next, we have the actual upload call to the blob storage. And after that, we trigger the import API based on the definition group ID, and of course, adding the URL to the blob storage. After that, we want to know if the input was successful or not. So we will call the get execution summary status API using the execution ID that was returned from the import from package call. The statuses are listed here. Not run means that the import has not been started yet. Executing means that it is in process. Succeeded, partially succeeded, and failed are results when the import is complete. Partially succeeded may mean that some posts, some records are posted and others are not. When it comes to the error handling, the execution ID that was returned from the import from package call is used in the call to get execution errors, like for retrieving the execution summary status. The get execution errors API can only be used for flat structures, not for composite entities. And even though we are using it when we call to retrieve error information from a flat entity, we may not get a result. If we do get a result, it will be an array of values, like in this slide. The execution ID can also be used in Dynamics to search and find information about the execution there. When we connect to Dynamics 365, we use OAuth 2 to authorize access. To retrieve the access token, we need a client ID and a client secret. The client ID is actually the Dynamics 365 application ID. We choose to store that in Azure Key Vault. If Dynamics is going to send information to the Azure platform, we need to set up an endpoint in Dynamics, and we used to put the endpoint information in Azure Key Vault, and then we provide the Key Vault URL to the administrators of Dynamics 365, like this. If it's a service bus endpoint, we use the connection string excluding the entity path. If it's an Azure function, we use the function URL and include the function key. If it's an API, in API management, we provide the URL and the a subscription key for Dynamics. And I want to point out that if we do make changes in Azure Key Vault, it will take some time before they break through in Dynamics, because I believe the values are cached in Dynamics. Also, note that it's not recommended to use version numbers in Dynamics if secrets are renewed or updated, they will have a new version number. Now it's time for a demo. If we start by looking at the data management in Dynamics 365, probably you recognize some of the features from previous slides: import, export, configure. I also mentioned dual write. We have staging, data entities, and so on. This is our import project. Here we could view map information for the import. It's also possible to perform transformations. This is a one-to-one mapping, but you could also set up transformation here. This is the entities. We are working with a ledger journal entity. Here we have possibility to validate, and we also can list the targets fields of the entity. Let's see. And we do have a job history where we can see our previous runs. This was erroneous. That's not much fun. I want to go back. We pick this one. We can view the staging data. And here we see an account number that we will use in our example, in our sample file. We also have the name of the general journal, which is mandatory in our call. And this is the job ID, and it's also the execution ID that I mentioned in the process. I could also show you the workspaces pane. So we go back to the start, and then we have the general journal processing view. And here we can see the job history as well. And we have the name, GenJourn, that we will use. We will also provide the company, the legal entity in our call. That's the view we are looking at right now. We have the account number, as I pointed out earlier. Yep, I think that's it. If we look at the package, we have the general journal XML. That's the actual data file. We have this account display value, the account number that I pointed out. That's mandatory. We also have the journal name, GenJourn, that you saw in Dynamics. And this is the entity that we are handling, the ledger journal entity. We will find that in our manifest file as the target entity. We also have the definition group name. That's my data project that we started with in the data package view in Dynamics. And we also have the package header also pointing to the data project. And we also say that we are using a definition group. If we go to Azure, we have a key vault, and here we have the client ID and the client secret that my logic app will use to connect to Dynamics. And I've also added the service bus endpoint to show an example of how this is set up. And we will provide this identifier to Dynamics when setting up the endpoint in Dynamics, but we will, if I could fetch it. We will not include the version number at the end. And if we go to the logic app, we receive an HTTP trigger connection to the key vault to retrieve client ID and client secret in runtime, of course. I've set up managed identity. I believe that's part of some of the other sessions regarding logic apps. In this section, we will call the get Azure write URL. This is a data management package URL that we use. This is our URI to the Dynamics instance setup. We will trigger a GUID that we will use in the body as a unique file name. Authentication. OAuth2, we use the tenant, the base URL to Dynamics, the client ID, and the client secret. This goes for all calls to the Dynamics instance. This is upload file. It will use the URL retrieved from the previous call. And then we have the import from package. In the body, we set definition group ID, legal entity, as I showed you, and the package URL, of course. The override flag is different depending on if we have a composite entity or a flat entity. Then we will pull the get execution summary status API to retrieve the result from the import. Here we use the execution ID retrieved from the previous call to trigger the import. I have also added a check to get error message in case of errors. And here we also use the execution ID. I will trigger my demo from Postman. Let's start nicely with an input that will work. I have created a zip file from the files I showed you. I have set my definition group ID. I have set the override flag, and I've set the legal entity. Yeah, let's do it. Notice that we will always get HTTP 202 accepted since the logic app received our HTTP call. Something actually went wrong. No, I was too fast to click. Now we're talking. So in the HTTP trigger, we can see the headers that we set in Postman, definition group ID, overwrite, and legal entity. We did trigger a unique file name, and we did receive a URL where we should put the zip file. Oops, the zip file was uploaded. The import from package was triggered using the values that we set in Postman. And we did get an execution ID. The status was succeeded, I believe, since we didn't get any errors. Yay! If we move over to Dynamics, we get to our project. We look into the job history. And here it is. It was nice and smooth. So let's see what if we have a file with an account name or account number that does not exist in Dynamics. We trigger the send. It's accepted by the logic app. It's running. I actually used the exact same header fields, so that's not very interesting. What's interesting is the error message when this logic app has completed. That one took some time. Okay, we did get an error, and if we look at the response message, we can see that we have an array with the record ID, account display value, the main account for ledger chart of accounts shared does not exist. Error found when validating record. Oh no. So let's check the job history. Error. And the job ID, as I said, is the execution ID. So if we look at the staging data, we have the result, the same error that we retrieved in the logic app. That's nice. I think I should run one more because I have time. just copy the legal entity. And here I have set an definition group ID that does not exist in Dynamics. Remember, we had the data project that I have run imports to is the GL import. So if we trigger this one, let's see what happens. It was accepted. And the logic app will run. I'm quite sure that it will be okay. Let's go down to the import from package. And here is my new data project. Oh, long Microsoft seconds. And it was complete. No errors. Now, let's see what happened here. We actually got a new project. So this one was created and it will get a data project as prefix in the execution ID. It was successful, but I'm not sure if the administrator of Dynamics 365 will be very happy if I start sending in new data projects for each call. So that was maybe a little bit out of scope, but I found it interesting anyway. So if we go back to the PowerPoint, let's wrap this up. The data management package REST API is suitable for large volumes of records, and it's triggered by schedule. It cannot, the import from package cannot run in parallel when handling the same entity. This may be an issue if you are splitting big files, if you have real big files. If the package is not set up in Dynamics, not the data project, but the package, you will get an invalid operation exception when triggering the import. Our Dynamics instance was quite nice to let us create a new data project, but I'm not sure if that is a configurable thing. Composite entities does not work with the get execution errors API. Since I had a flat structure, I could not view that in my demo. It's time for questions, but since this is a pre-recorded session, I believe we will take that in a moment. And I say thank you for listening, and don't hesitate to reach out if you have questions or comments. Thank you very much.
Thank you very much also for this insight on Dynamics 365. Lieslot. I haven't worked with it that much, only like 3 calls in my entire life, probably. So for me, it's all quite new. Stevian, have you worked with that before?
Yeah, actually, I'm currently in an integration with a certain company with Dynamics 365 Finance and Supply Chain Management. But in the past, I also did integrations with Dynamics 365 Finance and Operations. And this had to do with pushing invoice data as XMLs to recurring jobs in Dynamics. So kind of similar setup. Although I'm not a Dynamics expert either. With HSO, my current company, we do a lot of implementations with Dynamics, and many of my fellow colleagues are very well versed in this side, this aspect, or at least these technologies. So I work really closely with them. So it's pretty interesting.
When I talked to my colleagues about doing this session, my first thought was that I would have known some of these things when I started out integrating to Dynamics 365. So that's where this all started.
Yep.
There are some special cases.
There certainly are, yes, correctly. Especially when currently I'm working with advanced shipping notice. Might not say much to the audience or you, but yeah, there are interesting integrations possible with Dynamics. So.
Cool. I don't see any questions right now, so I guess we'll also go. There's Matthias as well. We can pull those in on Discord as well.
Yep.
So please continue the discussion there. You can also post your stuff there if you want to use a lot, maybe your slide deck or anything. It's always cool to share it over there because Discord stays alive. The YouTube stuff will probably fade away.
Yeah.
In the
Okay.
future.
Yep.
Thank you very much.
Thank you. Bye-bye.
Bye-bye.
And there he's back again. Just switching screens here. Too many screens open.
Yeah, I saw your studio in Discord.
Yeah, sometimes it's a little hard to find my way through the windows, but it's normal, I guess. Don't have the box. Probably Stevian and Eldert have the box to switch stuff.
Exactly.
No, I don't.
You don't? Okay. Yeah.
I do actually have that, but I don't have admin at this stream, so.
Oh, that's a pity. So I have to switch you.
Yes.
your camera. So you're gonna talk about releasing services with love now.
Yes.
And I think that's a very, very good thing because in the past we saw like my client, we had a Microsoft audit, we do everything with CI/CD, and they were really surprised that we did everything with CI/CD for BizTalk actually. And for us, it's basically just a click on a button and it releases automatically. And of course, you have to do some stuff, but in the end, you know exactly what's where and who has worked on it, and so it's very nice. And I think it's always good to share that knowledge. Yeah,
I agree on that, and it's not getting easier when we go into Azure with a lot of services and dependencies and stuff like that. So yeah, I'm gonna try to bring that into some sort of nice setup at least.
Cool.
And share some tips and tricks.
Yes, then the floor is yours again.
Take it away, Bond.
Nice. So, release with love is what I'm going to talk about, and let's just go ahead and manage that PowerPoint. It's me again, Matthias Löfberg. I work as a solution architect, as mentioned last time, doing something new. So that's going to be up there later on. Just Swedish governments being slow. Anyway. Today, I actually have added an agenda slide, and this is all to Mike, a friend of mine who's actually taught me how to do an agenda for once. So in this one, it's going to be maybe a bit complicated. We're going to do a lot of stuff. I'll try to keep it as simple as possible. So we will have a setup. We will work a bit with ARM. We will look into supporting functions in ARM, and we will also see how everything are. So I will try to keep it as that. So Rob, if you can bring me the camera again. So when it comes to releasing services in Azure, we have a lot of services. I mean, it's often, I don't know, 3 or 4 different services, and we need to bring in these ARM templates that you probably have worked with, and those are not as simple as you want it to be. There are building topologies on top of that, like Biceps, we got Terraform, we got others. I will today use ARM, but I will use something called master template. So that's how I want to simplify my release process, by bringing in that microservice thinking in the release process as well. So that's the thing, and I think we make these releases. I'm just not sure if I'm alone, but I'm assuming more of you have this issue that we almost spend more time on the release, building the release, rather than actually developing the things in Azure. I think I see some nodding heads over there. So I think that's an issue that we have from project perspective, that we tend to be done, and then we just need to build our release process, and that takes a lot more time than we want it to be. So I'm gonna try to do. That's what I'm gonna try to help you with a little bit. So I hope this will be nice. So let's jump back in, and let's see how my setup is looking, because I think that will be the important part. So I have a DevOps instance that we will be using. I got a demo project, and I have an environment. My environment today is a dev environment, which consists of these 3 resource groups. And why I have 3 different resource groups is because I have infrastructures supporting stuff, and I have an API, and I have a function. So that's why. So if we go into the shared one, which has supporting, we can see that we have a few of these supporting stuff, like, we got application insight, we got a key vault, we got a log analytics workspace, and we got a storage account. And that's like the base pipeline. And then we have an API management instance, and we will also talk a little bit about the next step will then be publishing an API. So I'm dividing this into 2 parts. Let's just kick the release done, because releases always take some time. So let's just go into this. I have into my repos, which we'll look into shortly, I have 2 build pipelines. These are very simple. They only publish my my ARM templates. And then I have a releases, and I have a release for my order API, and I have my release for infrastructure. So I only have a release for dev right now, and we will actually do the test as we do now. So let's just go in and look at the edit. As you can see, we will releasing all the supporting stuff, all the application insight, key vault, we will release the storage account, and we will release API management instance. And we will do that in this one. So let's go check the tasks. I only have 3 tasks to do this. That's all I need in this one. So I need to copy some files to blob storage, because I want to utilize ARM with my master template setup. And then I got a release for my shared resources. And after that, I have a release for my API management resource. And the only reason I don't have these in the same release is that I need to create the resource groups by themselves. And then this is a good way. In order to support this, I have some variables. And you might think that there's a lot of variables, but it's not. I'm using an environment variable, which contains the current environment. And I need to be able to pick those files from that storage account. So I need to get the storage source token, the URI, and the blob prefix. So let's just go ahead and look into variables, and we will see that I have a blob prefix, infra, and an environment dev. Cool. Let's go back to this one. Let's clone this, and let's create a test environment. So that's what we want to do. So let's change the name of this one, and let's go to test. And now I need to fix that variable stuff. So what I can do now is that I get this environment. So I want to set this to test in test, because that scope over here makes it only available in that scope, which means that I could, as I did, just copy my previous step if that's all right. And the only thing I need to do is test. Seems simple enough, right? This is how simple I want your releases to be as well. And that's what we're gonna talk about today. So let's just create this one, and I'm crossing my fingers that it's working. The demos gods are with me. So this will be starting, oh yeah, we'll be doing dev first and then test because I have set this up. So let's bring in to actually look into what's going on because this will take a little while. I'm wondering if I should just do that. Yes, we do that. We can look into that one later. We can go ahead. So let's just go into VS Code. So this is my repository that I have brought down. I have a few templates in this one, so everything is just ARM templates all over the place. I got an AI template, an API management template, Key Vault, and I have an API, and I have a master API, and a master and a storage template. And these are pretty small, so all of these are just basic templates. These are having standard stuff that are very small because I want to keep them small and simple. If I want to change something, I want to do that in these templates. So these are all very small and they have a lot of default values in them. So I think I have just a name that's actually not having a default value. If you look at the API, we will see the same. We will see the same stuff over here. Everything is rather, this is bigger because it's bigger, but it's rather small anyway because it only contains this resource. We usually build rather big templates, but that's what I want to avoid. So if I'm going to my master template, you can see that this one has some environment parameters that we saw passed in, and we have the SAS token, container URI, blob prefix parameters. And then we use variables because when doing this, we often have a good naming standard. I hope you do. I'm using one over here. I'm using a rather complex one just to show it off. So my naming standard is that all my resources start with M. Lugberg. I'm an ego guy, you know. And then we have the environment, and then we have some name that actually describe it. Which means that if I want to bring this up in a new environment, only thing I need to do is actually change that environment. That's the only difference in everything. So in all of these, the only difference actually is the name. And that's what we're doing with this environment variable. So that's how we can pass that variable in as test and dev, depending on the environment we're doing, and bring that into our environment. So what we are doing is in our dev and in our test. Let's just short look at the release. There we go. Dev is deployed and test is working. Sounds good. So we have a few services over here, and we want to bring them over there. That's what we're doing right now. So what our release is doing is creating these services again in what we have defined as our test environment. In my case, it's the same subscription, just different resource groups. Probably you have a new subscription, then you need to switch the deployed resource group, obviously. But this is what we do. And based on this, we actually have, as you saw earlier, we have one of these is a file. So if we go to the VS Code again, we can see that we have application insight, and this is a file. We have one for Key Vault, we have one for log analytics, we have one for API management, we have one for storage. All of them is rather simple. So we're actually creating a master template. Master template part is actually creating, and then that is linking in templates. So we're using smaller templates, but building blocks, like building blocks, I would rather say. And it's orchestrating this deploy. Also breaking dependencies, so I can say that we need to buy these we can run in parallel, and this one we need to have this and that in front of it or deployed before. And I can make sure that in the end, when this has been executed okay, I can make sure that all my services are okay and deployed in the appropriate order. And it's very easy. If I want to add something new to this, let's say we want to add another storage account. We can just fix that in the master template. We create a new file in our repository. In this one, we create a new file. We go into a master template. We need to create the variables and the link to that template, but then we can just add it to the resource list down here. So this just copy this part, and then we can add it again. And the beauty of this is that when we go into the release pipeline, we don't need to manipulate that at all, because we rely on this master template, orchestrating and fixing and reading it in. And how it does that is this template link part. So ARM gets this master templates, that's what we're sending in, and we get the instructions, we create these variables, and then we get this URL. We create this URL, and ARM downloads that URL and executes that as a step in its process. So let's just see how our release went. Oh, it failed. That doesn't seem good. I even tested this yesterday. Demo gods are not nice with me. Let's just try if that is let's just go ahead and do it like this. Let's hope that it's just a simple one. So let's go to resource group. Let's see how it went. And let's just add test to this search. Test shared. Okay, so test shared went in at least. And we can see that we got some of those resources over here. So we got the AI, we didn't get the key vault. So that's the param. Let's just quickly look in to see if that's something that what's the key vault? Look. So you get a release for everything in this, and let's just see really quick if we can fix this. Soft delete with the same name, code conflict error. Crap. So this is just because I run this before, so it has a soft delete, and I don't have that stuff ready to execute, because you need to execute the API. So let's just go ahead and be a little bit nasty about it, and let's just go ahead, go to the master template, and crap. Okay, let's remove that resource, and just to get it in, because we need to have. Maybe we don't, by the way. I think we can do it like this. Go to release pipeline, and let's go to test. And let's just do, edit release. No, edit pipeline. I fixed this for API management, but I forgot about the key vault. Let's go into the tasks, and let's just go to test, and let's just make sure that this is run anyway. And let's have control options, continue on error. And we have control options, continue on error. There we go. Save. Okay, so I won't be able to get everything up. Soft delete key vault. I can get that out. Let's not dig too deep in that. As mentioned, I can then guarantee my releases. As you saw, I failed on the key vault, and then if I do that, that resource won't be available, and my release will fail. So if that one fails, we will then be bringing that in. So this is bringing in our environment. The next step that I'm going to talk about is bringing in an API, and when we are creating our environment, so we have our services, we have our, in this case, our APIM instance. We'll get some tricky because the key vault is not working, but let's do this anyway. And let's just have we're going to have an API called orders in this one. This order in itself has a function app, And as you know, function apps connect to app insights. And it also connects to a storage account. And its next step is actually connecting to a Cosmos. So this is a setup that we have, and this is actually what we have in dev. So if we go back and check out the dev, let's go to resource groups again, and let's go to Emluberg dash dev. So we got the dev API and we got the dev orders. So this resource group orders is the one we talked about for the function app. So in the function app, we always have a few services. We have a function app, we have a storage account, and we also have a app service plan. So these three is existing. We need these three. And we also have this one connected. Let's just see. I'm just curious how this went. And let's just see if we can have a... This one is connected to application insights. So we can see that we have an application insight setting as well. So we can see view data and the system. Your application is connected to application insight. And all of these things we want to get with us when we release to the next environment. We want to make sure that we don't manually need to do things, because everything that you do in the GUI and Azure portal, you can actually do via ARM templates or via CLI or via Terraform or whatever your choice is. But you can do all of them. So you can do linking and stuff like that. You can even grant access to Key Vault for MSI. So you can dedicate that as well. And in this case, we will link application insights to our API. And we also have then the API itself. So in Dev API, we then have Dev API, and we have it right. We got some APIs in this. And we then have the orders API version 1. And we have a bunch of operations. All of these is actually protected. So get my orders, I think it is we're going to use. So all of these is actually protected by policies and job token validation and stuff like that. And we will bring everything like this in. We don't want to have anything in this replaced. So everything should be in there, and we should have the keys for functions. We should have everything over there. That's the plan. And that's our release, to make sure that everything goes from dev to test. And let's see, now it's deploying the API management part. That's good. And as mentioned, we can test this right now. So we have this. This is a Postman call. So this is the Emluberg Dev API, as you can see. So if I press send over here, I will get. Oh, I did get the token earlier, so I hope that worked, and because I'm sending that authorization, we then get an order back. This is our order. In this demo, I want to be able then to do the same. So if you scroll this one out, I actually want to do this because this is dev. I actually want to take everything of this and put this in test. And I want to be able to execute it without any manual stuff at all. So I will use the same approach. I will use that master template stuff. And let's just check that my infrastructure comes in so that we can actually do. So partially succeeded. That didn't work. Let's just hope. I pray that we get these things in now. And resource groups. Come on. Let's hope we have the test API. Nice. Let's see that we have the API management. Yeah. Nice. Sorry. So we will bring this in, and you will now see that this is empty. This API is completely created right now, and we won't have anything in it at all. And we will see that now. We will just have that no APIs to display. So this is just an empty one. And if I go back to my release pipeline, I really hope my next release pipeline works better. We will do the same for the OAuth or API. So let's first just create the release, and then we can go back and check the files to make sure that we have some nice files. So in our tasks, we have dev, and we have a little bit more here because when releasing a function with us, we need to do some stuff to get it working appropriately. So we do the same. We upload our templates. We have the same style. Templates goes in, and we have templates for each thing. We then deploy the order API function, which means that we deploy the resources in the resource group for the function. And that is because we need to prepare the function, what do you call it? The function resource for code. Then we can deploy the code. We can upload the source code, and we can then run. We then need to get the master, the host key. In order for API management to call the function in a secure way, we need to provide a key because we have a function level authorization. And in order to get that one, we need to actually get the key out as well. And unfortunately, there is not a function in ARM that can do this, so we need to do this ourselves. We then bring out files again, and then we deploy the API itself. So this last step will then create up the API in API management. It will connect to the function, and it will be ready to use. So that's the plan. We actually have some more variables in this part, since we have some more stuff to do. Even though we don't have that much that we need to change, because I added this in the variable management, that the function name and the environment name is managed. You can see that in a short in the templates and in the pipeline. So we go back and we do this, and we do clone, and we create this test. And then we go to variables again, because we need to make sure that we have good variables for our test. So we have a test, and we can add that to, I can leave that one. That's good. And then we create the release. There we go. So let's hope this one goes better than the last one. This release will now kick off. It will do dev first and test second, because that's how the setup is. But let's just look into some of these things that we are using. So I talked about it earlier, and I could have shown it actually in this API management part. The master API management, the API management is also connected to the application insight, by the way. So when we create this insight name in this master template for API, I can then send that downstream to my release pipe, my template for API. And in my API management template, I can then actually go ahead and do something called, there we go, reference and resource ID. So I can actually look, I can tell ARM that this is my resource. So this is my resource. There we go. And I want to get this resource information, just this particular one. And when I do that, I will go back, and I can then go in and I can get that instrumentation key, which is the key that I want to use in my logger in API management. And there we go. So that's the part we do. And when we jump into our OAuth and we go into our order, we can see that in this part we have the order function, which is the code, which is compiled during the build step. We're skipping that for now. But we got ARM templates for our order function, and we got ARM API orders, and that we got ARM templates over there. So in this one, we also have a master template, and we have the dev test prod settings. Let's scroll that one down. I'm actually getting the Cosmos to this. I'm actually going out and getting Cosmos information. So I'm using bindings, so I need to have this in the application settings, which is fine. So I can then send this information down to my function. So this is my storage template, my template for the function app. And I'm sending in my application insights, and I'm sending in my Cosmos account, which then varies depending on this environment, because that's the only thing that differs, more or less. And if I go into that template, we will see some nice stuff. No, thank you. Let's go in and let's just scroll down to, here we see this again, the reference that we're actually getting the instrumentation key. We can also get the connection string for application insight. We also have down here, we have the list keys. Doing the same, we find out our resource. We want to have the key. We pinpoint this one, and then we go back and get the information we want. And list keys is another of these nice handy features. So then we can get the key of the storage account in this case, and we can also do the same for our Cosmos. So we can then create the Cosmos connection without, we need to know the Cosmos DB account. That's all we need, as long as ARM has access to this one. Remember this. So as long as ARM has access to this resource, it can go out and grab that information if we wanted to. So that's what we're saying. We're going over here and we do the list keys again, the Cosmos DB account, and then we get, in the end, the primary master key, which will then be populated. And we have a valid connection string that we can use, and our function is connected to the Cosmos, and we didn't know about the connection. We have no idea what that primary master key is. We don't have to manage it. We don't need to put it in a key vault. We can just say ARM handle this for us, which is nice. We could also have gone to key vault and asked for it, or we could have built in functionality into our function to actually go and grab it from key vault as well. But we will just keep this as now to let ARM do it. So let's check out that release. So let's just see if this is okay. So this is working now. Let's check the logs. Okay, so this is working. Good, cool. And this is part of being able to do this, being able to actually bring everything in again and don't need to manage it is the beauty of it. I also added one more thing that I wanted to show with the key vault, and that was actually going back to my previous session. And it's something called, when we do releases like this, we can actually get the permissions. We can actually set the permissions directly via ARM. So if ARM has ability to do that, we can actually create permissions. So this little part is actually key vaults and access policies. So I can then reference any resource in that I have accessible, or ARM has accessible, and then I can set the permissions. So as you can see in this case, you will do get and list. And since the test failed, I'm not able to actually go ahead and show that. So I will show you in how it looks like in dev environment, just to make sure that we can do that. So I will show the dev, and let's just go ahead and set dev and shared resource group. Going to key vault. Oh yeah, let's just bring in one more thing. Sorry, I'm going to do one more thing, because this relies on me having an identity. So this is bringing in my principal ID, the identity. So in my API management template, I actually have this part set as well, just to make sure I have my identity. And since you can have managed entities and system assigned, I just added it as a setting, and I will show you how it looks like. And this is my identity. So I have a system assigned identity. So it will create that into the AD, and I will be able to give them permissions. So what's really happening is that if you go into access policies, you can see that I have a bunch of access over here, and this is my mBluebird dev API, and that has this get and list permissions. And that's all set by ARM, which means that from my perspective, I just need to know what key vault to go through. If my service principal that I'm using with ARM has access to it, I don't need to understand more than I have a key vault name, the resource group, and then I get a subscription, maybe if you're doing cross subscriptions, and then I can get that from that. And in my resource later on, I just need a name of that secret. I never need to understand the secret. I just need that name, which makes it really simple for me to do a release, and to do a release that's working every time, over and over again, because there's no hiccup on the line. I just need to make sure that I have the appropriate values, and someone with another hat on it has added that password into the key vault. So let's see how that release goes. Seems like we're doing fine. This takes a little bit longer than I hoped for, but yeah. So we should have a function app deployed. We should have that done, so we can start checking that out. Let's do that. Let's go back to our, and make sure that we actually get these values that I'm talking about. So let's just test orders. And let's jump into that function app and make sure that we have some functions in it, and that we have this setting as well. So let's just go into configuration, because this is the interesting part. And dun, 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 dun. Come on, help me out. There we go. We can see that we have this Cosmos connection, and if I click this one, we can see that I actually have. Let's go ahead and let's just take advanced edit. Be better. We can see that our instrumentation keys is popping up. We can see that our storage account is popping up with account keys. Nice, as we want it to. We can also see that we have this Cosmos connection. So we have a Cosmos connection running up. We got the account key. We got everything we need to connect, which is really nice. There we go. And so when this is up and running, we should be able to go from our API management into the Cosmos and get our data. There we go. So everything is now released. So let's go into our test API. And let's just go back and reload this test API again. That was currently blank. We got APIs, and we got orders now. We got V1, and it seems to be up and running. We can get my orders, which is the function we use. We can verify that the policies are there. Everything is there. Cool. And we can then get a subscription key. Let's just bring in the subscription key for built all access, so we don't have to do a bunch of stuff you already know. So let's just copy that. Let's head over to Postman, and let's just change to API test, and let's just go ahead and APM key. Oh, sorry, edit APM key. There we go. We press send, and now we go to the test, newly deployed test, and we did everything, and I get unauthorized. That is fun. Let's just see if that's the token, and let's go ahead and let's just try again, or if it's my key maybe. MWB test API. Resource not found. Interesting. Let's go to APIs. Let's go to orders. V1. Interesting that they changed the result. Get my orders. Let's go to test and just get the URL from here to make sure that we're not doing anything. I didn't do any typos. Let's just go ahead and do that. Let's press send. I get that. My demo gods are really not with me today. Current E. Dun, dun, dun. Okay. Let's copy that. Let's see. We copy that to the subscription key again, and we go back and we copy it. We put it down there. And we press again. Is the resource not found? Interesting. Okay, my demo is not going very well, so let's just go ahead and do a test over here and add the authorization. Let's just copy it from here. Let's just go ahead and copy. Copy that one and no, not query, sorry. We'll have a header. And let's just copy the bear token that I had from over here. See what I'm doing wrong. And let's just copy. Send. Oh, so let's just delete that one and let's press send. 404 not found. That's very interesting. So I'm getting that from the backend, of course. This is, of course, my function app that is responding that one. So something went wrong with my function app. Let's see what that seems to be. So my function app. And let's see my functions. So much fun. Huh. I don't have any code in here. That's really interesting. Yes, restart that one. And let's just go ahead and deploy this one again just to make sure that we get the code in. Some reason I didn't get the code in, which is interesting. And let's just see if I go back to the order again and let's go to functions. If my restart did anything. It did not. Okay, the demo gods are not with me today, and I will make sure to wrap this up instead. It should have been working, but as you can see, at least I'm connecting my services. So my function app and my order API is connected, so they are connecting in. And to prove that, since it didn't work, we can go to test API. We can actually go back to and we can go back to backends because we are creating a backend in this part, and we can see that we have this FA orders API, and we can actually see that this is the FA001 test API. And the problem is that we didn't get the code up, but we did get the FA order test API. So at least we get the connection up and running in API management at least, and we just need the code. So let's see if that can run through and we can get up. But we were able to connect these. We were also able to connect the correct AI, the correct storage, and the correct Cosmos. So everything is done through ARM. And if we would have get the key vault as well, we could have shown that we get the permission set as well. I just missed that soft delete part where you have to go and purge the delete or wait 48 hours. And since I tested this last night, that failed. As a see how that deploy goes. Let's just see. Okay, that's gonna run through. So let's just wrap this up and present. There we go. And I don't have much to show more than that. I want to bring up this. Key takeaways is I'm trying to show you that master templates is very good to use to simplify the release. Hopefully you saw that part where we actually just work with variables and then sending that into templates. Updating underneath resources is just managing that template that is small and should only be for that particular resource or the needed resources. So for function app, there will be more. There will be the function app, a storage account, and maybe something else that is needed. But for key vault or storage account, they should be very kept small. Then we use pipeline variables. There's also a concept called variable groups that I didn't go through, but make sure to look into that because then you can actually switch a whole set of variables depending on the environment, and you can reuse them in different pipelines as well, which makes it easier to manage these variables and also make sure that all your releases to the same environment has the same values. Use ARM to get secrets and links as much as possible is one thing that I use. I know that it's get messy to learn the ARM template language and that list secrets stuff is tough in the beginning, but when you get the hang of it, it's really good, and it makes it so much easier to move between environments. And have you learned it for Cosmos once, you will have the same for every Cosmos instance you have. And also make the release as simple as possible, both in the pipeline setup, but also as per resource. Make sure to put in the resource you want, but avoid a lot of manual handling or too much overhead, I would say. So using master template to simplify variables and secrets, bring that for that. I'm just gonna try and see if we get this demo up and running. Let's just hope that I get this. I get some functions. I have some time left, I think. This is not my day for this function, I guess. Ah, there it is. Now I have it. Let's just try it out. Let's just see. There we go. Everything worked this time. So all I needed was to release it again for some reason, because the code was not there. And yeah, that's all for me. And I hope you have enjoyed this and learned something new. And back to you, Rob.
I was muted. Oh, Stefan.
Hey.
Both clicking the button doesn't work.
Adding stream.
We were actually chatting before Matthias' talk about demo gods and how it's the thrill to do it live. But so we jinxed it probably. But in the end, actually, it worked out. It worked, right? So,
yeah, I did. I don't know why that function.
I think it is a lag time because under the hood, you're going to the Azure resource provider, or at least the resource provider of those services. And I think it's just communication between, all these layers,
Yeah, something like that. Too bad I forgot about the key vault as well, because that soft delete stuff is you don't really see that anywhere. You have to do it under the hood.
Mm-hmm.
yeah,
But anyway, I hope it was interesting anyway, and that you learned something new along the way.
Oh yeah, for sure. Yeah, this is
yeah.
Things we're doing as well with our projects, and I know it's you reap the benefits in the end, but it can be complicated in the beginning. That's true.
Yeah, I mean, starting off doing this is hard, but when you have done a few of them, then it's a lot of copy pasting. It's a lot of getting these things up, and you have the the simplicity to actually release it in a good way.
True.
And always the same way.
Yes, that's also important, because that's what we want. We want to rely on our releases. We want to make. I mean, it's really beautiful when everything just works and you can see it all over again and again and again and again, and it's just working. And you can just say, I want to have this in production, and you know that it's going to work. And that's just, I just love that part.
Perfect.
Awesome.
Then we have a small break now.
I think we do.
Yeah, and after this, Mike is up at 12:15 UTC. So in 15 minutes, we'll be back.
15 minutes, Mike. I know I already see him in the background. He's ready.
Yeah, he's saying he's going to do it in 45 minutes, but he's taking 60 minutes probably. Who knows? We'll
That's
see.
a good one. Thank you very much
guys.
for me today.
Okay, thank you.
Enjoy your day.
Matthias.
Thank you.
Hope to see you again in person someday.
Same to you guys. Or to all of you, actually. I'll see you soon. Cheers.
Cheers.
Thank you.
Okay, and we're
Yo.
back.
Gents, how you doing?
Good.
Doing good. Doing good.
It's like quite a good day going on today, mind.
Yeah, there's quite some stuff going on. Global Automation Bootcamp with the Overtrack. It's the Global Integration Bootcamp. That's
Oh,
us.
no, it's Scottish Summit as well, isn't it?
Yeah. And I'm talking.
What is going on with your webcam? Because I noticed this the other day where you've got a very distinct blue glow to you.
Yeah, I know. I'm not sure how to adjust the light, so it's a bit better wrong. But yeah, there's also a green screen behind me. But
it gives you a bit of a kind of sort of alien look.
It's special, maybe because of the blue screen, green screen stuff you can do in StreamYard. That it kind of adjusts it or something. Yeah. Okay.
It's just with lights, so yeah.
So, I guess there's no introduction necessary for Mike, is there, Steve?
No. I think everyone's familiar, and he's got 45 minutes, so.
Yeah, let's jump right in. And always interesting to listen to your sessions and watch them. So, take it away.
Thanks, guys. Hello, everybody. Really honoured to be asked to present at the Global Integration Bootcamp. It's really great that it's online this year as well, so we get to talk to so many more people, and I hope everybody's having a good time. It's a glorious Saturday here up in Newcastle. Quite a funny little story before we jump in. So I'm in the log cabin at the moment, and normally I have the heating comes on to warm it up in the morning. And I forgot to put that on, so I came and turned it on manually with a quick blast to warm it up, and then forgot to turn it off. So as well as being glorious, it's currently about 26 degrees in the log cabin, and I'm absolutely dying. So, but anyway, to jump into the topic for today. So I had this session I've been wanting to do for a while called "Can I Build an Enterprise Integration Platform in 45 Minutes?" I'm going to show a little bit about how to use Terraform to manage and provision Azure environments, and so as we go through this, you'll kind of see how we address one of the big challenges that we've had. One of the things I need to do before we start, obviously, I need to. I'm going to just jump a screen across here. I need to kick off a pipeline. So usually I would forget to do this. I need to bring Azure over as well. So here you can see in Azure, I've got a number of environments. I've got a resource group called environments.test. I want you to see that this is currently empty. So there's nothing up my sleeve in the magician style. And what I'm going to do is I've got a pipeline over here, which is going to go and basically start building the foundations of my enterprise integration platform. So we're going to kick that off. And then I'm going to just let that chug away doing its thing. And we're going to come back to that later on, and we're going to talk for a bit, do some demos, and see how our integration platform goes. Fingers crossed, we'll have something done inside 45 minutes, but we'll see how we go. So if you haven't met me before, I've been a Microsoft MVP for 12 years. I'm a freelance cloud architect based in Newcastle. I'm also involved in integration user groups, or Integration Monday, you might also know it as. So we do sort of webcasts on Mondays usually, which is why it's called Integration Monday. I also blog quite a bit and run something called the Integration Playbook. So there's some good community resources if you're interested in the integration area. This is my reminder. Mike, don't forget to start the build, which I've done, and I knew I'd probably forget, so I put a reminder in. So agenda for today, I'm going to talk a bit about history of building integration platforms, and touch on BizTalk a little bit. I'm going to talk about integration on Azure, and then we're going to jump into Terraform and do some stuff. I think there's actually 3 demos if we've got enough time, so that agenda's slightly wrong. So let's think about BizTalk, and a typical, a lot of the people in the integration bootcamp probably came from an integration background with BizTalk. The stuff we're going to talk about today, really with the BizTalk bit, I'm setting the scene of some of the problems we used to have. Once we get onto the Azure bit, it doesn't really matter whether you've done BizTalk or not. Really, I'm going to talk about how we can do some stuff in the future. So BizTalk environments typically look like this. We'd have a SQL cluster, we'd have AD, some storage, BizTalk servers. And when it came to setting up an environment, there were so many difficult things to do to set one up. We had SAN to get sorted out, users, groups, backups. the list goes on here. I've just done a brain dump of all the things I can think of. The top and bottom of it is BizTalk environment builds used to be painful. If you were fortunate enough to have the time to automate them, it made your life easier. But actually, the reality was, even if you did automate them, the minute you had a BizTalk upgrade to do, suddenly you've got another nightmare to deal with. Of having to redo all your scripts and redo your documentation. And there was also lots of very specialist skills involved, and usually it took multiple teams to be able to build a BizTalk environment. Now, multiply that by the fact that there isn't just usually one environment. You usually had developer machines, test environments, and production. That would be a fairly simple kind of customer who used BizTalk. Complex ones would often have multiple environments, and the problem just gets bigger and bigger and bigger. And I think in one of the previous sessions, somebody mentioned how actually we can spend more time doing, I think it was Matthias maybe in the last session, which I thought was a really great quote, more time doing these setup things than we can actually solving business problems, which I'm totally on board. I think that's really one of the things we have to sort of spin that round and spend more time delivering value. So if we think about some of the things to consider, so, if you come from a BizTalk background, just have a think for a moment. What's some of the largest number of BizTalk environments you've seen? How long did it typically take for your project to set up your environment? It's not uncommon that it takes, minimum days, but possibly weeks. And I've seen environments that have, because of all the challenges organizationally and in addition to technically, can see it take months sometimes. You spend a fortune building your infrastructure, and it's this massive upfront cost before you actually start getting any value, which I think is the biggest problem. So let's pivot now and we'll talk about Azure, and let's think about what does an enterprise integration platform look like on Azure, kind of the alternative to that BizTalk diagram. So here's a diagram that similar to what I've done with a few different customers. If you think about the different assets on Azure that play into your platform, you've got things like logic apps, integration accounts, functions. You've got the operations stuff like log analytics. You've got queues, APIs, and all this fancy stuff. And really, I think we're in the point now with Azure integration where we've got a set of assets that we can pick and choose which ones apply to our platform. And as we get a new use case that needs something different, so for example, you might not have API management when you start. A couple of months down the line, you might have a new project that needs it, so you can easily add it. And you just build up this platform that covers these different areas. Now, when it comes to environments, typically we then have dev, test, prod versions of these different things. And we do have a similar scenario as before, where usually we have a snapshot of what our platform looks like replicated across multiple environments. And that sometimes there's some sharing and there's different ways people spin it based on physical deployment models and stuff like that. But that's really, it's the same scenario where we've got lots of resources to spin up and different environments to do it in. So with Azure, some of the big benefits are the automation capabilities are so much more advanced than what we had back in the BizTalk days. So you could do it. It was just painful. Now it's a lot. It's a lot more powerful. The question's really more about how effective you can be when you do it. Sometimes you can do it and it's really difficult. Hopefully today I'm going to show an approach that we use on projects that makes your life a lot easier. So hopefully that kind of resonates with people who are listening, and you can see something that could benefit you if this is a problem that you have. So jumping into Terraform. So Terraform is something you might have seen me blog about if you follow my blog. It's one of my kind of favorite things to use at the minute, because really it's about provisioning infrastructure. So if you're familiar with the terms desired state configuration and infrastructure as code, Terraform's really in that space. And what you can do is you can define files that describe the infrastructure you want. And the idea is that it's relatively simple to understand, and it can give you an experience where you can do like a developer experience, but for building infrastructure. So what we'll do is we'll define our setup. We can then plan what's going to happen, check we're happy with it. We can apply the changes. We can roll back changes. We can destroy the infrastructure if we want. And we can also abstract the clouds that we talk to. So you can use Terraform with Amazon, Google, Microsoft Cloud. You can use it with on-prem infrastructure. And the idea is that you can describe your infrastructure, and the provider model for Terraform sort of deals with the complexity of each each cloud, for example, you want to talk to. So you could, an example would be, I can have Terraform set up that can provision in both AWS and Azure from the same setup. So if you've never used Terraform before, here's a quick view of what a Terraform structure would look like. So you'd have your project would be kind of like, in my case, I like to do it in Visual Studio, so it might be my Visual Studio solution. I then have some files, so we'll have these .tf files, which will be used to describe the resources that I want to configure. I can define variables, which we'll have a look at in a moment, and I can also have these .tf files where it lets me override the variables for different environments. So I can have, development, production, etc., etc. So I think if we just jump into a quick demo here. So what we're going to do is over in my resource groups here, you'll see I've got these resource groups all up and running for each environment. But what I'm going to do is have a look at building a new resource group with a couple of really basic resources in, just to introduce everybody to Terraform. So I've got this solution over here called Terraform Intro, and let's have a quick look at a couple of things. So first off, you can recognize I've got some tf-var files, and I've got this this tf-var files as my variables, and these .tf files are actually the scripts. So what I usually do is when I start off, I usually have main.tf is you don't need it to be called main, but I usually call it that just because it gives me a place for my brain to go to when I start looking at it. This is the starting point. And what I'm going to do here is there's a few things. So firstly, you'll see the format that we're going to use is a little bit JSON-like, but it's simpler, so there's a lot less text to worry about. And if we walk through what we're doing here, so firstly, this bit here is going to tell me that I'm using Terraform and what version of Terraform that I want to use, so I can go between different versions very easily. The next thing I'm going to do is here we've got a provider declaration. So I'm saying use the Azure RM provider, and there's a couple of settings you can set on that provider there as well. And then this basically lets you it manages your context when you're connected to Azure. So what I'll do in a moment is I'll come back to how we run Terraform, but just bear in mind that by this point when I'm going to run it, I'll have had a connection to Azure. So you can just do AZ login as if you're going to use Azure CLI, and Terraform will just pick up your connection. So what we need to do, in this case, we're going to basically build a resource group, build a storage account, and put a couple of things in it. So we've got the main thing we would use in Terraform is called a resource. And if we define an object, you can see here we have this keyword at the start that tells Terraform it's a resource. We have a type of resource here, so that this kind of first line is really made up of three things. There's resource keyword, then we've got the type of resource, so in this case an Azure resource group, and then after that we've got a key for it. So one of the things to note with Terraform is when you run it, it looks at the state you've currently got and what you've got in your config files and works out a diff of what changes need to be done, and then it'll go and kind of tell you about them and give you the choice to apply them. So this is where the state file, each resource you kind of manage needs to have a key in the state file so that it can work out which one it is. So as an example, every resource group that I have needs to have a unique key so it knows which one's which. And to set the resource group up, all I'm going to do is give it a name property, and I'm going to give it a location. And you can see here I've pulled these in from my variables file. So at this point, let's take a quick look at the variables. So what I usually do is I've got a variables file over here where I'll actually declare the variables. So you can see here I've got ones like a prefix. I think which one were we using? Resource group. So if we have a quick look down here, you can see I've got one called resource group, and resource group location, and all I'm doing is just a description and then a default value. So I'll maybe talk a little bit later about the build processes that I use if we've got enough time, but what I'm doing here is you can give it a default value. When I run a build, I'll dynamically inject a value into it. But for when we use variables locally on my dev box to run this, what we can do is use these TF-var files, and I can actually supply the values directly in this file. So you can see here, I've got instances of these resource group and resource group location, where I can just pass a name in, and I can pass the location I want it to, to deploy to. So that's going to set my resource group up here. Now, where this starts getting really interesting now is next I'm going to create a storage account. So again, I've got a resource declaration of type storage account. I've given it a key, but I need to now specify some properties. So firstly, I need to give it a name. So here I'm going to use some of the formats with Terraform where you can start dynamically creating the names for them. So here I've got a reference to my prefix variable that I'm going to give to all of my resources. I've then got a variable here which lets me specify what environment it's going to belong to, and then I can give it a name that's going to belong to that resource. So really, when this runs at runtime, I'll get a generated name that'll be a sort of concatenation of my prefix, my environment, and then whatever I want the resource to be. Next up, we've got the location and the resource group. So we need to tell this this storage account where to be and what resource group to live in. And this is one of the bits where I think Terraform starts to get really strong, is that what I can do here is I can reference another object. So I'm going to say, look for a resource called of type resource group. So I've got one up here. I give it the key. So that's going to point to this instance of a resource group. And then I can just get it to reference the values from that resource. So basically it's a way of me saying, rather than having to specify the values directly each time, I can just specify them once on this resource group and get everything else to just point and inherit them from the resource group effectively. Then I can set a couple of properties here, like the tier and stuff like that. And then running it quickly through just to kind of build this, I can then add a container. So we give it a name and we just point to the storage account here. So you can see I'm pointing to storage account above, and then I can create a queue as well. So that's really how we're going to configure this. Now, what I can do if I go into my command line here, so I need my other one. So there's a couple of commands that I need to run Terraform. So the first one is I'm pointing to the folder that my demo's in, and I run Terraform init. And what that does is it goes and looks at those declared providers that we had over here. So this 0RM one, and it'll actually import any assets for it. So that's currently downloading v241.0 of the Terraform provider. We then need to we can do Terraform validate. So where I think Terraform also has a strength is when I'm writing these files, I can run the validate command and it'll tell me whether that's good or not. So if we see there, it says, yep, everything's fine. If I put a typo in my file, so let's say I just put a 1 on the end of that and save it, maybe. If I run validate now, I should get some kind of error. So you can see here, unsupported argument, and this is really telling me that that property name's not right. So I can actually go and get some validation that my scripts and my configuration's good without having to attempt to deploy it. I can sort of deal with those issues straight up. Next thing we're going to do is I'm going to run this command here called Terraform plan. So you can see here I'm saying Terraform plan, and then I pass in my local variables file. And what this does that I think is really cool is this goes and looks at what I've got in my state file, what I've got in my deployed resources, and then work out what it needs to do. So the idea here is it can say, here's a plan of what I'm going to do. So you can see the plan result was 4 things to add, nothing to change, and nothing to destroy. So it's telling me here about the resources it's going to add. So if we just scroll up slightly, so it's going to add a resource group, add a storage account, and then further down we'll see add a container and add a queue. So I can decide, am I happy with that? Yeah, I am. So I'm going to apply it now. So it's going to just do a couple of checks there. Kind of reconfirms, because I didn't use the auto approve flag, reconfirms what I'm going to do, and then I can run it, and that's going to go and provision those resources and kind of let us let us have that set up when it's finished. So you can see it's going to go start creating some stuff here. And if we go back to Azure, and I'll just put this kind of up here, so we should start seeing that appearing in a minute. So this will be an Azure cache thing. We'll just refresh that. There we go. So there's my resource group. It's always the same when you do a demo. The Azure portal is your biggest nightmare. Let's try that again. So you can see here we've got our resource group. We've got in the containers, we've got the container I specified, and we've also got the queue. So that's really kind of demo one. The other quite cool thing I can do is I can also choose to destroy that infrastructure that I've built if I've done something wrong and I want to get rid of it and redo it from scratch. And if I made any changes to it, it would just work out what changes. So it might decide to replace something or just update it if it's just a property. So that gives you a really good way of like kind of this kind of try something, deploy it, roll it back, try it, deploy, that kind of way of developing your infrastructure. So let's jump back to the slides quickly. That's demo one out the way. So what about the integration platform then? So if we think about that, that was just a really simple demo. We want to look at a bit of a bigger picture here. So can we build an integration platform? Well, we can use the exact same approach here. So I'll build a Terraform solution and I'll just have more resources in it. I'll have things like a log analytics account, some functions, etc., etc., etc. And I can just do exactly what I was doing there to build this. So what I want to do in demo 2 is while that's running, deleting my infrastructure, I'll just bring up my other solution. And here what's different is I've really just got more resources in this setup. So you can see I've still got my main.tf. So I've got some stuff in here. I've actually here I've referenced a key vault. So if I take a step back for a minute and just show you in Azure, if I go resource groups, you can see, so I've got a resource group for each environment, and I've got this DevOps resource group where I've got a key vault for each environment and a storage for my Terraform state. So I probably won't be talking about the state today. There's resources out there to help you learn a bit more about that, and I've got some videos that talk a bit more about it on my blog and stuff. But really, I'm just going to reference these key vaults because they've got some secrets in them that I want to use for some of the deployments. And what I want to do is really I've built up this example platform. So you can see here I've got platform assets that are reusable across multiple solutions. So I've got, start at the bottom, I've got some storage accounts here, which is very like what we looked at before. I've got, here's my account. This is the key for it. This one here is building me a SQL database for my my infrastructure. So I've got here, I've got it's interesting. In addition, if you remember the resource keyword earlier, you also have the data keyword. So a data keyword means this is something Terraform wants you to read only, versus a resource, which is something you want to manage. So they're two different things. And what I've got is there's an existing secret in Key Vault, which lets me get a username and a password for a database. So here I'm going to create a storage account, which will be for the audit data for MySQL. This one here is going to be the server, and I've got a key for that, and I can specify some basic properties here. If you notice, I'm putting tags on some stuff as well, and here so this is my extended audit policy, so I can configure, you know, which storage account it's going to go at. So we need the endpoint. So if you notice here, I've referenced the storage account from above, and I've just said use its primary blob endpoint. So it just points to this object, and when it builds it, it'll then work out what its endpoint was and use it here. So this file builds my entire SQL database. I've got one that builds a service bus namespace. I've got one that does an integration account, but I've renamed the file extension here because I found you can only have one free integration account per subscription. So if you want to use this, you can change it, but I'd probably change the SKU. So I've taken that out the build for now. One of the ones that's quite cool here. So here I'm going to create a log analytics namespace. And I'm going to spin this up. But what I want to do when I've got it is it'll have a key that I might want to use in other things. So for example, I can reference the object in my Terraform to set that property somewhere else. But if I want to later on have a logic app that I build that wants to use it, what I'm going to do down here is I'm going to create a key vault secret on, like, in the script, which basically is going to be called KVS log analytics key. The value is going to come from that log analytics workspace I create up here. And I'm just going to point to the key vault that I mentioned earlier in the demo. So what I'm doing here is I'm using the data flag in front because it's a read-only object for that key vault. It's not a one I'm going to manage in the scripts. That's a key difference between how you use a data versus a resource element. So in the interest of time, I'm not going to delve deeply into each of these things, but you can see from the names here, I've got ones I do: front door, event grid, event hub, Cosmos. This one spins up an API management instance. And what's quite cool is it sets up, so I've got a consumption one. It's going to do a system identity. Here I'm going to create an app insights as well. So I want to create an app insights, and then I'm going to use it down here and reference it as a logger in my APIM. So that'll kind of set all that up for me. Now, the bit I wanted to show, coming back to what we were talking about a little bit before about this development process, is here I've got an Azure function, and what I want to do is this spins up a function, and I want to basically create a new function to show you how easy it is to get this up and running. So if we look at my my dev environment, so you can see here that this is kind of what's in it. There's quite a few different things. What I want to do is build a new function app, and this is something you get quite commonly on a project. And so the worst one I find is people will just go manually spin one up, get their dev working, and then there's like nobody knows how to set it up for the other environments. So by using Terraform, what we can basically do is I'll kind of go just rename this one. So if we create a new file for a function app. So let's call it functions, and it needs to be a .tf file, so Terraform will run it. And then I've got my template over here, which I've got a template for a function, but I could kind of just copy any of the others and change it. So let's have a quick look. So the first thing I'm going to need to change is my key, because there'll already be a one called template functions in the state. So I'm going to have Bootcamp functions will be the key for this new function app. I can use the same prefix that we've got before in the same environment name if I want, but I'll just call it Bootcamp functions there. It's going to deploy it. So if you look, the resource group and everything's already set to be the main resource group I'm using by referencing that object. The app service plan, so what I've done, down, where is it? Down, where's my app service plan? There we go. So in my general functions bit, I've set up an app service plan here that I'm going to put all my functions on, and it's a consumption one. I've put a storage account with it and app insights for it to point to and that kind of thing. And with my Bootcamp functions, I'm just going to basically point to that app service plan and live on it. And I'm going to set those storage values to be the ones I've already created. I'll set my instrumentation key to point to that app insights instance here. So again, you're just pointing to that other object. And if for some reason I get that wrong, it'll give me an error when I just do a validate. in my tags now. So I think all I need to do is Bootcamp down here, and that should be us ready to run our function. So what I should now be able to do, if I've got my other command prompt here, so I should be able to do Terraform init to begin with. Is this actually running? Is this going to give me a demo gremlin here? There we go. So problems with configuration. So I have made a little bit of a mistake here somewhere. So if we have a look, duplicate definition of function host keys. So there must be something in here somewhere. I think it'll be in. Sorry, there's a bit I forgot further down. So what I actually have that I didn't spot was further down the file. I've also got. So what I'm going to do here is I'm going to read out, after the function's created, this is going to read out the function host key, and it's also going to set that in key vault as well. So I just need to change these. So what this error message was saying here is that there's a duplicate function host key reference. Tells me what file it's in. So this template functions and this other one's both got the same one. So I can work out, actually, I just need to set this here. So I need to change that. Camp functions. And I need to reference this object up here. So what I'm going to do is say, go and get me the function app host key, point to that function. I need it. So there's a thing where one of the cool things about Terraform is that a lot of the times it'll work out the dependency order to do stuff in. But for this function key one, you have to kind of explicitly set it here. So this tells me to run this when the one above's finished. And then when I reference this one here, I'm going to say, so my Bootcamp functions key vault secret is going to reference that host key. Basically, that's going to create the new key for me. So let's try that again. So that's just installing the provider. So now I can validate it, which should be good. And I think what we'll do is we'll skip the plan and we'll just go and jump in and apply it. So this will go and check what we need to do against the state, and it'll come back and it'll give us a yes or a no option to decide if we want to approve it. So you can see it's going checking all the state for everything. So we're going to add 2 things and change 3. So the 2 we're going to add will be this key vault secret here is going to get added, and we're also going to add our function app template, and then it'll just the way I've got this set up, it's going to refresh a couple of things because it'll read some of the function keys that other functions have already got and just update the secrets. So we'll apply that. That's going to go away and do its thing. And we should start to see a new function app appear in here. So I'll just move this over. So it'll just keep checking until it's finished creating it on Azure. So we'll just let that keep running, and we'll check back on that in a moment. And I think we'll jump onto the next slide because it's just running in the background there. So if we, we've got about 10 minutes left now. So if we think about where we are at this point, so in terms of developing infrastructure, I've now got a developer experience for creating this infrastructure, so I can configure it, I can test it locally, I can check it's syntactically correct, I can see what it's going to change. When I'm happy, I can choose to apply it. That gives me a great way to configure this infrastructure, and I can, with the variables options, I can quite easily set up other settings for different environments and stuff. Now, what I can do is then I've got the options to jump into a CI/CD type option. So if I have this Terraform setup checked into a repo, I can then build pipelines to go and deploy it out. So really, I can use the same config and just change the variable settings, and I can have a pipeline can deploy it to a test environment, to a production environment, and can go and like repeatably build and deploy this all the time. So if we have I chucked this demo in a little bit earlier. I'm going to just walk through this a little bit, but not spend too much time on it, hopefully. Because there's a couple of other things I want to talk to you, but I just want to show people what's happening with that pipeline in the background. So over here, we've got, in fact, I think our pipeline from before is already finished, the one that was running. So we'll go and have a quick look what happened. So this here, in fact, I've just got the email notification as well, so I think it's probably just finished. So what I did is I've got a pipeline that I've set up. So in the code, you can see there's a pipeline folder here. And I think a couple of the other people have shown release manager in DevOps, and there's also the YAML build option. So one of the things I've been doing more recently is learning how to leverage the YAML builds. I know the classic ones quite well. I think they're really great. And there's a bit of a kind of, choosing one versus the other at the minute around which way you do it. But what I've done here is there's YAML pipeline specified. And I've done this because it better supports something I'm not going to go into too much today, but down the line, you'll see me blogging about this. So I can copy a solution and just copy paste the pipelines rather than having to build them all the time in Azure. But really what I've got here is a bunch of stages where in my pipeline, anyone who's familiar with YAML, and you can actually export your DevOps pipelines if they're classic and see what the YAML looks like. But here I'm just supplying these Terraform apply and Terraform plan commands that my pipeline can run. So when I build a pipeline, it's really just referencing those commands. And you can see here I've got two stages in this test deployment. So what it does, it goes and installs Terraform. I've then got a couple of things that, building, pulling in key vault secrets. I do a replace tokens on my Terraform file. So this is where I've got some stuff in DevOps libraries and in key vault secrets. And if you remember earlier, I was talking about the variables file where when I run it on my dev box, I use local.tf-vars, but on the build agent, I just inject values to replace these tags here. And then I'd just let it run with these default values, and they've been put in by the build agent. So that's how I can deploy to any environment. And then really what I can see here is the plan stage kind of run, I can see exactly what it's going to change. So when it ran before, there was nothing in Azure, so everything should be getting built, and I can go and see, that's going to be created. Here's the setup of it. And I can review my plan if I want to put like an approval stage in before the plan and apply, I can do that. And so if we look when our build ran before, this went and did the apply, so it's gone and built all this Azure infrastructure. And if we, have a look at our test environment that's set up, in fact, we'll just check on that local build as well. So I think, those functions have finished building there from before while we were chatting. So hopefully if we refresh this, you'll see here's my new Bootcamp functions. And you can see it's all set up and everything. The config settings we put in the app settings should be in here, so we can check that with the app insights one. So we can see that that's got a value in here. And I could have just checked it and pushed that key vault out to, that function app out to other environments. But if we go, so if I just jump back into Azure for a second, if we go back to our resource groups, that test resource group, which had nothing in it before, when we kick the build off at the start of the presentation, you can see it's now gone and built all of this stuff. So we've got a bunch of storage accounts. We've got a SQL server. We've got a service bus, a log analytics, an app service, Cosmos, all the things that you might want to have in your enterprise integration platform that you're then going to build stuff on top of as you build functional solutions. So you've got all, if you want to start putting queues out there, you can do it. If you want to start putting functions into one of the functions apps, you've got all these things in place, your building blocks to start developing with. Okay, so if we have a think about, so we've got our base platform now. The next stage is the actual functional bits we want to build on top of that. So the idea of my enterprise integration platform, this is the equivalent of my BizTalk SQL storage type setup that I can then start building BizTalk apps on top of and deploy into. So when we build Azure solutions, what I tend to find is I'm using a combination of logic apps, functions, API management, and a few different bits. And I wanted to just put this diagram together to show how we do the different ones, because I think, for me, the bits that are really solid are with functions. We've got the Visual Studio support. We can deploy from Visual Studio, or if you're DevBox, if you're in development, when you go to a build agent or a DevOps, you've got a great DevOps pipeline that's dead easy to deploy your code out with. So that's exactly what we use with logic apps. Currently for consumption logic apps, we've got the ARM approach, which works really well, fits in with Visual Studio. There's a few different ways people spin that up. Basically, you end up with a logic app defined in ARM, and then you deploy it. SQL, we tend to use the DAC pack stuff. One of the things I use for integration accounts would be when I define things like liquids, maps, and XSDs and XSLT, I usually just use the PowerShell commandlets to deploy those with. That's dead easy as well. Fits nicely into local development and DevOps. But the bits where I think the sweet spot for Terraform are, in addition to the Azure provisioning, so the actual physical resources themselves, the main reason I like it is because it's simple. It gets rid of, if you compare a Terraform script against an ARM template, I think a Terraform script gets rid of at least 2/3 of the lines of text out of it, and just it's easier to read and follow. But I also really like that kind of like configure, validate, apply, or plan apply approach. I think that works really well for me. But in addition to the infrastructure, where I also use it is I use it for building APIs and API management. So I didn't go into this today, but you can actually configure your entire APIs. All the policies can be within Terraform, and you can just have that full same experience. And I use it for APIs. I use it for configuring permissions on a hierarchical namespace in a data lake storage. I use it for configuring queues and topics. And I think this is kind of how I do each of these things. So a couple of takeaways really quickly is just the consistency of building and managing your platform, the way it fits with pipelines. I know we're kind of running a bit short on time, so I'll just jump onto this. So for me, what's next is I've got a load more samples than what I've shown today. I've got samples for all the different bits that I'm sort of planning on doing some blogging about. And I was thinking about maybe making some training courses to show people how to do this, because I think where I've used this is I've got to the point where I've got a cookie cutter approach where I can go, I want an API management solution, copy, there's my code to run it locally, copy, paste, there's my DevOps pipelines. And I can do that across a number of things, which I think would be really useful to people. And I think there'd be some interest in training and samples and stuff. So I think I'm going to do that through Integration Playbook. The samples I showed today are available on GitHub. So there's a link there, but it's on my GitHub. I've put the two solutions we saw are both on there. Otherwise, if there's any questions, and I actually twice today I've put a reminder for something that I thought I'd forget to do and I remembered. So I'm obviously getting better. The sunshine must be making me less forgetful. But if anyone's got any questions, feel free to pop them on YouTube or wherever we're collecting questions. But thanks for listening. Hope everybody has a great afternoon and enjoys the bootcamp.
Constantly clicking. To explain, it's the same button. So if I click the button and Stefan clicks the button, then we're basically ping-ponging each other off the stream. Thank you.
Yes, thanks, Mike.
Yeah,
guys.
very helpful. I'm also in a debate about Terraform or RM templates within the client, and we are using it for one data project, Terraform, where I like it. So it's kind of a debate you will.
Yeah, I've just had the same thing with a customer actually the other day. Is they had they were left a solution with ARM templates, and they were really struggling to get their head around it, and they'd heard of Terraform but never used it, and we basically rebuilt their stuff in Terraform, and I just showed them how to use it, and they kind of did it themselves, and it's way more complicated than like the solution they have's got like networking and everything in it as well, and it's functions and all the private endpoint stuff, and it's a really quite powerful way of, they've got to the point where they can actually build this stuff themselves, and they're finding it a lot easier than ARM. So that, to me, it's that making it a bit more readable and easier to understand is the big use case win, I think. But there's pros and cons of each. I think to me they do similar things. It really just comes down to what skill set you're comfortable with.
Okay.
Yeah, totally true. Totally true. It's also moving to Azure. You notice that a lot of things are going back to code a little bit, so you have to do more in code, and some people have to get used to it. But I think in the end, it's a more agile way of working for sure.
Well, I'll tell you that one of the ones the other day, we had one where one of our team came along and they needed a new storage container, and you've got like 6 environments or something. And it's dead easy to just knock one up yourself. But the problem is, right, that's not in any of the other environments. How do you know that it gets done? You know what I mean? And they don't end up going to UAT and somebody forgot to spin it up or something. But it literally took, I go to them, right, 5 minutes, right there, it's in the Terraform. Apply the Terraform and it goes and checks. And the only thing it needs to change is add this storage container, check it in, job done. It's in all the environments, it's just makes everything that bit easier, I think, is the thing.
Yeah, for sure. For questions and answers, Dan Toomey is back up again, I see in Discord. So if you can go in Discord, you can also share your slide deck and your links in there, because that's going to stay up and people will ask questions if needed.
Whereabouts do I find the link for Discord, Rob? I'm not sure.
It's on the right top corner of the stream. It's bit.ly and then gip2021-discord.
Ah, cool. I couldn't see it for looking at it. Cool. Right, I'm going to jump off then, guys. Have a good session, Sam. I hope you guys all stay well. And
thank you, Mike.
Good job on the event today.
Thank you. Bye.
Bye.
Next up, Sandro.
Hi, guys. Another usual
long
suspect.
time no see, but that's for almost everybody today. So
exactly. How are you guys? Good.
Good.
Doing good, yeah.
Awesome.
Long day.
Long day, yeah. Wagner and Bill did the whole night, and we took over this morning. Stefan actually closed the APAC one this morning at 7. So
I was watching in the night for me. Well, really in the night, the beginning of the session in the other part of the world. So,
yeah, it's cool to do it live and to get everybody involved over the entire world. Actually, it's new to us all. Stefan and you guys probably have more experience with doing live stuff from the other side. So it's also cool to run it.
Yeah,
for sure.
Yes.
Okay, then let's jump in, Sandro.
Yeah.
Okay.
It's yours.
Do your thing.
Okay, thank you. So first of all, thanks for accepting the session and allow me to be here presenting another year, another session about enterprise integration. So my session will be about logic apps preview. Oh. For those who doesn't know me, I am Sandro Pereira. I am Azure MVP. I am MVP for the last 10 years. Beanstalk MVP, integration MVP, now Azure MVP. You have my contacts there, my LinkedIn, email, Twitter, my blog. You can follow me. You can ask me questions if you want. And a disclosure, we are in full lockdown in Portugal, unfortunately. And this is a house full of kids now. They may enter on that door at any moment, so bear with me. Be patient. I will try to put it out of the room as quickly as possible. So this session is not about discussing your perfect tool. Should we use Beanstalk, Logic App, Preview, whatever? I think all of these tools that you see on the screen, they are valid. They are valid today. You should invest today in any of these tools, depending on the scenarios that you are using in your client. This is about logic apps and special logic app preview. So we will speak in the first part of this session about integration challenge that we are facing today, and logic app, and special compare what is logic app and logic app preview, and show it at the end this new resource that is the logic app preview. So integrations challenge that you face today. Okay, you will still have a lot of on-premise integration that doesn't go to the cloud. It stays on the main floor of the company, inside the company, and it doesn't go outside. I still have clients that they cannot go to the cloud or moving data outside the organization because security policy and so on. We have what is the most common these days, the hybrid integration, then that you combine Azure service with on-premise technology and systems. And of course, we have more and more happening today, cloud-to-cloud integration. So if you look at the landscape today that is available in terms of Microsoft products, we see that for on-premise integration, we have two main components. SQL Server and Integration Server for ETL process, and we have a Beanstalk server for on-premise integration, and I mean on-premise integration only, okay, without going to Azure to connect to on-premise to on-premise. So we have these two main products that has two main also components. One is about integration, message integration, and another is that about data replication. Okay. Of course, we can do on-premise integration using cloud service also. Azure Integration Service, basically API management, Logic App, Service Bus. You can also have the IaaS environment, private environment, that you can, of course, connect to on-premise and do on-premise integration, but in this case, using Azure service, okay? And of course, to do that, we need some kind of gateways that allow us to connect to on-premise. It can be a VPN, a data gateway, or express route, depending on your scenarios. And it doesn't mean that this is the main components. The Azure integration is the only component that you should use to integrate. You have a lot of service that can do the same stuff depending on your scenario. Integration account for B2B is special. You have data pipelines, you have Azure functions. Well, you have a lot of stuff that you should use and you may need to use depending on your requirements. Now, with this new release of Logic App, we have another way to do on-premise integration, on-premise to on-premise without going to Azure. That is using logic apps preview that you can run on a container or a Docker and can stay inside of your organization and do on-premise to on-premise integration. Okay, I will speak more about that later. For hybrid integration, everything that I spoke earlier, it fits on the scenario. Now, you have a lot of this technology. You can use SQL integration server, Beanstalk server, Logic app preview, API management, functions, service bus, event tabs, you name it. Okay, you have a lot of stuff that some of the stuff can have a collapse in terms of functionalities, but depending on your scenarios, you can use one or the other. Okay, you can use service bus for persistence. You can use SQL Server for persistence also. So again, it's just a matter of flavor, about of taste. You like one better than the other, pricing, and capabilities. Based on these topics, components, you may choose one instead of the other. But again, all of them will be valid for you. In terms of all cloud integration, pool cloud integration, of course, main component is about Azure Integration Service. And of course, you have the eyes for people that want a dedicated environment, but you are speaking mainly about API management, Logic app, service bus. Of course, functions also really important. Key Vault, integration account, event hub, storage account, app service, and data factory. These are probably the main components. But again, there are a lot of them available. Don't get me wrong. You can have app configurations. You can create custom connectors. You have storage accounts, web jobs, databases, several databases, App Insight for logging, streaming analytics, Power BI for dashboards, and so on and so forth. Okay, so we have a lot of tools that we can use and technologies that you can use to do pure cloud integration on your based on your requirements. And again, we have also the Logic app preview that can also run on the cloud. Okay, so it's another option that is now available. Of course, it's still in preview, but this is available. So Logic app preview. I think, honestly speaking, I think Microsoft should do a better naming convention. Otherwise, it's too much confusion. And there is quite a confusion. What is one and what is the other? So Logic app, the traditional Logic app, the Logic app that you are running today, they are pure serverless. Okay, they are 100% serverless. You basically, it's about creating your business flow, workflow, orchestration. You can name it in several ways, but it's about creating your business flow. It can integrate app integration, data integration, system integration, enterprise integration. Despite data integration, I think it should be more data factories than Logic app, but it can do that in small cases. B2B communication and so on. So this is, if you are familiar with Beanstalk, it's an orchestration. Okay, it's about designing your business flow to integrate systems. Of course, they can also run in an integration environment. You can create a dedicated environment, isolated. It is 100% for you. You can have more control of the thresholders and so on and so forth. You are not dividing this environment with other clients. This is dedicated for you. And you can run the Logic apps there. Again, they are 100% serverless. Okay. The Logic apps preview is more computer based. It's not as serverless technologies is more computer-based because you cannot use a consumption hosting plan. You have to have a app service hosting plan in Azure or in a Docker container. So the price will be different, despite the price is not yet clear for everything, because if you know Logic App, you pay per execution depending on the actions and triggers and so on and so forth. Here you will have like a mix, I believe, like a mix of pricing. You pay back compute based, but of course you may pay by enterprise connect or something like that. I'm not sure about that. I'm just this is my the idea that I will have in the future, that something will be like that, but it's computer-based price mainly. And the Logic App preview, it is not a workflow. Okay, it is not a business flow. It is a container of business flow. There you can have stateless and stateful workflows. This is kind of a new stuff that we see in the Logic App preview. Stateful workflows is what we have in the Logic App at the moment. So all the Logic App flows are stateful workflows. They persist all the points, and you have this history runtime, and you can resume and so on and so forth, because everything is persistent. They can run for a year. Okay, that's the limit. They are high resilient. Okay, stateless workflow, that what you have new in Logic App preview is more try forget scenario. For try forget scenarios like request response, that you need to get a response really fast, and we have to improve this kind of the runtime. You shouldn't avoid. You need to avoid a lot of persistence to be more faster on the execution, and that's what this stateless workflow want to achieve. That is to be high performance. You will not have this history. You lose the persistent points. But again, this is for scenario for request response that you actually don't need that. That means that if it fails, the source system needs to presend the message again, because you are not persisting this stuff. So for me to explain better what is this container of business flows. So in Logic App that we have today, the traditional Logic App, and now you understand the confusion about Logic App. When we speak about Logic App, you need to clear what is Logic App and Logic App preview, which is quite annoying. So in the traditional Logic App that we have today, we create an Azure resource, and we actually can deploy several Logic Apps to that resource. And we actually can deploy other components like API management, service bus to that Azure resource, okay, that resource group. And you can actually deploy at your own rhythm. You don't need to deploy all the Logic Apps. We're adding Logic Apps to your resource. So in the Logic App review, if you are putting this in the concept of deploying to Azure, you will have an Azure resource group, okay? And then you have a Logic App preview resource that you will deploy Logic Apps to that. In this case, you are deploying, let's call it by the proper name, workflows, stateless or stateful workflows there. That is Logic Apps, okay? And you can have more Logic App preview resources to that resource group. So they are basically a container of resource, and you actually can also deploy other components, other technologies, Azure service to that Azure resource group. But, and there is a big but here, in the Logic App preview, what I call a container of that, you deploy all of them So if you add a new logic app, once you deploy everything to that container. Okay. So let's say if you are familiar with Beanstalk, this is kind of a Beanstalk application. So, so the resource group is like a Beanstalk application, and the logic app preview is kind of a project that you have. So you create a lot of orchestrations and you deploy that DLL. That DLL, every single orchestration there are deployed to your in your application. Here is kind of the same. So you have this logic app preview project, and you are creating all of these logic apps, stateful flows, and you need to deploy all of them at the same time to that specific resource. So this kind of limitation, you cannot deploy one by one. It will affect everything once you are deploying. This is the difference between one of the main difference between them. Why is that? Because logic app preview is actually running inside Azure functions. And this is the same behavior of Azure function. You create all the Azure functions and you deploy all the Azure functions, all the functions that you have to that function app. So indeed, logic apps preview are hosted on top on Azure function runtime. And this allows you to deploy logic apps everywhere. Okay, everywhere that Azure function runs, you now can run logic apps, which is quite awesome. In this case, you can run on containerized Docker or Kubernetes environments, app service or app Azure function for managing past experience. I took this slide for Steve Chen also with reference to coded blog post that is quite good. And you see that you can now run almost everywhere, and you can also run not in Azure but in AWS, Google Cloud, and so on and so forth. This is quite powerful and enable us to reach other scenarios that you couldn't do today. You have a lot of limitation because Logic App today is 100% serverless. So what are new in Logic App that doesn't fit quite well in the current Logic App today? So I told previous stateless and stateful workflow flexible hosting model that we already saw, and now we can actually do local development inside Visual Studio Code. Unfortunately for me, I'm more a Visual Studio lover than Visual Studio Code. Logic App Preview at the moment doesn't have ability to work with Visual Studio. It only has the Visual Studio Code, or you can do it in the Azure portal. But this full Logic App designer capabilities nowadays. So in this resource, we have full Logic App capabilities. What doesn't happen with the traditional Logic App, with Visual Studio Code, you only see the designer as a read only, not editing. Here we have a full capabilities. We can also have support for local project, which enables to do awesome work with Visual Studio Code. Now, since December, the last release that I did, that they did the Logic App team, we can actually do breakpoint debugging on before and after actions. So you can see what is entering on the action and what is leaving on the action. So you can have a proper way or a different way to debug what is happening inside your flow without going to the history, without using the history. So this is live debugging live. Okay. And there is a new Logic App Designer. It's more compact. So the layout, what you see visually is different. Is they have a more compact version, so it's easier to edit and change large and complex workflow, because the traditional one has some large actions, and when the flow or the workflow starts to build, so if you use like branch and so on, it can be large and big workflows. So you need to scroll. You have a lot of scrolling. So to minimize that, we create a new design. Is more compact. It allows you to be more productive. And you can also have the capability of custom connection extension that works with the framework. So it's good to have. But this is also really important. You have built-in integration account features without the need to have integration account. So you still need to have integration account if you want to use B2B integration, but it makes sense. But you don't actually need integration account to have schemas, XML schemas, and maps. So you now can have built-in inside Logic App Preview without using the integration account. You have full support for schemas, maps. You can do schema validation. You can do transformations, XML, XSLT transformations, liquid operations, so on and so forth. You can also have the inline code without using the integration account, which for me makes really more sense that we have nowadays in the Logic app. Because to be honest, integration accounts is quite expensive for the goal that we need to achieve. So if you are not really doing B2B integration, but you are doing XML integration, I think it's too expensive to have an integration account just to support schemas and maps. Okay, that's my opinion. So this makes more sense. So without any delay, let's do some demos about the Logic App Preview. Let me put here on screen. So this is my Visual Studio Code. I'm running this in my local machine. I'm actually doing that in my BizTalk machine. So it's everything in the same machine. And you now have this. So we still have the Logic App add-in for Visual Studio Code. This is the traditional one. You can log in, you can edit your Logic Apps there, the serverless Logic Apps there. But you need to use inline code. The designer is only for read scenarios. So for me, it doesn't make sense to use this plugin for developing Logic Apps. But nowadays, you have this new one that is Logic App Preview. Of course, you need to connect your Azure subscription. I do have two of them. We'll be working on this one that I have deployed already, or I have created. I don't have nothing deployed there. I just create the resource. And you have here the capability of creating new workflows, and you have the capability of adding a local project that I'm showing here. So I have this local project that reflects to this resource, Logic App resource that I have. And here, as you see, I have schemas, I have maps, I have schemas there. So you see this component of artifacts on inside your local project, and you can actually add here maps and schemas. So I tried yesterday schemas. It's again, unfortunately, there is no schema editor here. If you want, you can create a new file, but you have to create the schemas manually. There is no editor at the moment. So what I did, and it's fully compatible, is I create the schemas using the Beanstalk project, and I just copy to my project that I have locally. I just copy to the folder, and they appear in your local project. The same will not happen with the map. So Beanstalk map is not 100% compatible with this XSLT. It has to be .xslt for the engine to understand that it's a map. It cannot be XSL, or it cannot be a BTM file. So it has to be an XSLT file. You can use the old plugin to create. So if I remember, I didn't use too much that. The Logic App team create a project for Visual Studio in in 2015 for create schemas and maps. They should be working. I'm not entirely sure that they are compatible here or not, but again, you can create these in online tools or other kind of plugin that you may have. So I have a simple mapping. So basically, we have schema A that has first name, last name. We have schema B that has a full name, and we have a mapping that concatenate first name, last name, and put a space in the middle. So quite simple stuff. This is just for a scenario as a sample. So you have the workflows, you have all the code behind, and here with this new extension, we have this opening design and capability, but full design capability here. Okay. So as you see, we have the when HTTP request received. I can now go and, for example, if I want, define the schema or leave it blanket. In this case, I'm receiving an XML. I'm doing a validation of schemas. So all the schemas that will be on the schema folder will appear here. I'm saying I'm validating the schema based on what I receive on the HTTP request. And again, I'm doing a transformation based on the message that I receive using that map, and I will execute, give back a response back with a content type application XML with the result of the transformation. So I'm not explaining here how we can create Logic App because it's quite the same as you have the experience on the existing one. It's just a different look and feel. And what I told you about, gosh, let me delete this stuff. Otherwise, okay, delete. As I spoke, the designer is more compact. Is about what you see here. You don't have these large shapes. All the configuration is done on kind of a property window on the right side. So you have a better user experience. So also, and I told you this is you have local developing. You can also execute and start debugging your your flows logic without deploying. Nothing of this is deployed on the Azure, on my Azure environment. Everything that I have here is locally, okay? So I can actually run. Oh, it's already running, sorry. So you see here it's already running. So it's running. If you want to see what is the endpoint, because when the HTTP request receive is deployed on Azure, you get the endpoint. You just need to go here and check the overview. And in the overview, you have the call URL. So you need to copy that. I have it already here. So I'm basically sending this message and sending to my local endpoint, my local engine that is running here. And this can be a little slow also, okay? And you see that is doing some stuff in behind, and I may get the response soon. It was is it executing, warming up. So the first call is quite slow because it's warming up everything that is inside my machine, and the others will be more fast. So bear with me, be patient. And you got the response. So if I try again, I hope that will be faster. Normally it is, but you get the point, okay? It's being executed. While it's being executed, so you see here, I also have this kind of history also. Is doing a refresh. It's also my machine is a little slow, okay? So bear with me. I have SQL Server running here, VSOC running here, and I have this Azure runtime working here, so it's quite a lot of stuff running on that machine. You get this response. Awesome, I got yesterday 8-second response, so 2 seconds response for the same. Some of them fail or not, but you get the point. So and you can go here and show the run. It actually tells you exactly the same capabilities that you have in the Logic app in the portal. So you have these capabilities that you can see the input output of every action, because this is a stateful workflow. Okay. So let me close this one. Let me close this, and let me actually close that. And here we have, for example, a stateless workflow. And I can, in each of these action, beginning and end, I can do breakpoint here. So I can go here and add a breakpoint, okay? So now if I test my flow, kind of the same. This is same, but this is JSON. I can show you also the design of this. It's just simple stuff about getting a request. I'm composing here, basically doing the same. So put in uppercase the first name, last name, and concatenate together. Unfortunately, I hope this expression experience will be better in the Logic app review. It isn't. So you still have these annoying small windows, and you still have this annoying small pop-up text box that doesn't fit nothing, but it is what it is at the moment. I hope this will be improved in the future. And what I can now do is send a request to my endpoint, And hopefully this is going to breakpoint. See, here we have the breakpoint, and here we will have the local variables that we can see that we are getting. Where is the value there? Let me go next step. Context. You see here input, and see here the output. Here the input, the output is the same because I'm using the expression, and basically this is not C# breakpoint so powerful like a C# breakpoint, but the point is that we have a way to kind of do this kind of breakpoints and check what is the input output. Some of the time will be a different one, some of the time will be the same, but you have a way to see what happened while this is running. And you see that it's still waiting for my reply. I will say resume, and it will give me back the response once it finishes saying my name is Samuel Pereira in uppercase kind of stuff. It's working, yeah. It's executing, and say hello, I'm Samuel Pereira. Okay. So I can also go here. Let me go back to the project and say overview. This is a stateless workflow. It shouldn't have the history. That's the point of the stateless. But while you are working and trying your workflow, you can actually enable the history capability of that flow. Basically, I'm putting this stateless, stateful workflow, and this will have the same capabilities of showing the history. Of course, I should disable that once I'm putting in production, and basically you can do that on the local settings, saying that this operation that is a stateless one, you can have the stateless with run history. That will persist everything the same as a stateful workflow, but then you can disable the one you put in a different, put it in production, okay? So you also have this kind of powerful capabilities of debugging your solutions. And that's everything that I had for today. I hope you enjoy it. I still have some few minutes about some questions that you may have. So I don't know if you can see the questions.
Let me see. And no, in Discord also it's quite quiet. People are mainly watching, not watching directly. It's a little bit different, right? Normally you would, if you're live, it's really different and easier to ask questions, of course.
Yeah, and see the feedback of the
exactly, see the feedback. Yeah, people didn't see that your daughter was walking in, so you were laughing, but in the end, your daughter walked in. I saw it, but
luckily she only came in to grab some stuff.
Exactly. Yeah.
Most of the time, they will enter to negotiate something like, I want a chocolate, or can I watch YouTube channel, and say yes, 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 go.
Actually, yeah, sorry. I'm a guy. I can only do one thing. I was chatting. Yeah, it's really good to know what the difference is between those two. Actually, the logic apps and logic app preview. Nice wording indeed by Microsoft again.
I just hope they rename something, otherwise it's too much confusion.
Yeah. We all know about naming and Microsoft. It's not the best combination.
And I didn't mention that, but none of them will go away. So we will still have
both
serverless and this containerized version. So all of them will stay there.
And is it so? What about the costs? Is it gonna be similar or?
No. So the traditional logic app will be still pay as you go. But because the preview is based on the computer-based scenario, so Docker or app service, they may so it will be based on computing, that for sure. But I'm guessing that some of the stuff will also be paid by execution of kind of what we have in Power Automate about enterprise connectors. I don't know. I'm still unclear at the moment.
Yeah, exactly. I'm also curious about that because it's a good way to do it to keep it containerized, but in the end,
one thing that I'm for sure, the design will be the same in all of them, but you need still wait for the merging kind of stuff.
Oh yeah. Oh, that would be a hell of a merge, I guess. Well, thank you very much, Sandro,
thank
for
you.
your
Interesting.
introduction.
Thank you.
We'll have a small break now. At 3 o'clock, we're continuing with Dan Probert about the BizHook Migrator tool. I'm actually very interested in it as well. I'm leaving early though. Stevian is going to take over after Dan's session.
Yes.
But because we are on YouTube, it's archived. We probably bring everything back up so we can have a look afterwards as well.
Yep.
Bye, guys. Thank you.
Bye.
Bye,
Thanks,
Sandro.
Short break. Hello.
Hey. So now you're in San Francisco.
No, this is Lisbon.
I would say, yeah, that's Lisbon. It's the same bridge, right? Or it looks very similar.
Yes, it looks very similar, true.
Oh. We have Dan Probert here as well. I can pull him in. Can we hear him? It's very black. That's basically.
I know. I turned my camera off because I can't get the virtual backgrounds to work, and my office is a mess.
Ah, no, it's nice.
I've got hair. You know, I've got to tidy my hair, guys. I just got back from the beach.
Oh, yeah, you got back from the beach. We were sitting at home, and yeah, Steve Jan expressed it last week. Groundhog Day. All day. Hopefully it's done. Hopefully it gets warmer soon outside, and we can also go out again.
Nice. Oh, I thought it was a virtual background, Rob. Your actual house. You got people randomly coming in behind.
Exactly. No, this is my mess. Some D&D stuff and the printer. So you're going to talk about an interesting subject. I'm going to watch it. I actually have the recording on my machine, so I can watch it again and again if I want to. But I'm also going to rewatch it because it's about the BizTalk Migrator tool. And as many companies, I'm also at a company that's, kind of starting the journey to, not walk away from BizTalk, but starting to move to the cloud and, kind of wrestling on how to do it.
Yeah, of course. I can understand that. So, Rob, are you going to play the recording with just me in the background if I need to talk? Is that how we're going to do it?
I can do that. Right.
That was my original intent. I was just going to be here to answer questions, but I mean, I'm happy to do it again live. I'd need to just set up the VM or turn it on.
No worries. We play the recording, and then afterwards, if you stick around, you can maybe do some Q&A if there's any questions. So.
Yeah, that's fine. I'll be on here on audio basically and answering anything on Discord and chat if necessary.
Yeah, that's excellent. That's awesome.
Yes.
Yeah.
Cool. Alrighty.
Okay.
Because it's there.
Hi everyone, and welcome to the next session at this year's Global Integration Bootcamp for 2021. This session's on the BizTalk Migrator, so Microsoft's BizTalk Migrator tooling. We'll be doing a deep dive. Dan Toomey earlier today, depending on what time zone you're in, did an introduction or a lightning session on the BizTalk Migrator. Today we'll go into a lot more detail on this session. So we've got a lot to cover. Right, my name is Dan Probert, and I'm the CTO of a company called Affinis Limited based in the UK. I've been working in integration most of my life. I've been working with BizTalk since 2002 and with Azure since 2008 and with Logic Apps since before they were called Logic Apps, somewhere in the sort of 2014-15 region. I've also been looking a lot into the problem space of migrating BizTalk to Azure since 2015, and I was involved in writing some early tooling looking at migration. You can reach me on Twitter at ProbertDaniel or LinkedIn also at ProbertDaniel. Right, the agenda today. I'm going to give you a high-level overview of the tool. I'll talk about how we get the tool and run it or execute it, how it works. I'll take you through a demo of migrating an application, and then I'll show you what Azure artifacts the tool generates. Then we'll talk about, we'll do a demo of actually deploying the artifacts to Azure, and then a demo about what orchestration migration is supported and what it looks like up in Azure. And then we'll talk a bit about some of the advanced concepts. So that's a lot to get through in 40 minutes. So I will do my best to get it all done. Right, high-level overview. So the BizTalk Migrator is an open source command line tool developed by Microsoft. You can find the source code on GitHub at the link shown here. And Microsoft wants your feedback on the tool. They want to know what else do you want it to do. It's a starter for 10 if you like. It's got some great support in it, and it could do more. But if you follow the link here, aka.ms/BizTalk Migration Survey, Microsoft have a hosted survey where you can talk about what your migration needs are, if you have any, but also what support you'd like to see in the tool. And they'd really welcome any comments. The tool is plugin based, so it runs a series of plugins to parse and analyze and then convert a BizTalk application. And it takes in a BizTalk MSI, so the MSI that's exported from, say, the BizTalk console. It takes in one of those, and then it converts it to a series of BizTalk artifacts, so specifically scripts for deploying those BizTalk artifacts. Currently, the version of the tool that's out there at the moment, the preview version, supports file, FTP, and HTTP adapters. It supports built-in pipelines like the XML transmit and receive and pass through, transmit and receive. It also supports custom pipelines, for example, JSON encoder and decoder and the flat file decoder, and then simple orchestrations, plus transforms on maps and property schemas and things like that. What does the migration process look like? Well, there's 3 phases: assessment, conversion, validation. And each of those are broken down. There's 5 stages, and each of these stages is handled by a series of plugins. So there's some default plugins that come with the tool, and the idea is that the community can write their own plugins for specific scenarios. But the discover phase takes in the BizTalk MSI. The parse phase takes what the discover phase has found in the MSI and parses out the orchestrations and pipelines and schemas and maps. And then analyzes what's been parsed and builds a model of it all. And then there's a report stage here, which takes that analysis output and builds a report. And you can stop at that point if you want. The tool is quite useful if you want to just get a list of all your BizTalk applications and your BizTalk estate. But you can then continue on, and there's a convert stage which goes through and builds a series of artifacts to be deployed. And then there's a verify stage at the end. How do we get the tool? Well, the tool is available via Chocolatey, which is a internet-based package manager. You have to install Chocolatey on your machine first, and you do that following the instructions here at chocolatey.org/install. Then when you've done that, you install it from a command prompt. You install the migrator and choco install BizTalk migrator, and then -- pre, because it's still a pre-release version. And then running the tool is very simple. It's command line aim.exe, Azure Integration Migration.exe. And if you do -- help, you'll get a big long page full of all the options and some samples to run it. But what you're mainly going to be using is aim assess, which generates a report, or aim migrate, which does the actual conversion and generates a report. You pass in the path to the MSI, and there's options for passing in multiple MSIs if you've got dependencies, or a folder of MSIs if you want to do your whole estate. And you specify your primary region, which is used for the output templates, and also a unique deployment ID. I'll talk a little bit about that later and why that's important. There's additional options, -v for verbose logging. So if you hit an error and you want to see exactly what was going on, you can rerun with a -v. And also -- no abort. By default, if the tool hits a problem, it stops. But if that problem was something that you don't really care about, you want to keep running and generate all the scripts anyway, then just put that at the end of the command line. How does it work? Well, you start off with an MSI, and the MSI is extracted, and we end up with a binding file and some BizTalk DLLs, and that's the discover phase. Now, the DLLs could be BizTalk assemblies that contain orchestrations and schemas and maps and all the rest, or they could just be other assemblies that you're referencing in your application. And then from there, we start building a source model, and this is the parse phase or parse stage. So the source model describes what we've found in BizTalk. Then the tool will start building a target model. This is the analysis phase. So from what we've found, what could we deploy to Azure and what would that look like? And it takes a pattern-based approach here where it says, if I take the BizTalk artifacts, what's the equivalent to those in terms of an enterprise pattern? And then what does that enterprise pattern look like in Azure? Following that, we have the report phase where we output a report. And then we start generating the scripts and templates, and that's the conversion or convert phase, the final phase. And we end up with a lot of scripts and templates. Right, let's get into a demo. So what I'm going to start off with is going into Terminal, and I've already got Chocolatey installed, but I want to install the product. So as we showed earlier, I'm going to choco install BizTalk migrator -- pre. It's going to go away, and it's going to go and find the packages, tell me I've got to accept the licenses, and then it's going to download those packages. Here we go. and download them, and there's a couple of them, and then at the end it's going to ask me to confirm I'm okay to run a script, and the script is just setting up some configuration for the tooling. And here we go, and it's almost done, and there we go. So yes, I want to run the script. Done. All right, the tool's installed. Brilliant. If I go aim -- help, I mentioned earlier, you'll get a lot of help suddenly pop up. There we go. Look at that. So there's all the command line options, and then there's some more information about the types of options, and then down here are some samples specific to BizTalk. So, you know, if I want to do more than one file, you can use a pipe symbol, or if I want to do all the files in a folder, you can do that as well. The next step is going to be actually migrating an MSI, but where do we get one from? I mean, you might have a BizTalk server with one on, but will it work? Well, the nice folks at Microsoft have some samples you can use. Here's the repo. So this is the source code. You can go in and have a look at all the source code. There's actually 5 repos. There's AIM tool, which is the main repo with all the documentation and everything, and there's a frequently asked questions and information about the scenarios. There's a repo called AIM BizTalk, and that's where all the code that understands BizTalk is. And then there's AIM Azure, which is all the Azure templates used to build the scripts and everything and what we put into Azure. And then there's 2 more repos as well. Now I'm interested in the AIM BizTalk repo because in there is a folder called scenarios. And in there are all the scenarios. So for example, FTP pass-through, pick up a file through FTP, use the pass-through pipeline, drop it in the message box, pick it up on a send port, use the pass-through transmit pipeline, and drop it out to an FTP server. Simple. There's a BizTalk solution here that has the bindings and stuff in it, and then there's the MSI file. So this is the MSI file I want to try migrating. Now I can just download this from here, or I could go back up to the top level and I could use the code option here to download all the code. Or I could use Git properly, and I could either fork and clone, or I could just clone this repo. And I chose to clone the repos. So I actually have them on my machine. And I've already copied out the MSI file I want, and it's sitting in a folder just back up here, sample MSIs, and it's AIM FTP pass-through MSI. That's the one I want. So to do that, I have already typed out here what I need. So let's go back to terminal and put that in. So we're doing aim migrate, and then we're passing in an argument, which is the name of the file and primary region. And then we have this unique deployment ID I mentioned earlier. And the reason we need that is some of the artifacts that get deployed in Azure are globally unique. Well, they have a globally unique name. So for example, Azure API management or a storage account or app configuration. Their names form part of a DNS entry. So you can't have more than one. So because of that, we need a way to make sure that if somebody else is running this tool and they happen to have a BizTalk application with the same name as you, then if there's no way of differentiating them, you'll both try and create, say, a storage account with the same name, and one of you is going to fail. So this lets you put a unique suffix on the end of every resource name so that you know it's yours. And it's kind of a way of defining a server group as well, because every other migration that you do that has the same deployment ID will go to the same deployment. And we'll talk about that later, that there are certain core resources that are common no matter how many applications you deploy. So we run this, and the tools start running, and we get lots of lovely output in the logger here. It's going to run all the plugins across it, and in a second it will be done. There we go. That's how long it took to effectively migrate a BizTalk application. Admittedly a simple one, but it's generated 312 template files. So that's a lot, and we'll talk about why there's so many in a bit. But if I come out here, I can see there's an AIM 12820 folder, and that's where it's put everything. And I can come up and find that AIM 12820, and in here is the report and some other folders. And in the report, if I open that up, it's made up of a number of files, but in here, I can see information about my BizTalk applications. I've only got one of them because I only did one MSI, and then what it's going to put out the other side. And then also message bus and system application. So message bus is a core application that contains your app config and APIM and things like that. System application is akin to the BizTalk system application when you install BizTalk, and it's got pipeline components in there like JSON encoder and decoder and things like that. And then the actual application I'm trying to migrate. What's important to understand is that if I do 5 MSIs, I'll end up with 5 applications here, but only 1 system application and 1 message bus. That's why I say it's a bit like your BizTalk server group. And if I do a completely separate migration, I run it and deploy, and then in a week's time, I do another MSI separately, but it has the same unique deployment ID and it's going to the same region, and I'm deploying to the same subscription. That will reuse the same message bus and system application, and we just add what's needed for the application. And if I can jump in here and I can start to see what's in here. Look, I've got a send port and it's using FTP, and here are the properties of it. And I can use up here, I can come down to the output application and look in here and see what's inside. So the report's actually quite useful on its own, even without doing a migration, just to document your BizTalk estate. Alrighty, so now I've done a migration and I've got a report and I've got some output files. Let's talk about what those output files actually are. What do we generate? I talked about a message bus, system application, and whatever application we have. In message bus, we've got like a config store and routing store, the app config to store configuration. Artifact store, it's the integration account. APIM is used mainly for caching, but also decoupling functions and the app config from the logic apps. Key vault and storage, there's a routing slip router. If you're not familiar with a routing slip, it's also known as an itinerary and says I'm going here and then here and then here. And it's what makes all this so powerful, because all the bits and pieces in here are wired up via config. So if I want to say my pipeline is now using a flat file encoder or decoder, I can just change configuration and it will start working. You can sort of do that in BizTalk, but not with as much flexibility as you can here. And then the system application has things we recognize from BizTalk, you know, service bus, JSON encoder and decoder. Sorry, service bus is the message box, I should say. We're using topics to replicate the message box and subscriptions. But JSON encoder and decoder, flat file decoder, content promoting, you know, taking using a property schema to take a value out of a message and promote it to context. Content demotion, how many of you have done this? Taken a value from context and demoted it into a message. XML processor, which handles promoting the message type and envelopes and stuff. You know, there's all the stuff here that's from BizTalk effectively. And then your application, and you'll generally have a receive port and send port. Topic subscriber, if you think about a send port, it subscribes to a message and then it runs through a pipeline or a map and then a pipeline and then actually sends it. So in this case here, they're split into 2 separate things because the topic subscriber subscribes to it and then it runs through a route, through the routing slip to say, well, where do I go next? And will eventually end up at the send port. Process manager, which is an orchestration. So the pattern for an orchestration is known as process manager, and then API connections. So let's do a demo of deploying to Azure. As mentioned earlier, what we end up with, sorry, I've jumped a little bit there. What we've ended up in a folder here is a whole of artifacts. So in the conversion folder here, we have a deploy all and a tear down all script, and they're PowerShell scripts. And then under applications, we've got, say, the system application. And if we go and look at intermediaries here, we have all those logic apps I talked about earlier, say the JSON decoder. And in there, we've got an ARM template for the logic app and a parameters file, and then a number of PowerShell scripts that, you know, either deploy or tear down that. And all at the top level, all the deploy all does is run every single PowerShell script in order. But it does it using the Azure CLI, which means that it assumes you've already installed the Azure CLI and you've logged in and you've selected the correct subscription. And I know people that haven't done this and it hasn't worked. And you end up with what's called the wall of red, where something fails earlier on. So if we talk about the Azure CLI just for a second, if you haven't used it, I've installed it here, but you know, we'd go AZ login to log in, and it pops up a browser window and asks us to select our account in a second. There it is. And then I have to go back here and it will give me all the subscriptions I have access to as JSON. It's, you know, not entirely user friendly. And then I can use Azure account set -s and give it a subscription ID to set the default one. You have to do all this before you run the PowerShell file, and so it's not particularly intuitive. We were doing some work with the product group a few weeks ago on writing a script to run to show you whether you've met all the prereqs, like have you got the Azure CLI installed and things like that. So what I've had to go doing for this demo today is actually taking that idea and applying it to the deployment script. So I did it on an earlier one, this one here, version, and now there's a batch file. And if I run the batch file, it's going to take me through to this. So it will, and I'm going to speak to Microsoft about getting this into the open source repo, because this is kind of cool. So it'll take you through, first of all, is the Azure CLI installed and can you log in? Have you selected the subscription? Because the last thing you want to do is try and deploy to a production subscription. Is the Azure the app configuration resource provider registered? This hit a lot of people who are, hit me as well. First time you've run the tool, if you've got a new subscription, by default, a lot of the resource providers that ARM users aren't enabled, aren't registered. And when you're using the portal, if you go to say create a logic app, the first thing the portal will do in the background is register the resource provider if it's not there before it goes to deploy an instance. But with app configuration, if it's not registered and you try and deploy it from a script, it fails because you're supposed to register it from the script first. So what this is going to do is check if it's registered, and it'll also check if you've got a free app configuration instances deployed. You can only have one per subscription, no matter what it's called. And with integration accounts, you can have one per region. So if you've already deployed app configuration and you run the deploy all script, it will fail early on, but then keeps running and you get all this red. So this will check to see, are you going to have an issue? And if you do have a free one registered, you've got two choices. You can either deregister it, or you can change the SKU that this deployment script is going to use by going into the ARM templates, or you can change the name by finding the name of the app config instance and using something like Notepad to do a find and replace. One of the things that we talked about with the product group that would be a nice feature would be if you could supply a file or parameters at the beginning saying, I've got an existing app config and this is the one I want to use, and you supply the name, but that's not there yet. Right. The other thing to bear in mind is the first time you do a deployment, it's going to take at least 45 minutes. That's because API management takes over 25 minutes to provision. And when it gets to API management, it will look like the script is hung. It just sits there for 25 minutes until it's finished. But it's all right. If you did cancel, if you did just close the window, it would keep deploying in the background up on the cloud. And when you rerun the script, because all the ARM templates are using incremental mode, it means it will ignore anything that's already done and just keep going, which will make things a lot quicker. So if I press any key to continue, it's going to check if it's installed. It's going to bring up this window again to log in. OK. You can see it checked to see if the CLI was installed and tell me what version. It now gives me a list of the subscriptions I have access to. If I only have one, it will skip this and keep going. I've got two, and it gives me their names. It's a little bit nicer than the JSON, although it's not laid out nicely because I made the text too big for this demo. But I can push enter because I want to use the default one here. This is the subscription I want, so I'll push enter. Then it is going to check that the resource provider is registered. It is. It's noted that I do have a free SKU app configuration that's been deployed by the tool, and that the unique deployment ID used for that one is BTS. So it's basically saying that when I run this tool, when I ran it to generate these scripts, if I didn't use BTS, I'm going to have a problem. But I did use BTS. And then also that I haven't got any free SKU integration account instances. So would I like to continue? Well, yes, I would. And then off it goes. So now it's going to start doing all the deployment. And it says here what subscription it's deploying to and what ID. And then off it goes. And now it's going to run, those 312 deployment files, which will take a while. I'm going to kill it, though, because I happen to have already done the deployment. I didn't want to wait 45 minutes because that's how long this session is. So I have deployed this already. And if I come up here to Azure, I will find under all my resource groups, one of these here is this one here. So aim.ftp pass-through was the name of the application, and that becomes aim-ftp pass-through. And in here, I'll find some API connections. I'll find a FTP receive adapter, an FTP send adapter, and a topic subscriber. Now, if we look in the receive adapter, most of these follow a similar pattern. I've got to say, these logic apps, I quite like the way they've been done. It's using the file connector trigger, the file system connector trigger. It's got some boilerplate variable stuff happening here. What's kind of cool about this is it's using a pattern called checkpoints, which means that instead of having, an action and then a decision and then inside there another action or a scope and then drilling down, sometimes you go into a logic app and you can't see anything until you start expanding. Here it's brought everything up to the top level, and a checkpoint is set and checked at each level. So, checkpoint should be null at this point. And it does its work and sets a checkpoint. And then here goes, well, is the checkpoint set to the value that this would have had it to? If not, then I'm skipping. If it is, I'll execute. And then we run all the way down till we get here and check, were we successful? And it makes it easy if you have to, say, do a resume. If I had to resume into here and skip over actions I've already done because they can only be executed once, it's a really nice pattern. But one of the cool things in here is that the file system connector does not support file masks like BizTalk does. I can say an FTP or file in BizTalk that I want to get, star.csv or employee star.csv. What happens here is that file mask gets converted to some regex. So it creates some regex and then executes that regex over the metadata it's got from the trigger, and then decides if it's actually going to go and get the file or skip. That's brilliant. So that's how that was implemented. So it's a way of implementing BizTalk features in code in logic apps. Alrighty, so we have deployed that logic app, and in fact, if we have a look around what's been deployed here, I can go back up to the resource groups here, and I can see there's a message bus resource group, and in there is our API instance and API management and app config and functions and our integration account. And in fact, in our integration account are the schemas and maps from the other samples I've uploaded. In fact, if you've got a BizTalk MSI with 300 schemas in there, this will generate the scripts to upload them for you, which is quite nice. And then, there's the system application one here where you've got there's other logic apps we looked at, like JSON encoder and decoder, and they all follow a similar pattern. All right, so that's how we do a deployment. Moving back to the presentation, let's talk a little bit about orchestrations. So orchestration migration is a tricky thing. Orchestrations are complex. These are all the different things we have. Port types, correlation types, multi-part message types, send ports, receive ports. And then we've got the shapes, call orchestration, receive, send, message assignment, loop. Some of these make no sense in Azure. A scope with a transaction type of atomic, how would you do that in a logic app? So some of these won't really ever be supported. But if we look here, these ones that are shaded are the ones that are supported today, and the other ones are not. So variables are supported. All my variables will be brought across to a logic app. A decide shape will be message assignment, transform. The expressions are brought across even though they don't run, and I'll show you those. So that's kind of cool. So there is limited support for orchestrations, and it's a good starting point. And in fact, I did a webinar. We did one of the BizTalk Migrator Live, similar to Logic App Live sessions on Thursday, this last Thursday with the product group, talking about this in greater detail. But if I look at a demo here, orchestration migration, if I show you a simple orchestration, this is one of the scenarios that comes with the tool. We have a single port type here, request response. We receive a message, we have a construct shape, we transform it, and then we send it. Couldn't get more simple. We've got two messages here, and in here we've got some schemas, purchase order request and response, and then we have the corresponding messages defined. Now I've already uploaded that to save time, and if I show you what that looks like, that is sitting somewhere here. Here it is here. So purchase order processor sitting right here. If I open that up, this is the logic app that was created from that orchestration. So it's subscribing to the message bus. This is equivalent of the receive shape. There's some boilerplate here, but the actual conversion stuff starts where we see these numbers. And the numbers are indicating that's an order in which things are done, because when they build a process manager here, an orchestration logic app, they're built out of snippets. It's quite funky. They're, you know, the logic app is built by pulling together lots of different pieces and then, you know, setting up the run afters and stuff. But the actual work for the orchestration's here. But here's the two messages that are being defined. You know, they're XML messages, sure, but they're objects here. And then in here we've got a bit of boilerplate about decoding the service bus stuff, and then the construct shape is here, and then the transform. And here's the transform. We're executing a transform here. And then we've got a send coming down here, and the send does a few things that BizTalk does for you under the properties. So promoting properties for you under the hood. Sorry, BizTalk does this for you, and then we publish the message to service bus. So that's the orchestration. What about a slightly more complex orchestration? So I have one here, and I'll show it to you. You know, it's got lots of variables. It's got some expression shapes with C# in them. And it's got a scope with an exception handler and some decision shapes in here as well. Now, I've already run the tool over, converting that. What if you just wanted to deploy only that orchestration and no more? Well, you can come down into here, find the application. So I would go to applications, I'd find the one for this. I'd go into intermediaries, and I'd find the folder for that orchestration. It's called complex org. And in here, I've got an API connection and a logic app. So I can just run the deployment of I can execute the PS1 files here that have got the numbers in them, and that will deploy just these. So if I come out to here, I've already got these set up, so let's deploy the API connection, and off it will go. Now, because I've already done an Azure CLI deployment, it knows the subscription I'm connecting to. But obviously, if I'd never done it, I'd want to make sure I'm deploying to the right subscription. So it's going to run ahead and do the API connection first. And these are generally quite quick. And then it's going to do the orchestration after that, or the logic app after that. Well, I'll have to manually tell it to do it. But you can do these manually. There we go, it's done now. You can deploy just parts of these. And bear in mind that these scripts, although it gives you everything, really the idea is that you put them into your own DevOps pipeline or GitHub Actions or something like that, you know, depending on how you do your deployments. Alrighty, so that's now deploying that, and we'll end up with something that looks very similar to this. Whilst I'm waiting for that, I will just say advanced concepts I'm going to look at quickly. How do you change the route? So if I wanted to, in a pipeline, insert the flat file decoder, how do I do that? And how do I change the configuration? And how do I refresh the cache? So we'll come back out to here, and hopefully, yep, it's deployed the orchestration. I'm calling it an orchestration, it's not really, it's a logic app. But if I find that it's here, and here we go, these are the two things I deployed, and here's the logic app. And if we scoot through this really quickly, like I say, there's a lot to cover, and I'm aware of the time. In here, we've got similar things going on. We're, you know, subscribing to message bus, we're initializing, and then down here suddenly we've got all these variables we defined. So look, orc name, and that's got the same value that it had in the orchestration. Cool. And if we come further down and go into here, we'll find the scope here, the exception scope, and in there we've got an init shape. So if you remember in the orchestration, there was an init shape up here, initialize, it's an expression shape. And that's been, oops, sorry, wrong place. That's been converted to JavaScript shape. And in there, it's got all the code, but commented out. So if you could run that code, uncomment it, but you'll have to do some work to do it. But anyway, there it is. There's the orchestration. The decide shape is down here. You know, it's all been done. In terms of config and routing slips, if we step back out of here and let's cancel out that. I want to go to API management, sorry, app config. That's all right. Don't mind doing that. So app config is where we store everything to configuration related. We go to Configuration Explorer, and we have an entry per what's called scenario. And a scenario is, receiving from a receive port and going to the message bus, message box, or message box to message box, like an orchestration, or message box to a send port. That's a scenario. In this case here, this is the FTP receive one, and there's always 3 entries: configuration entry, routing properties, routing slip. So we'd want to edit the routing slip. So we could come away to the end over here. It's not wanting to scroll. And this is a horrible editing experience because it's a text box with JSON in it. So I always bring it over here to Notepad++, and I will format it. And then let's say we wanted to add in a route. This route here is saying, well, when we've received the file, we want to promote various properties, specifically the message type, but also like the receive file name and stuff that's done for you by the adapter in BizTalk, and then publish it to the message box. But I now want to add in support for the flat file decoder. And I can do that by the resource idea here is it looks up the callback URL for the logic app on the fly, the secure endpoint. So all you need to do is include the resource group name that logic app is in and the name of it. And I know that is called flat file message processor, and then flat file up here. Now, if I was to run this route again, it's now going to call the flat file message processor. It will fail because it needs config as well. I have to go back to the config editor and here and edit the configuration entry to specify what the name is of the flat file schema you're using. But that's how you do it. One thing to bear in mind is when you change these, they don't automatically update in API management. And the reason for that is API management caches things. And you can actually make a call. You can clear the cache by making a call to, say, configuration manager with a scenario name, and there's a parameter clear cache that you can set. But what I did is I cheekily set up another logic app with event grid, which will look for changes in app config and then make that call. And again, this is something I'm going to try and get into the source control because it's quite useful. It means you can change config and it's automatically refreshed. Alrighty, so what's next for the tool? What I'd like to see, and this is up to the product group, support for the new dedicated runtime, function app running on function apps. Sandro did the previous session to this. Sandro was talking about that. It would be awesome to see support for that. Improved performance. Performance could be better. We're looking 20, 25 seconds to pick up a file and send it out again, which is not as good as BizTalk, but then it scales better. If you do 1,000 files through this thing, it'll still take 25 seconds. If you did 1,000 files through BizTalk, I guarantee you it will take longer. More adapters, MQ, SAP, SQL, WCF, better orchestration support. Business rules engine and BAM would be lovely to see. I don't know how we'll do it. How Microsoft would do it at least. Right, so last thing is please go to that survey. The product group would love you to. They want to know what else you would like to see. They've got to decide where they want to take this tool and how do they get community involvement. Ideally, we'd have people writing open source plugins for this and get people getting involved. But please, get involved with it. That's it. I feel like I rushed through that a little bit, but there was a lot to cover. If you have questions, please reach out to me. ProBitDaniel on Twitter or ProBitDaniel on LinkedIn, and I'll happily answer questions. And please enjoy the rest of your day and enjoy the rest of Bootcamp. Thank you very much for coming today to my session. Thank you. Goodbye.
Thank you. Right, done.
I'm in the mountains. Well done.
Well done.
I didn't realize, so just for people that didn't realize, I recorded that session and uploaded it because I wasn't sure. I was going to do a live install, so everything was going to deploy, but because it takes 25 minutes or 45 minutes, I didn't want to spend my entire session watching a spinning wheel. So, but I didn't realize that we'd have a problem with the quality of text and things like that. So if there's anything that people couldn't read, then I guess downloading this session, Steve Jan, is going to be the right thing to do. or watching it
Yeah,
later?
I think it's going to be put up. At least we got the recording, so yeah, it will be put down somewhere downloadable, or so no worries.
Awesome. Okay. All right.
Quite be following because I kind of knew what you're all doing, and it's easy to follow. So even when the lines or words have been blurry, still it was. Well, from my monitor, right? I don't know what the setup will be of the audience, but yeah. For me, it was easy to follow. But yeah, it's
okay.
No worries.
Well, I guess I'm just here in case anyone had any questions, but I haven't seen any questions on Discord or YouTube. But if anyone did have any, you can ping them now, and I'll answer them live in the next few minutes we've got. But
yes.
One of the things I was difficult to see was the deployment script changes I made that I thought was pretty cool, that you could double click a batch file and it'll run you through the Azure CLI, checking if it's installed and everything like that. That's pretty useful because a number of people have hit that if you're coming from a BizTalk background, you haven't done a lot of work in Azure, and maybe you're used to using the portal for doing deployments, or I don't know, maybe you create an Azure resource group and then you port that to DevOps, and either you set it up or someone else does. You might not be familiar with the Azure CLI and then deploying from a PowerShell script that way. And I know that's caught, speaking to the product group, I know of at least one person using the tool who accidentally tried to deploy the migrated solution to their production subscription because they didn't realize that when they were using the CLI, they had selected the wrong subscription. Hence the point of making it, a bit more user-friendly for people that are new. One of the things I was planning to add to that script is an override, so that if you are a pro user and you just want to use the same script, but you don't want it to pop up saying, please choose a subscription and everything like that, you've already done all that and you just want to run the PowerShell script, you could run it with a special parameter, so it would just run. But yeah, the main thing is please vote on what you want to see, what you want to see next. Yeah. What do you want to see, Steve Jan?
Good question. Well, the thing is, I don't work that much with BizTalk, and some of my later projects are all cloud native.
Yep.
And potentially in the near future, it might be interesting because there are some few customers that are going to move to the cloud eventually, not now, but in time. And I definitely feel that by that time, your tool, at least the tool itself, will be pretty much mature and enable and help those customers drive their, or at least migrate their solutions to the cloud. Because there are quite a few ones, I believe, that can definitely benefit from this solution instead of just doing it, completely greenfield, chuck everything away, just remodernize and re-architect everything. If you leverage some of those investment with your, with that tool, it will be definitely valuable and an enabler for some of the companies say, okay, I do want to move to the cloud, and hey, this tool can help me. And so it's a kind of modernization of integration, which is feasible using or leveraging what I believe you created it, right? Together with a few other people.
I will remain mute on that one, just to say that I worked with Microsoft on it.
Okay, cool. But anyways, you get the point, right? It will definitely be valuable.
Very much so. But the other cool thing about it, I know we've only got a minute, is that it's similar to like the ESB toolkit. It gives you a suite of integration tools. So even if you didn't migrate, the fact that you've got the routing slip and everything like that, you can build pipelines in the cloud. So if you want to build a solution in a cloud native solution that's flexible, config driven, and has built-in suspend queues and things like that, wait a little bit for it to get a bit more mature, but you could build that with what you've got today without even migrating anything. It's quite a good architectural background for doing integration, because there's a lot of things you have to write by hand, and there's a lot of patterns there that you could just reuse. So I think that's something that Microsoft are looking into as well. So
no, definitely good that you showed this with your recording. That's good, and I think when things progress, you'll probably, and that's my question too, you probably will do more sessions when things are updated.
Yeah.
In the future, so people can see what the progress is and what the value for them will be. Because I definitely think in 2-3 years time, there's going to be a lot of attention to this when people do feel that
Yeah, if you're file based at the moment and you're wanting to, you're mainly, you're moving files around, it works great today for doing that. And that was the intention, because 80% of BizTalk customers are just moving files around. Anyway, I think we're at time now, so.
Yeah, I'm waiting for the next speaker, which will do some nice, interesting. There she is. So thank you, Dan. And I'm going to add Deepti Goguri, if I say correctly. Hello.
Yeah. Hello, Jan and Dan. How are you?
Hi.
I'm fine. Thank you. Did I pronounce your name correctly? Deepti Goguri?
Yes, absolutely.
Okay. Spot on. Excellent. Well, if you like to share your screen as well, then, you can hit it off and tell us more about the wonderful world of SQL.
So, so I can just share my entire screen?
Yes, you can, because then
I can change the windows, right?
Yeah, it's all good. You can share it. Yep.
Okay. So
I'll add it to the stream. See, there you go.
Okay.
And you can talk and do your stuff, and I will go away for a bit. And
so can I go ahead and start?
Yeah, you can start, and we'll see you later. Take care.
Sure. Thank you. So hello, everyone. Good morning, good afternoon, good evening, depending upon where you are joining from. My name is Deepti Goguri, and first of all, I would like to thank Global Integration Bootcamp for giving me this wonderful opportunity to present here today. So what are we going to discuss in this session today? We are going to talk about the life cycle of a query in SQL Server. So this particular session, like everyone who is dealing with SQL Server or databases or queries, everybody you have to know this stuff, because once you know this stuff, you'll be better able to write your queries. So there is a lot of content to grab. So hopefully you like it. So let's get started. A little bit about me. I'm a database administrator with 7 years of experience in managing SQL Server and databases. I'm a Microsoft certified trainer and Microsoft certified solution expert. I did my master's in computer technology at Eastern Illinois University, and I do blog for dbanuggets.com. That's my website. And you can contact me on Twitter at dbanuggets. That's my user ID. And down below, that's my email address. I am very active on Twitter. So if you have any questions or if you wanted to connect with me, it will be an honor. You can always connect with me. And later, if you have any questions, please do not hesitate to contact me. So what are we going in detail in this session today? We will start with basics, the ACID properties, and how each and every relational engine should satisfy these ACID properties of transaction. And later, we are going to see the life cycle of a query for the read as well as the write transaction. Like while going through the life cycle of a query, we'll go ahead and see the different types of components we have inside the SQL engine. That's the relational engine components and the storage engine components. So internals, why should we actually care? Many DBAs developers, they work with SQL Server on daily basis, but they might not exactly understand what happens behind the scenes when we submit any query to the SQL Server before getting back those results on our screen. Knowing this information will really help you in identifying, like in knowing how queries are processed at each stage inside the SQL engine. It will also help you in tracking down the performance issues very quickly and fix them efficiently. It will also build you confidence while managing the databases as well as the SQL Server, right? It will also help you in convincing your coworkers or managers of why they have to take your ideas seriously, because by the end of this session, you'll come to know so much stuff, like whenever you submit any query, what happens behind the scenes, right? By knowing this information, you can definitely go ahead and give your recommendations to your managers and coworkers. So we all work with SQL Server, right? SSIS, SSRS, or whatever it may be, behind the scenes, queries will run onto the SQL Server, right? So the more we know about these things, the better we can understand how SQL engine and databases work. Let's start with the ACID properties, the basics. So what is this ACID? Every major relational engine, it can be SQL Server, Oracle, PostgreSQL, Sybase. All these major relational engines should satisfy the ACID properties of transaction. So what is this asset? A stands for atomicity. Atomic meaning a single unit of work. A single transaction can contain one operation in it, or it can contain multiple operations in it. Whenever we execute a query like a single transaction, either all of the operations in it should either complete successfully or none of them. Let's take an example of a store procedure. Inside the store procedure, let's say there are two operations in it, an update statement as well as an insert statement. Whenever you execute the store procedure, both of those operations should either complete successfully or none of them. Like if the update statement succeeds and if the statement fails inside the store procedure, the SQL Server should go ahead and roll back the entire transaction. That's atomicity. C stands for consistency. The data inside the database should always be consistent before starting the transaction and after completing the transaction. Let's take an example. I wanted to do an update statement on a table. And while I am doing that update, if something happens suddenly, right? If there is a power outage and if we had to restart the SQL Server, then once I restart the SQL Server, this particular uncommitted transaction should be completely rolled back, making my data in the consistent state. That's consistency. I stands for isolation. No matter how many transactions are running at the same time, each and every individual transaction should be independent of each other and should not be interfering with any other transaction. Let's take an example. I wanted to insert bunch of records into a table. And while I am doing that, none of the other transactions which are running concurrently at the same time should even know that I am performing this action. They should not be interfering with my transaction. That's isolation. D stands for durability. So once the transaction has been successfully completed and all the data that has already been modified should be made to the database permanently. Once the data has been made to the database permanently, even though if I restart the SQL Server later, this committed data should not be lost. That means there should not be any data loss. That's durability. So what components of the SQL engine will ensure this asset property? Atomicity is very easy to be ensured. It is taken care by the parse component inside the relational engine. Consistency is also very easy to be ensured. It is taken care by the parser and binder components inside the relational engine. Once the atomicity, isolation, and durability are ensured, consistency will automatically be ensured. Isolation is all about the locking mechanism. It is taken care by the lock manager inside the storage engine. Durability is the most toughest of all. It is taken care by the transaction log inside the storage engine. So let's go ahead and see a very simple example ensuring this asset property. Let's take a very simple bank transaction. Let's say I have a balance of $500 in my balance, which have an ID of 1, and I would like to send a $100 gift to my friend who have an ID of 2. This simple transaction contains two operations in it, right? The first operation is to deduct $100 from my balance, and the second operation is to credit $100 to my friend's account. So I can do this simple transaction multiple ways, right? Like I can use the online application, bank application to do it, or I can use the mobile phone application to do it of the bank. So I'm using the mobile application to do this transaction. Once I begin the transaction on my mobile phone, behind the scenes, SQL Server will also begin the transaction. It will go ahead and perform the first operation to deduct $100 from my balance, which will make $400. And the second operation is to credit $100 to my friend's account. But I suddenly see this on my screen. I am logged out of the mobile phone application and I see this alert saying facility is temporarily unavailable. Now, what has happened? I do not know. I do not know if I lost my $100 or if my friend has received any money. I'm very angry on the bank guys. So I immediately called my friend to ask if she received any money, which she said she didn't. So I have no other option except to call the bank customer service guys. So I was so angry and mad at the same time. And when I asked them, they said there was a severe thunderstorm and some of their SQL Server went down and they already restarted them. If this particular transaction is ensuring the ACID property, what should happen once they restarted the SQL Server? Let's go ahead and see. Once they restarted the SQL Server, this particular uncommitted transaction, which has been stopped in between, right? So this particular transaction will be completely rolled back, making the data in the consistent state. This particular transaction is ensuring the ACID property. Now how? Atomicity is ensured by rolling back the entire transaction. Consistency is ensured by reflecting $500 in my balance, which is the initial amount before beginning the transaction. Isolation is also ensured. Like, did you observe when the first operation SQL Server went ahead and deducted $100 from my balance? None of the other transactions have been interfering with my transaction, right? So durability is also ensured. I did not lose my money. My $100 is back, reflecting $500 in my account, which is the initial amount before beginning the transaction. So that's how each and every individual transaction of all these relational engines should satisfy the ACID properties of transactions. Now let's go ahead and see the life cycle of a query. This particular slide, it seems to be so complicated, but it's very simple. Let me explain. So if the life cycle of a query is divided into 3 different steps, the first step contains the components parser, binder, simplification, and the trivial plan. These components from the first step are very simple. They are very lightweight to the SQL Server. SQL Server doesn't require much like resources to process these components. It just need like table definition, query definition, those kind of little things. When you come to the second step contains the components load metadata, join heuristics, and search phases. Most of the metadata that it requires to process any query are gathered at this second step. When you come to the third step contains the components access methods, transaction manager, and buffer manager. Now, all these components from the third step are very IO intensive. Now, why I say that is because the buffer manager, the component, it have to go ahead and grab the pages from the disk subsystem to process those queries. So that is the reason why the buffer manager and the third step components are very IO intensive when compared with the first 2 steps. So the first step components and the second step components combinedly together known as relational engine and the third step components known as storage engine. Now let's go ahead and see how the life cycle of a query works behind the scenes when we submit a select statement to the SQL Server. So here we have a wonderful user who wanted to do a select statement onto SQL Server. Now, no matter what kind of interface he is using, he might be using a SQL Server Management Studio or Azure Data Studio or .NET Visual Studio or even a third-party application. No matter what kind of interface he is using, he should first get the secure network connection to the SQL Server. Now, how does he get that? There is something known as SNI, which is also known as SQL Server Network Interface. SQL Server Network Interface, it will use the Internet Protocol to establish the secure network connection between the SQL operating system as well as the client. The client is our user here. So SNI will be using different types of Internet protocols, like it might be using TCP IP, named pipes, or shared memory. No matter what kind of Internet protocol we use here, the process remains the same. So once a secure network connection has been established, the query that the user is sending to the SQL Server will be wrapped inside a tabular data stream packet, which is also known as TDS packet. This TDS packet is given to the SQL operating system by SNI. So once the TDS packet has reached to the SQL operating system will first identify the coming connection as a SQL connection and it will assign a SPID to it. You might be knowing the SPID. It's a server process ID from the SQL Server side. Whenever you use SP-Who2 or SP-Who in your management studio, you will see clearly those SPIDs speed number 67, speed number 94, those all the speeds are the active connections made to the SQL Server. So once the speed has been assigned, this particular tabular data stream packet, which is now at the SQL operating system, will be unwrapped, and that particular query is identified as a SQL query. And that query will be now sent to the first step of the relational engine. So the first component inside the first step of relational engine is the parser. So parser, whenever you run any query, if there are any syntactical errors, it will identify that as a syntactical error and throw back the error to the user. Let's take an example. I wanted to do a select star from a database, but by mistake, I have given select star from. In this particular component, parser should identify that as a syntactical error and throw back me an error saying it is syntactically incorrect. And variables are also declared here, like if you are using variables properly or not, those kind of things are identified here. And views are expanded here. For example, if your statement, like if your query is having any views in it, behind the scenes those views get expanded. That means the query text behind that view will be brought inline into the code you are sending. So basically they will get expanded. With all this information, parser will first put a hash on the query that we are sending to the SQL Server, and it will go ahead and check against the hash of the query plan inside the plan cache. If it finds the exact match, it will go ahead and use the same query tree for the execution phase. But what if it didn't find the same execution plan, right? It will go ahead and build the initial logical tree for the first time for that particular query. Once the parser component work is done, the query will be now sent to the binder component. The parser will just identify and validate the syntax of the query, but the binder is the one which will validate the objects. That means whether your tables, columns, whether they are valid or not. Those kind of things are checked at the binder component. And check user permissions happens here. Like if you are running any query, whether you have enough permissions to execute those objects or not. Those kind of things will be checked at the binder component. And data type resolution happens here. Like, for example, if you are running a select statement between two tables and you are using any union or clause between those two tables, the ordinal columns of those two tables should be matched in their data type. Like we are going to see this example in our demo. Aggregate binding also happens here. Like the sum, average, those kind of things are bound here. With all this information, the parse tree inside the plan cache is once again updated with this information, and then our query will be sent to the simplification component. Simplification name itself says it will simplify something, right? So if your queries, for example, they have subqueries in it, behind the scenes, no matter how many times you send any queries with having subqueries in it, behind the scenes, those subqueries are converted into simple joins like left join, right join, those kind of simple joins. And contradiction detection also happens here. Like if you are having any foreign key relation contradiction, right? Those kind of things will be identified here. And with all this information, once again, the parse tree inside the plan cache is once again updated, and our query will go to the trivial plan component. Trivial plan component is the last component inside the first step of relational engine. These four components are also known as pre-optimization stage. So the last component inside the pre-optimization stage is trivial plan. So if your query is so simple, right? Like for example, select star from a table or select star from a table with a very simple where clause, those kind of queries are treated by the SQL Server as very simple. This is how the SQL Server thinks. This is such an easy query. Why should I even go ahead and update the parse tree inside the plan cache that this previous component has been built? Instead that, let me go ahead and discard that parse tree that has been built inside the plan cache, and let me go ahead and create the trivial plan on the fly. because SQL Server, it doesn't cost SQL Server much at all to create these trivial plans. And by default, these trivial plans are not stored inside the plan cache. So that means it is not wasting any cache inside the plan cache. It is saving the cache for the more complicated execution plans. So once these trivial plan gets generated, if your query is so simple, that trivial plan will be used for the execution phase. But what if our query is not so simple? What if our query is so complicated with 10 tables in it and a complicated logic in it? Then in that case, SQL Server wanted to create a full execution plan for it. In that case, the query will be sent to the second step of relational engine. So the first component inside the second step of relational engine is load metadata. In the load metadata component, most of the metadata that it requires to process any queries are gathered here. Like for example, the index statistics and histograms. So what are these statistics? Statistics are the blob structures which are saved inside the system tables to describe the distribution of the data inside a column or set of columns or an indexed view. So basically, the optimizer will go ahead and use and trust these statistics to determine like how many rows might come out of a table or a column. Based upon that, all the memory grants for the queries will be released. So those kind of information will be gathered here. Auto create stats happens here. Like for example, you are very frequently running a select statement and you are searching on a column. If that column is not in the key column of an index, SQL Server will go ahead and create a statistics on that particular column because it wanted to estimate how many rows are going to come back out of that column whenever you use that column in your query. And SQL Server collation and Windows collation are checked here. Set options are also checked here. Like for example, if your query is having set XML on or off, set ANSI padding on or off, depending upon on or off setting, execution plan might be dependent. Now with all this information, the parse tree inside the plan cache is once again updated and our query will go to the join heuristic component. So what happens at this component? Let's take an example. For example, you are running a select statement between three tables and you are having joining in between those three tables, right? Let's say the join between A to B is filtering out around 50% of the records from the result set. And the join between B to C is filtering out around 90% of the records from the result set. In that case, SQL Server will go ahead and reorder the join in such a way that it will push back the join between B to C front of the statement and the join between A to B back of it. Now, why a SQL optimizer do that is because it wanted to grab the results as quickly as possible. With all this information, once again the parse tree inside the plan cache is once again updated and our query will go to the search phases. In the very next slide, I'm going to discuss what these search phases are. But for now, just remember that SQL Optimizer is a cost-based optimizer. It always want to choose the good enough plan instead of the best plan. Now, why is that? Because to choose the best plan, it will take so much of resources and it have to go ahead and analyze so many transformation rules that it will take so much time for it to get that good enough plan or the best plan. Instead of that, it will go ahead and analyze some of the transformation rules to get that good enough plan, which will be suitable for our query. So, so how the optimizer do that? It will go ahead and get that execution plan information from these three phases: phase 0, phase 1, and phase 2. Once it finds that good enough information, it will go ahead and update that information inside the parse tree of the plan cache. And now our query will be sent to the storage engine component. But before going into the storage engine, let's see what these search phases are. So no matter what kind of query we are sending to SQL Server, Optimizer has to go ahead and get that execution plan information from these three phases. Phase 0 is also known as transactional plan. So these transaction plans are generated at the pre-optimization stage. Now, what is this pre-optimization stage, right? The four components we have seen inside the first step of the relational engine: the parser, binder, simplification, and the trivial plan. Those components will come under the pre-optimization stage. That means the trivial plans are generated here, right? These trivial plans are generated as quickly as possible and with the small queries with maximum of 3 tables in it. And very basic information is needed to process these components, right? Like the table definition, query definition, such kind of little things. When you come to the phase one is also known as quick plan. These plans are generated for the queries with maximum of 8 tables in it. And more transformation rules are needed than the phase 0. Now, what the optimizer does is for these phase 0 and phase 1 is it will go ahead and compare our query with already existing execution shapes. If it finds the good enough plan, it will just go ahead and grab that good enough plan for our query. But that is not the case with the phase 2. Phase 2 is completely different. Phase 2 is known as full plan. These execution plans are created for more complicated queries, and most of the parallelisms, spills, and spools to the TempDB happens here. That means more and more resources are needed to generate these execution plans. All transformation rules are unlocked here. And like phase 0 and phase 1, optimizer will not go ahead and compare our already existing execution shapes. But instead, what it does is it will go ahead and uh, prune off all the transformation rules we don't want. Let's take an example. For example, we are running a select statement which do not have nvarchar max data type or blob data types. Then first the optimizer will go ahead and prune off all the transformation rules which are related to the nvarchar max and blob data types, such that it can go ahead and very quickly analyze some of the transformation rules to get that good enough plan information. That's how the optimizer works. Now our read transaction is at the storage engine. Storage engine meaning the disk subsystem, right? So there are three components inside the storage engine: access methods, transaction manager, and buffer manager. So before going into detail about this, let me retell one more time. Like no matter what kind of query it is, the query should pass through the first step or the second step and come to the storage engine. If our query is very simple, like select star from with a simple where clause, then the trivial plan gets generated at the first step of relational engine, and that trivial plan will be used for the execution phase. So it will come to the storage engine. But if the query is complicated, then it have to pass through the second step of relational engine and then come to the storage engine. But all the difference happens at the storage engine component for the read and for the write transactions. The difference is at the transaction manager and the buffer manager components. Now let's go ahead and first see the read transaction and then let's talk about the write transaction. Access methods, the first component here inside the storage engine, it doesn't perform any action, but all it have to do is to analyze how it have to grab the results from the disk subsystem. That's all it does. When the query reaches the transaction manager component has two subcomponents in it: the log manager as well as log manager. As this is a read transaction, we do not write any data, like we do not modify any data pages inside the buffer pool. So the buffer manager have to first go ahead and invoke the log manager part of it. Because it's a read transaction, transaction manager will go ahead and put a shared lock on the resources it needs to process the query. Now, why shared lock? Is because this is a read transaction and we do not want to interfere with any other transaction, right? So once the query reaches the buffer manager component will first put the shared lock on the resources it needs and go ahead and check if all the resources it needs are already inside the buffer pool. If it didn't find some of them or any of them, it will go ahead and update that information, like get that information in the form of 8 KB pages, put them in the buffer pool, do the operation over there, and send the results to the user. That's how the read transaction works. So it's very simple, right? But it's a little bit different with the write transaction. So what happens with the write transaction? Access methods by itself, it doesn't perform any action, but all it have to do is to analyze the results, like how it have to grab the results from the disk subsystem. Transaction manager, once a query reaches here, transaction manager now it will first invoke the transaction log part of it. Why? Because this is a write transaction. Any modifications that we are doing onto the database, they won't directly go ahead and update that on the disk. They have to they have to grab the pages from the disk, put them in the memory, the buffer pool, and do the operation over there. And later down the after the commitment of the transaction, then those pages will be written back to the disk subsystem. So before writing anything into the database pages inside the buffer pool, those modifications should be first written to the transaction log. So first, those modifications will be returned to the transaction log. Now, why? Because if something happens suddenly, right, like power outage, once we restarted the SQL server, this particular transaction log will be helped to roll back the entire transaction to its original value. So once the changes has been written here, then the transaction log will be going ahead and requesting the buffer manager to put the exclusive lock on the resources it needs to process this particular query. Now, why exclusive lock? Because this is a write transaction. We do not want any other transaction to be interfering with my transaction. Again, the ACID properties which we have discussed earlier, right? So once the query has reached to the buffer manager component, buffer manager component will go ahead and first put the exclusive lock on the resources, and then it will go ahead and check if all the pages are already inside the buffer pool. If it didn't find some of them or any of them, just like the read transaction, it will go ahead and grab those pages in the form of 8 KB pages, put them in the memory, do the modifications over there, and send the success message to the user. But did you observe something here? The data has been already modified inside the database files in the buffer pool, but they are not yet hardened to the database file system, which is on the disk, right? That's when the checkpoint process kicks in. Checkpoint process is a process which will be kicked in by the SQL Server automatically every couple of minutes. So what it does is it will go ahead and grab all these written data inside the data pages, which are also known as dirty pages because they are already written, right? So it will go ahead and grab these dirty pages and push them back and harden them onto the database file system on the disk. That's how the write transaction works. Now let's go ahead and see a very quick demo. It will be real quick to show you how the pre-optimization stages works. The parser, binder, simplification, and the trivial plan works. Let me go ahead and share my management studio. So we are using AdventureWorks 2016 database for this demo. Let me first show you how the parse only option works. So to show you, I have to set the parse only option on. So whenever I turn the parse only option on, it doesn't produce the results or it doesn't generate any execution plan. It will only go ahead and check if there are any syntactical errors. So let me go ahead and run this very simple select statement, which do not have any syntactical errors. So when I execute that, see, it did not produce any results, but it says command completed successfully. There are no syntactical errors. Let me go ahead and show you like the variable part. I did not declare the variable, but instead I used it in the where clause. So when I execute that, this is syntactically incorrect, right? So it should throw me an error, says must declare the scalar variable. Let me go ahead and run this select statement with select non-existing column from a non-existing table. So there is no column, no table with this name. So when I execute that, it should not throw me an error. You know why, right? Because parser will just identify and validate the syntax. Syntactically, this particular statement is absolutely fine, but objects are not valid. That's when the binder component will kick in, right? Binder should identify that. But this set parse only option will only kick in the parser. So let me go ahead and turn that off. Let me go ahead and turn set format only option on. Now this particular option, when I turned it on, both the parser as well as the binder components will kick in together. This particular option is deprecated, but for my demo and until they completely remove it, we can still use it to parse and bind our queries, right? To check for the objects validation. So let me go ahead and run this select statement. Syntactically, it is perfect and all the objects are valid. So when I execute that, it doesn't produce any results or it doesn't generate any execution plan. Now let me run the same query, select non-existing column from a non-existing table. But this time, as the binder component kicked in together with the parser, it should throw me an error, says invalid object name. Let me go ahead and turn that off so that our queries will run and produce the results. Let me go ahead and show you the data type resolution error, right? Here we are running a simple select statement between two tables and we are using union all clause between those two tables. The ordinal columns should match in their data type. The customer ID is of an integer data type. The sales order ID is also of an integer data type. So both are matching, right? So when I execute that, it should produce the results. Now let me manually create a contradiction. Here the same query. The customer ID is of an integer data type. The credit card approval code this time is of a different variable, different data type, which is of varchar. So these two are not compatible. So it should throw me an error. Conversion failed error. So that's how the parser as well as the binder components occur. Let me show you how the simplification and the trivial plan component works. I'm using the same AdventureWorks 2016 database. Now, simplification, as I told you, simplification will simplify the query by converting those subqueries, right? So this particular simple statement has subquery in it. So to know how does that convert into simple joins, we have to enable the actual execution plan on. This is the button inside the management studio. When you execute that, go to the execution plan. Here, did you see that it automatically converted into a simple inner join? That's how the simplification component works. Simplification will also remove any redundant joins in the queries. Like here, if you observe, here we are only getting the values from the sales order header table. All the values are from only sales order header table, but we are simply using the customer table here. We are not getting any values from customer table, right? So when I execute that particular query and go to the execution plan, it will only grab the results from the sales order header table. It did not use the customer table at all. But if you observe here, for this query, this is a left outer join, so it doesn't have to use. But for any other joins, for the right join, if we are not getting the results from the other table, then SQL Server will first go ahead and check if these two tables are having relationship between them. If they are having the relationship between them, then SQL Server will just go ahead and remove this redundant join from the execution plan. But what if those two tables are not related, right? If they are not related, then SQL Server will just go ahead and check that second table also to find the relationship between those two tables, because the joins should check for those values, right? So it will definitely use that table inside the execution plan. Now, how do the contradictions happen? Here, I manually created a contradiction saying where territory ID is equal to 1 and where territory ID is not equal to 1. So when I go ahead and execute that, it should not produce any results because at the it did not throw me an error too, right? Because at the pre-optimization stage, SQL Server doesn't know what these values are. So let's go ahead and see how the trivial plans are created. This is a very simple select statement where we are searching on the sales order ID column. So let me go ahead and execute that particular query by enabling the actual execution plan on. When I go ahead and check the properties over here, if you see here, the optimization level is of trivial. Trivial meaning SQL Server thought this particular query, this one, as very simple. So that's why it did not cost it much to create those trivial plans. So it will go ahead and create the trivial plan on the fly, and it will use the same trivial plan for the execution phase. And these trivial plans are not saved inside the plan cache by default. Because why? SQL Server wanted to save the same cache for the more complicated execution plans. It doesn't want to save these simple trivial plans. But if you are expecting a query to create the full plan, but SQL Server is going ahead and creating the trivial plan, but somehow you wanted to save that plan inside your plan cache, I really do not suggest you to do this in production, because there is a reason, right? Why SQL Server just go ahead and create those trivial plans? Because it doesn't cost it much. So no matter how many times you run those queries, simple queries, behind the scenes, SQL Server will go ahead and create those trivial plans those many times. And it doesn't affect it much. But there is an option. If you enable the trace flag inside the query that we wanted to convert that trivial plan into the full plan, you can enable the trace flag 8757 inside the query. So if you enable this trace flag inside the query, it is only bound to that query. It doesn't affect the server or the database level. So let me go ahead and enable and run the same query one more time by enabling the trace flag. If you go to the execution plan, do the properties here and check the optimization level, the same execution plan is now converted into full. That means this particular plan is now saved inside the plan cache. That's how the trivial plans and simplification component works. Let me go ahead and share back my slides. So in the summary, in this particular life cycle of a query session, we have gone through the basics, right? First, we started with basics, the asset properties, and how each and every single transaction of all these relational engines should satisfy the asset properties of transaction. And we have seen with a very simple example, ensuring the asset property. We have also seen the life cycle of a query for the read as well as the write transaction, like what happens behind the scenes at each component inside the SQL engine. While going through the life cycle of a query, we have seen the different types of components in the SQL engine. That's the components of relational engine and the storage engine. These are the resources I followed to prepare my presentation. If you wanted to know more about internals and architecture and life cycle of a query, please follow these resources. And I would like to thank Integration Bootcamp, Global Integration Bootcamp, for giving me this wonderful opportunity. Thank you so much, Rob, for giving me the opportunity to present at your bootcamp. Thank you so much.
Yes, thank you very much. Rob is gone actually, so he had to do some other, so I took over. I'm also one of the organizers with many others.
Awesome. Thank you so much, Jan.
Yeah. No, it was very insightful. Me being an old database administrator, but going back more than 10 years. But it's very interesting, insightful. It's really deep dive, but I enjoyed it, of course, as an old DBA guy.
Thank you.
I think the audience might find it interesting too. What happens behind the scenes, definitely, because our audience, of course, some are still doing a lot of BizTalk. BizTalk, of course, relies on SQL Server. So hey, there you go. See, there's the connection. And going forward, I think we as integrators probably also have to deal with SQL Server somehow in its shape or form, whether it's on-prem or in the cloud with Secret Azure or managed instance or going forward. So
absolutely, because queries runs with SQL, right? No matter what kind of interface we use, right?
Yeah.
And the same SQL queries will run. So yeah,
no, very good stuff.
Thank you so much. I hope it is useful.
I'm also following you now on Twitter. So,
Oh, thank you so much.
Since you're saying, hey, follow me on Twitter if you need to know anything. So, people will definitely,
This is my at DBA Nuggets, same name as my website. So if you contact me later for the new sessions as well, you'll be in touch with me.
Yeah, sure. No, I think it's good. Also for the audience, if you want to reach out to Deepti, here again are the contact details, Twitter handles, touch, and email. Find our blog if you're really into SQL, I think. So I've also looked at your blog for, peeking a bit. So it's a lot of stuff there. So good stuff. Thank you
so much, Anne.
The other one is waiting as well. So add it to the screen. I will remove your
Thank
slide.
you. I'll stop sharing.
Yeah. I already did that for you. So no worries.
Thank you.
Thank
Bye-bye.
you. Bye.
Bye, everyone. Bye.
Hello, Felix, the last one.
Hello, the last one. Here.
Yes.
Here I am. I am prepared. When you want, I can start.
Yeah, sure. I already added it to the screen. So yeah, digital twins, interesting. So we're going to see an IoT session, I presume?
Yes, of course.
Excellent. That's also part of integration, I feel, at least my opinion. Integration also deals with connecting devices and stuff. And I think with the digital twin you're going to present, it's going to be in that direction, right?
Yes.
Okay, cool. Then the floor is yours, and I will see you later. Bye.
Bye. Welcome to a new Global Integration Bootcamp session. This session is advantage of Azure Digital Twins, build your digital twin from scratch, where I am going to introduce some basic concepts about Azure Digital Twin technology, and also we are going to build full Azure Digital Twin from scratch. Before, I want to introduce myself. My name is Felix Mondelo. I am industry first control manager for Travel, a consultancy company from Spain. I have been working since 2005 in integration solutions, mainly with BizTalk.
Okay, sorry to interrupt. Your mic is sometimes pulling away. So you speak up a bit. You're on mute now. You're on mute. Hello? You need to unmute. We cannot hear you. You're on mute. Sorry, you're on mute. I can't hear. Yeah. Now I can hear you again. Yes.
I don't hear you.
This is perfect. So now it's good, because before there was a lot of interruption. So
I don't hear you. You will hear me.
Yeah, I'm hearing you fine now. Can you share your screen again, and then we can continue? Yes. You need to unmute. You're on mute again.
Can you hear me now?
Now it's great. Yes. And now.
Okay. I threw up the mic and began another time.
Yeah, that's cool. This is way better. Yeah, you can share your screen again. Yeah,
yes.
No problem. We have the time. No worries. Okay, here it goes. Okay, you can continue. Excellent.
Yes. well, I have been working since 2005 in integration solutions, mainly with BizTalk server, and in the last years, I usually participate in integration projects with Microsoft Platform as a Service, with Logic Apps, Service Bus, and also in IoT projects with Azure ecosystem. The agenda for this session, we will begin with a brief introduction and context, where we will see IoT Microsoft portfolio, and we'll introduce the Azure Digital Twins technology. Then we'll continue with a high-level vision of Azure Digital Twins before talking about the details. First, we'll talk about how to define models for a twin with open modeling language, and I'll show you a short demo about how to create a simple model and deploy it on Azure Digital Twins. And next, we'll see these models working through live execution environment. And we also will execute another short demo where, after defining the models, we can add instances for that model in Azure Digital Twins. At the end, we'll develop a full demo with a simple scenario connected to whole IoT Microsoft ecosystem, devices, IoT Hub, Azure Functions, Event Grid, and so on. Okay, let's go. Let's start with a short intro talking about Azure IoT portfolio and introducing the Azure Digital Twins technology. Maybe most of you already know it, but this is for staging the technology what we are going to talk about today. From the Azure IoT solution software as a service perspective, we have IoT Central, that is a software as a service solution for small companies in order to help them incorporate IoT solutions quickly. We have the IoT accelerators, that is a kickstart your implementation of common Internet of Things scenarios like remote monitoring, industrial IoT, predictive maintenance, and device simulation. These are open source projects on GitHub that you can modify to adapt to your custom requirements. And also, in the Azure IoT solution, we have connected field services. Connected field services allows organizations to transform their services from a reactive model to a model proactive and predictive. This is possible with the combination of diagnostic with IoT devices, inventory, asset maintenance in the same platform. We can connect through IoT Central or IoT Hub directly with Dynamics 365 field service. Azure provides us with a platform as a service solution with several components. For example, Azure IoT Hub for managed devices, ingest data, and so on. Device provisioning service for provisioning new devices, adding them to IoT Hub. String analytics, Cosmos DB, and series insights. And here is the new component that we are talking about today, Azure Digital Twins, that adds new possibilities to the Azure IoT platform as a service. On the edge side, Microsoft has several tools to manage the work on the edge side. Azure IoT Edge, a fully managed service built in on Azure IoT Hub that allows us to move cloud workloads to run on IoT Edge devices via standard containers with Docker or Mobi. We can deploy modules with the desired functionality that we develop or from the marketplace. Also, we have here the Azure IoT Device SDK when we need new firmware on our devices to communicate with the Azure IoT ecosystem, and others, Azure Stack, Edge, Azure Services on the Edge, etc. Okay, then Azure Digital Twins is a platform as a service which allows you to create knowledge graphs based on digital models for full environments. These environments can be buildings, energy networks, farms, stadiums, even entire cities. We can use these digital models to get insights to boost better products, optimize operations, improve customer experience. So, With the use of Azure Digital Twins, we can create personalized and connected solutions to model any environment and build the digital twin in a scalable and secure way. Connect assets as IoT devices and existing commercial systems. Use a robust event system that allows us to create dynamic business logic and data processing. Okay, we have here the open modeling language. In Azure Digital Twins, you define the digital entities that represent people, places, and things in your physical environment using custom twin types, called models. We can think of these model definitions as a specialized vocabulary to describe your business. For a building management solution, for example, you can define models such as building, floor, and elevator. You can then create digital twins based on these models to represent your specific environment. The models are defined in a JSON-like language called Digital Twins Definition Language, and describe the twins in terms of their state properties, telemetry events, commands, components, and relationships. Models define semantic relationships between your entities so that you can connect your twins in a knowledge graph that reflects their interactions. We can think of models as nouns in a description of their world and relationships as verbs. You can also specialize twins by using model inheritance. One model can inherit from another. DTDL is used for data models in other Azure IoT services, including IoT plug and play and time series insights. This helps you keep your Azure Digital Twin solution connected and compatible with other parts of the Azure ecosystem. The live execution environment in where digital twins are live, up-to-date representation of the real world. Using the relationships in your custom DTDL models, you will connect the twins into a live graph representing their environment. You can view a visualization of your Azure Digital Twins chart with the help of a sample application, the Azure Digital Twins Explorer. Azure Digital Twins provides a comprehensive event system to keep that chart up to date with data processing and business logic. You can connect external computing resources, such as Azure Functions, to drive this data processing in flexible and customized ways. You can also extract insights from the live runtime environment using the powerful Azure Digital Twins Query API. The API enables you to query with rich search conditions, including property values, relationships, relationship properties, model information, and more. You can also combine queries, gather a wide range of knowledge about your environment, and answer personalized questions that are important to you. Inputs for this technology. To keep the Azure Digital Twins live runtime environment up to date with the real world, you can use the IoT Hub to connect your solution to IoT and IoT Edge devices. This hub managed devices are represented as part of their twin graph and provide the data that drives their model. You can create a new IoT hub for this purpose with Azure Digital Twins or connect an existing IoT hub alongside the devices you are already managed. You can also handle Azure Digital Twins from other data sources using REST APIs or connectors to other services like Logic Apps. The outputs. The data in your Azure Digital Twins model can be routed to subsequent Azure services for additional analytics or storage. This is provided through event routes which use the Event Hub, Event Grid, or Service Bus to drive the desired data flows. Some things you can do with event routes include Azure Digital Twins data storage in Azure Data Lake, analyze Azure Digital with Azure Synapse Analytics or other Microsoft data analysis tools, integrate larger workflows with Logic Apps, connect Azure Digital Twins to time series insights to track the time series history of its twin, align as time series modeling time series insights with Azure Digital Twins. This is another way Azure Digital Twins can connect to a larger solution and meet your custom needs for ongoing work with this knowledge. The following diagram shows where Azure Digital Twins stand in the context of a larger Azure IoT solution. Azure Digital Twins is commonly used in a combination with other Azure services as a part of a larger IoT solution. A complete solution that uses Azure Digital Twins can contain the following parts: the Azure Digital Twins service instance. This stores your twin models and your twin graph with their state and organizes event processing. One or more client applications that control the Azure Digital Twins instance by configuring models, creating topology, and extracting information from the twin graph. One or more external computing resources to process events generated by the Azure Digital Twins or connected data sources such as devices. A common way to provide resources is through Azure Functions, an IoT hub to provide device management and IoT data flow capabilities, top-down services to handle tasks such as workflow integration with Logic Apps and cold storage and so on. Then we are going to talk about open modeling language. Let's begin with the details of Azure Digital Twins. And first, we are going to describe the open modeling language, the language to define the models for digital twins. As we say, the models are defined in a JSON-like language called Digital Twins Definition Language and describe the twins in terms of their state properties, telemetry events, commands, components, and relationships. Models, they describe the contents, properties, telemetries, commands, relationships, or components of any digital twin. They are reusable and can be used as schemas for components of another interface. Telemetry are measurements, device readings. This data is not stored in the digital twin. It is data that pass through the digital twin. Properties are data fields that are stored in the twin. They can be read at any time. Commands, they describe a function or operation that can be carried out by the digital twin. Components, it allows to build interfaces to describe the model, example, a car, and allows them to be made up of other interfaces, example, wheels. Relationships, they define how our twins components are related to each other. Then here is an example of an interface. First, we have the digital twin ID. This must be unique. We have the type that in this case is always the value interface. A display name for the interface. And a set of values, telemetry, properties, commands, relationships, and other components of this model. And a last attribute is context, that in this version always have this value. Also, we have telemetry. Telemetry, the type is always telemetry, but we could include semantic value like temperature. The name is the name of the telemetry, and the schema is the data type. We could include other optional fields such as unit to indicate the type of telemetry unit, but this is the most simple way. Properties is very similar. The type is always property, but could include semantic value like temperature. Name, the property name. Schema, the data type. And we could include other optional fields such writable to indicate if the property is modifiable by an external source, such as an application. By default, it's not writable. Commands, the same, the type is always command, the name of the command, and here is the request, the description of the command input for this command, and also the response, that is the description of the command output. Both parameters have their own description through the command payload type. Also, we have relationships. The type is always relationships. The name, the target ID is the ID of the model to which the relation refers, and the properties of this relationship. This is optional and indicates if you have properties of the relationship. Other options such as min multiplicity or max multiplicity allows us to indicate the cardinality of the relationship. And finally, the components. The type is always component, the name of the component name, and the schema, the data type of the component. For more detail, we have a long documentation here in this link. Okay, well, now I will show a short demo defining a model and deploying this model to Azure Digital Twin. I have here my simple model. Okay, is this interface that contains a relationship and a property. To deploy this on Azure Digital Twins, we have to authenticate against Azure and then use a Digital Twins client. It's a SDK class that we can use in our code. To deploy this JSON file, I read the JSON file and invoke the create model async method. Okay. Then I want to launch this. Okay, now it's creating the model. And now I have added the model. We can see the model created here in the Azure Digital Twins Explorer. Here it is. On the left side, we have all our models in our digital twins. Okay. Okay, let's talk about the execution environment for Azure Digital Twins. Live execution environment allow us to create digital twins instance based on available models. We have defined these models previously through DTDL. With these instances, digital twins can provide a graph in which we can visualize the elements hierarchy, the relationships, and so on, using Azure Digital Twins Explorer. We also can query the digital twin with an SQL similar queries. I'll show you in the next short demo. Also, this environment provides us with a powerful API to launch queries against our defining model and get insights. The inputs come, as we show in previous slides, from IoT Hub, using REST APIs or connectors to other services like Logic Apps. In this environment, we can connect our digital twins with other Azure elements, Azure functions, to act on the data, transform it, calculate it, etc. The fitting it offers an API where we can interact with our digital twin through updates and queries. Storage and analytics is one of the most important parts of digital twins. Having the data outside the digital twin, we can redirect it through Event Hub, Event Grid, or Service Bus. With its native connectors, we can perform different interesting scenarios, such as having our analytics directly in a data lake, carry out a process with the data that is arriving through logic apps, or connecting with time series insights to visualize the historical data. Now I will show you a short demo where we are going to create instances from our digital twins and see with the Azure Digital Twins Explorer the graph that represents these instances and their relationships. I have to move this. Okay, now I go to create my model for this second demo. Is I have created an interface for a car device. This car have several properties like brand, model date, emissions, and number of airbags. And here in the program, after creating the model on Azure Digital Twins, I will create a twin with concrete data. Okay, this is my twin, my car, my Kia Sportage, with all the data that has my twin. We only have to use the same class, okay, the client with the method created digital twin async, and we pass the twin data for this new twin. Okay. Then I go to launch this. Okay, now we have if I run this, here is my car, and here is the model of the car. Okay, with all the properties, and here is my car with the data that I have added to this twin. Okay. Well, we are going to the final demo. I want to show you a full solution with digital twins, integrating with IoT Hub, Azure Functions, Digital Twins, and Event Grid. This is the scenario that I'm going to show you. I want to represent our company office, only the floor 2, that has 4 rooms, each one with a thermostat. And I want to reflect the real temperature for each room. Okay. To build this scenario, I need several devices that are the thermostat, an IoT Hub to receive the events from the devices, an Azure function that processes the telemetry events from IoT Hub and updates the twins. And when a thermostat twin gets updated, an event is published into Event Grid, and I have another function that is subscribed to these events to update the twins related the thermostat. Okay. Then I will show you all these things. I have here my subscriptions with Azure Digital Twins instance. It's very important here that you have in the access control, you need the role. Sorry about the delays. You need the Azure Digital Twins data owner to, because if you don't have this role, you can't query against the digital twin, and also you can upload any twin to your digital twin. I have also here an IoT hub with several devices. I have here my devices, okay, 4 thermostats. I will simulate it with a Node script because I don't have here the devices real, but I have here 2 functions that are these functions. One that gets data from the IoT hub and route the events from the IoT hub to the digital twins. This function gets the event from the IoT hub and gets the temperature body and invoke through the API to the digital twins and update and device with the temperature new value. And another function that is subscribed to the event grid that gets the updates on digital twins and look for the parent in the relationships and update the parent with the new temperature value. Okay. First of all, I have to deploy my models and my twins. I have a little program here. Okay, I have here my program that will upload the models and the twins. I have a model for a thermostat, a model for the space, room, and floors, and each one with several properties for our office's details. Okay. I'm going to upload all this data to my Azure Digital Twin instance. And now I can see here my graph. Okay, the floor, each room with a thermostat associated. This is the thermostat 767. This is the room 1. And now, what I'm going to do, I go to simulate the devices, each thermostat. These devices will connect to the IoT hub. The IoT hub will push the data. My Azure function, this Azure function, will read this data and update my digital twin. Okay. I have here several several Node scripts that will write data on the IoT Hub. Okay, if I go to Azure IoT Explorer, I can see this telemetry data for each. Oh. Now, these simulated devices are sending this kind of data to the IoT Hub. The IoT Hub is connected through events to an Azure function. The IoT Hub, you can modify here in events. You can connect an Azure function. In my case, I have created this subscription. To filter only device telemetry. Then when on the IoT Hub receives telemetry, we'll send to this Azure function. Okay, my Azure function is that the process hub to DT events. This Azure function gets the data, gets the temperature, and see the device ID and update my digital twins ID. Okay. Then from here, the digital twin has an event routes property. Here I publish an endpoint that is an event grid. And from this event grid, I have a route to send each update event to this grid. Okay. I only send updates to this grid. And now I have a function connected to this kind of events. Okay. Process DT route data. Then this function gets this data, looks into my digital twin for the relationship for these devices, and updates the parent for this device. Then now if I go to my digital twin, not only have the temperature here in my thermostat, but also here is the temperature. We have also the temperature here in the room. Okay. Now we can query this as a SQL database. We can query for which twins have a temperature greater than 20. Are all 25 or something. Maybe it's not. Well, it's not. Okay. Also, we can do more complex queries with relationships. Okay. Or even okay, we have only 2 rooms with the temperature greater than 27. Okay, we see this is 27.8 and here is 28.21. This is updating constantly because it's connected through my devices. Okay, they are receiving events from the devices continuously. We can see this on the functions. If I go to my functions, they are processing all the time these events. The hub, this function is which is connected to the IoT hub, and with each event from which each telemetry from the hub is updating the digital twin. Okay. This is updating the thermostat 53 with this temperature. Okay. And the other function is getting each event from the digital twin, each update event from the digital twin to update the parent of the devices. Okay, we are sending a patch to the parent to replace the temperature property. Okay. This is the schema that we have seen in this demo. The MyIoT hub in telemetry events is redirected to the process hub to DT events function. This updates my digital twin. The digital twin, with every update, launch an event to the event grid, and with another function, I get from the event grid these updates and update the parent for the devices. Okay. Well, then we have finished this session. I hope you have enjoyed it with this presentation, and I hope these explanations can help you to put in practice the use of this technology that is very young, because it's only a few months ago that is the final version of the Azure Digital Twins. Thank you to all.
Thank you. That was an interesting session, and it's good to see that you're talking about that it's more mature now. I did see some things around digital twin, I think a year and a half ago, and it wasn't so stable as you showed it today. So that was good to see.
Okay, great.
That was pretty excellent. So
yes, we are playing with this technology these days. I want to improve my knowledge on this technology. That is very young.
Yes, it is, but it's becoming more stable. It's definitely improved. Definitely. So that's good to see. I don't think there are many questions currently. Of course, they can go to Discord or approach you later on, right? So I think we're kind of at the end of the day. So I think there's a handful of people still watching, but no questions I can see. Yeah, what I would say to you, thanks for being the last person in this great event. Thank you for.
Thank you to the organization for this great event.
Okay, so yeah, I think we'll close it up. Thanks everyone also for watching globally. We started out beginning of this day all the way back into New Zealand, and then we transgressed all the way up to where we're now, including speakers even from the US, the other side of the pond. I would say stay healthy. Yeah, hopefully we'll be able to do Global Integration Bootcamp in person again next year. We'll see. But I would say virtually was a good success as well. So thank you, Felix. Thanks everyone else for chipping in and doing the sessions online. Audience. So I would say thank you.
Thank you.
Have a nice evening, weekend. Bye.
Bye.
Okay, so I'm also going to end now. Thanks again, everyone. This was the Global Integration Bootcamp 2021, which was the 5th, I would say, version of it. So we did it 4 times in person back in 2017. Now we're all up to 2021, virtual, but hopefully we'll be back, in multiple cities next year in person. We'll see. I would say have a nice weekend. Enjoy the weather. Enjoy the rest of the day, or maybe you're getting close to bedtime, or maybe to supper, or at least I am. So okay, thanks again, and goodbye.